Olá. Hello. Good morning, everyone. My name is Tiago Costa Mendes. I am co-chair of the organizing committee of the Dsie 2021, so the Doctoral Symposium in Informatics Engineering, together with my colleague Soraya Felicio. It is a pleasure to welcome you all to this 16th edition and the very first one in online format. This is different, so the format, but it's also curious. It seems that we're kind of pioneers in some actions. I can say that, for example, we will have today and tomorrow live broadcasts from diverse locations like Braga, Guimarães, Viseu, Albergaria Velha, and Belgium. So we have a wonderful program of 9 sessions and 26 presentations of research works in areas like machine learning, image graphics and interaction, software engineering, natural language processing, robotics, and artificial intelligence. DSIE is part of the Methodologies for Scientific Research course held by the Doctoral Program in Informatics Engineering, ProDay, at the Faculty of Engineering of the University of Porto. I am just one element of a team of 28 people, 2 professors and 26 PhD students that worked hard during the last 2 months to make this event. I would like to thank you, all my colleagues, for all your efforts and also for the patience to tolerate me. Without your contributions, this would not be possible. I also thank Professors Carlos Soares and Antonio Augusto Souza for their precious support and supervision. Likewise, we are grateful for the support of the Director of the Faculty of Engineering, Professor João Falcão Cunha, and the Director of the Informatics Department, Professor João Paiva Cardoso, and his team that have been very nice to us. And these directors that also honor us with their presence in this opening ceremony. We cannot forget the contributions of our sponsors. So Primavera Software, LTP, Wacaro, DAB, CTEL, Ripley, and Natixis. Thanks to them. I wish all attendants a great conference and excellent presentations to all authors. To go on with this opening ceremony, I will pass the session to the Director of the Doctoral Program, Professor Carlos Soares. So please, Professor Carlos Soares.
Okay, good morning, everybody. Thank you, Tiago. So I'd like first to welcome Dean of our faculty, Professor João Falcão Cunha, and also to the head of the Informatics Engineering Department, Professor João Cardoso, and thank them both for the availability. They have very heavy schedules, but still we're very happy that they were able to join us, at least at the welcome at the opening ceremony. I hope you'll be able to enjoy a little bit more of the event as well. I would also like to my colleague Professor Augusto Souza, who is actually does most of the support to the students in the organization of this event, as usual, and Professor Eugênio Oliveira, who is here with us, is the former director of the program and will be watching me very closely to see if I make any mistake and will punish me severely afterwards. No, kidding. I would also like to thank all participants and all organizers. I was very happy to learn that we have over 50 people enrolled in the event. That's very nice. Which means that a lot of the participants are not students, even though this is essentially an event for our students. And a very special thanks to the students who organized the event. We know that these are challenging times, and organizing an event such as this for people, well, even for people with experience, this is hard, but even more for first-year students. and I was very happy to see that they did this with additional creativity. So they faced additional challenges with additional creativity, which makes us very happy, of course. And I think you'll see that during the event. So as Tiago was saying, the SEA is part of the Methodologies for Scientific Research course, which for many of our students represents the first serious contact they have with research. So this is the let's say the ending of this process of learning of their first contact with research. And as part of this course, they have contact with some fundamental issues in science, like things like the scientific method, but also they have contact with more prosaic issues, even if they're still very essential, things like doing a literature review, learning how to do scientific communication, and participating in a scientific community, which means understanding the process of peer reviewing, understanding the process of organizing, and participating in events such as this one. So for this reason, this is of course a very important event for ProDay. It's always been and still is. That's why I would like to wish all a very fruitful event and also a fun event, because I think there will be very interesting things happening, especially tomorrow. So it will be interesting from a scientific perspective, but also I think that will be the organizers were able to set this up in a way that there will be possibility for some gathering, for some interaction, which will be very interesting. So thank you very much to Tiago and Soraya, who led this, and of course on behalf of all the team, which I've witnessed really dedicated themselves to this. Thank you very much.
Okay, thank you, Professor Carlos Soares. So I now would ask Professor João Paiva Cardoso, the Director of the Department of Informatics Engineering, to give some words to the audience, please.
So good morning to all of you, and to my colleagues, and especially to the organizers and to the PhD students and to all the participants. I would like to start by congratulating the students that organized once again one more event about the doctoral PhD program of informatics engineering, and especially in this period, in this COVID-19 period. I think the conference itself has been very instrumental for the PhD students, especially to learn a lot of things considering the research and considering also aspects like reviewing. So it's one more example of acquiring or learning by example, learning by doing, which is very proud for us. I also take this opportunity to wish all of you the successful PhD work. My desire is always that you aspire international scientific impact, you aspire publications in top-level conferences and journals, but as you know, this requires a lot of work, a lot of hard work, a deep commitment, and but this is the intention, this must be the goal. I would say also that during the PhD work, this is a most exciting research time. At least it was for me, and because you are very focused on a PhD work, it's your project, you have time to explore, and you have like a 3 to 4 year horizon, which is very important. I think you must know that after these times, nothing will be like the same, because you don't have this time. Anyway, you don't have this time if you go to the academia, and you don't have this time if you go to the companies. So please enjoy your time and do your best during this time. So an exciting, very exciting time. I will say that the PhD is a framework at the moment. It's a framework for your future career. So it's a framework if you go to a company, and it's a framework if you go to academia. So we need PhD students for many reasons, but especially for the potential they have for the creation of innovation in companies and in academia. So let me just conclude with my best wish for a great symposium, and have a nice day. Okay, thank you very much.
Tiago, estás com o microfone desligado.
Thank you. Thank you. So thank you, Professor João Paiva Cardoso. I will now pass the session to Professor João Falcão Cunha from the Faculty of Engineering of the University of Porto. Please.
Good morning, everyone, and I would like to congratulate the organizers, in particular the students, the PhD candidates, Tiago Mendes and Soraya Felício, and all your colleagues and everyone that is attending now, in particular the ones who are with their cameras on. But I'm sure they are listening to what I'm saying and we are saying. I would also like to say hello to my colleagues, Carlos Soares, Augusto Souza, Eugênio Oliveira, João Cardoso, and the ones who are attending, and say thank you also for the companies that are supporting this event. It's very important, on my view, to make to have a good relationship with companies, in particular companies who are leading the ideas about what we need for the future. I can tell you that I was also in your position some years ago. I did a PhD in computing science, so I understand, I still understand, I still remember a bit of what you're going through. Although I think you are doing much better now than I did when I was doing my PhD. Professor Eugênio Oliveira read my PhD. I think he's the only one who read it in Portugal. Because I did it in the UK, but I need to have the PhD recognized by a committee here. Now it's different, I think. But I'd like to tell you that I think this event is very important because you will interact, and I think one of the most important things of these events is the interaction between the people who attend it, and communicating your ideas and being open to criticism or to support. And usually when you do that, you learn something new. And I hope that what you learn, not only in this event, but what you learn during your PhD, not only, I can tell you, not only technical issues, but everything you learn will be, or some of the things you learn will be more important sometimes for your future career than the technical aspects. And being in computing or informatics, it's a very relevant area for the society, for the current society and for the future society. And I think one key issue of what you're doing is to think that you have to change the world for better. And one of the most important things you have to think about is how to make the world more sustainable. And being someone who will be leaders in the future of our economy, of our society, I think you have a lot of responsibility for that. And I'm sure you will be in the future invited for a Dsie as an external speaker or as an external supporter, and your company, the one you've created or the one you're working for, will make this event better, will make this school better, the university better, and the society better. So enjoy your PhD, and for the moment, enjoy this event. And congratulations to all of you for being here, and congratulations for the team that is in charge of making sure microphones are on when they need to be on. Thank you, and have a good event.
Thank you, Professor João Falcão Cunha, and thank you for your availability. But now I think it's time to go into science. So let's start the conference. The conference is now open, and we will start very well. We will be traveling, I think, to the city where the country was born. So it's Guimarães, I think. So and I'll pass the session to the first session share, which is Carolina Ribeiro. And the subject here will be machine learning. So welcome, Carolina.
Thank you,
The session is
Tiago.
yours.
Thank you. So good morning, everyone. Welcome to the machine learning track. My name is Carolina. José Rodrigues and I are the track chairs of the machine learning track. Today, I will be guiding this session, and tomorrow it will be José Rodrigues. So today we will have 3 presentations. The authors are already in the Zoom room, I think, so we can start. The first work has the title Empirical Study on the Impact of Different Sets of Parameters of Gradient Boosting Algorithms for Forecasting with Light GBM, and the author is Filipa Barros. Are you ready, Filipa?
Yes.
Okay, so you have 15 minutes for presentation, and then we will have 5 minutes of discussion and some questions. For people who are watching us on YouTube, you can make questions about the presentations through the Slido. So Filipa, you can share the screen and get started, please. Good luck.
Thank you. Does everyone see it clearly? Yes, good. So hello everybody, my name is Filipa Barros. I'm here to present a work I've done alongside with the proponent and Professor Carlos Soares in a course. The outline of this work is the context, the goals, the methodology, test and results, and the final remarks. So giving you a little bit of context, time series forecasting has gained some popularity. A time series is basically a collection of observations made sequentially through time. Forecasting the value of future observations of time series is of vital importance in many areas of scientific and industrial activity, and it is particularly relevant in applications such as cell forecasting and model evaluation, which is the scope of this work. A little bit of context on the part of light GBM. So gradient boosting has gained some interest in the forecasting community after the light GBM algorithm has won the M5 forecasting competition, and it has also achieved several runner-up positions. In the M5 competition, the data on supply and demand time series in retail had some specific characteristics, such but not limited to intermittency. Thus, the set of hyperparameters of the algorithm in this data may not be the best for another type of time series, hence this study. So the goals of this paper and research project were to find which hyperparameters were the most important and which values of the hyperparameters are the most promising. These subsets of hyperparameters and values can serve to warm up an optimization process. So the methodology used was split into 2 sections. So first we reconstructed the time series, and then we performed a random hyperparameter search. So the idea was that the data for forecasting was reconstructed. So the time series was reconstructed as a geometric object by applying a time delay embedding using the Takem's theorem. We did this to frame the predictive task as a multiple regression problem. Then we constructed a set of observations. In each observation, the value of y is modeled based on the past values before it, and conclusively, this leads to the time series being transformed into the dataset T. Regarding the random hyperparameter search, despite grid and manual search being the most used strategies for optimization, we decided to use randomly chosen trials since these are proven to be more efficient than trials on the grid. In contrast to grid search, what we do is that the chosen parameters are not equally spaced and are searched randomly, providing a wider scope of cases than grid search. So in this work, we opted to follow such a methodology for the hyperparameter search. Regarding the case study, the used data consisted of basically 58 time series data frames. The data was collected from the time series data library, TSDL for short. From that database, all univariate time series with at least 1,000 observations were selected. Why? Because this condition basically is justified since the methods need a reasonable amount of data to build a good predictive model. So then this query to the database generated the 58 data sets. From there, we limited the maximum number of observations to 10,000 for the computation process to become faster. And as you'll see, that is sort of the limitation of this work. And besides this, differencing was applied to account for a trend component that can be found in the time series. Basically, differentiation consists of the process of subtracting the current value of the time series with the previous value. Okay, regarding the hyperparameters themselves, and I apologize for the background noise. Regarding the hyperparameters themselves, we basically searched for the documentation of LightGBM on which parameters would be the most important to tune for better accuracy, coming to the conclusion that these were the maximum number of bins, which should be large, the reduction of the learning rate using a larger number of iterations, also the enlargement of the number of leaves and the possible use of the DART algorithm, and an important parameter that we found to be important for avoiding overfitting was the use of a maximum depth. In the slide, you can see the values we used. We would like to have used, obviously, more values, but for computational distresses, we couldn't. Also, I would like to point out that even though there are more parameters that could be tuned, for instance, if we choose to use the DART algorithm, we can choose different hyperparameters that can be tuned. However, this would make for a very huge mesh grid, and so we weren't able to test them, but hope to do so. Our tests consisted in two approaches, so basically two parts. In the first part, we wanted to have a general overview of the impact of this random hyperparameterization as a whole for forecasting specifically time series in LightGBM. The second part consisted of understanding which of the hyperparameters had the biggest importance in reducing the MSA error, which is explained in brief moments. So basically, we wanted to have an overall picture of configurations, and then we wanted to study exactly which hyperparameters would have the biggest impact separately. So for the first part, for the overview of the hyperparameterization, So for the first part, for the overview of hyperparameterization, we randomly chose 251 configurations. Why this number? Because it was basically a good set of data without overloading our computational resources from this previously generated table of hyperparameters. Then we applied these configurations to the LightGBM algorithm. After that, the default configuration of each of the data frames, the value of the default configuration with each of the data frames was calculated, so it has to have a benchmark. And then we calculated the mean squared error for all of them. Then we normalized this error with a calculated default configuration error. And then the default configuration was used as benchmark, as I had mentioned before. we found that the random ones performed better in reducing the measured MSE. What this means is that they were always better than the one we use as benchmark, which means the one that is used by default in LightGBM algorithms. So our range of reduction varies up to 17.9% in larger default MSEs. So this is basically an exemplification of some of the results. Basically, we have the data set and the percentage of the improvement in MSE. So the values are switched to positive. So basically, this is what we wanted and were expected. Then we proceeded to the second part of our experiments, which was to study the individual, individually study the hyperparameters and their performance. So basically, we took the values we previously had and we analyzed the impact of each possible different category by using again the median value of the MSEs, but specifically for each of the parameters. And then we obtained these 58 median values for each possible category of the hyperparameter, and we calculated the median of the list. Then we compared it with the benchmark and found that the boosting algorithm that minimizes MSE is DART, number of leaves 50, learning rate 0.1, and the maximum number of bins is 400. The maximum depth is 1.7, which is, by the way, the default. So this was, I believe, the only parameter that we had that was the default configuration. Oh, and also the learning rate. So yeah, this is what we found. Another thing I wanted to point out is that the maximum depth was expected to be the default because the other ones provide less depth, which means that we don't get as much opportunities to train the algorithm, which was already expected as well. So then we further analyzed these impacts by using one configuration or the other. We wanted to have some awareness of overfitting. So even though so basically having all of this in mind, we end up proposing an alternative for better accuracy in a time series forecasting problem, specifically for time series predictions, and they are shown below. I'd also like to point out, and this is mentioned in the paper, that even though the max depth recommended is the default one, because it is the one that improves the results, anyone that uses the algorithm needs to be aware that using a greater max depth might avoid overfitting the data. In here, I just have some exemplification of the MSEs measured with the different configurations across different categories and for the other data. As a final remark, so our work consisted of exploring the importance of hyperparameter tuning. We started by establishing hyperparameters that could be tuned. We used 58 time series data frames with 251 randomly selected. And using the default configuration as benchmarks, we concluded that the randomly selecting configurations can lower the MSE up to 17.09%, which means that they always improved. By the way, I'm sorry, but this value is wrong, 17.9%. There was a mistake in the slide. We then studied the individual performance and impact of each of the hyperparameters and ended up suggesting the table of hyperparameters I have shown you. And as future work, as I mentioned before, we would like to be able to test the DART boosting algorithm in order to further enhance our solution, especially given that the DART algorithm was the one that had better performance in lowering the MSEs in our case study. Here I have some references for remarks, so the ones that were more impactful in the research process. And that's it. I'm open to any questions you might have.
Thanks, Philippa. Congratulations. It's a good work and good presentation. It's a relevant research topic. Now we have one question from Ricardo Gomes. I would like to know why you used 58 time series, as far I understood, and not apply maybe a broader set of hyperparameters, turning with less time series.
Okay, so what happened is that these 58 time series data frames were not chosen in accordance to the GPU that we have. This was done because following the process that I explained in this slide. So basically we collected them, but then we wanted them to have at least 1,000 observations. And then we limited the maximum amount of observations to 10,000. So these were the only ones that were returned. So that's why we used 58 time series. Regarding the hyperparameters themselves, unfortunately, I did try to use more, but that made the computational process unbearable, because basically, even with only these hyperparameters, with this mesh, I still had to run the algorithm for almost 48 hours. So,
okay, I think it's clear. Another question from Tiago Marques. Would you see this work as a basis for automatic hyperparameter tuning for time series? What are the limitations?
I'm sorry, could you repeat the first part of the question, please?
Would you see this work as a basis of for automatic hyperparameter tuning for time series? What are the limitations?
Mm-hmm. So the main limitation that I would like to point out is the maximum depth might not be the best one to fit the hyperparameters you have, since you may cause overfitting with this max depth. I left it there because it was a default and we couldn't find a better one as expected. But everyone should always be aware that you must avoid overfitting. The main limitation, the other main limitation is that we haven't tested how to kickstart the process for the DART algorithm, which means that there's a whole world to explore there. But yeah, the suggestion we make is specifically for people to be able to, when they have a time series that we want to use to forecast something like a supply demand or something like that. The idea is that you can automatically use these hyperparameters.
Okay, thank you. Ugo asked the following question. Are the time series from the same domain? Any context of this time series in which you models have more difficulties to converge? Any through on this?
And if you want, sorry. Oh, and if you want this, got it.
Yes.
Sorry. So these 58 time series are from the database that I mentioned. So they are all from the same scope, which is why we focused mainly on time series for supply and demand. So the view is that it would probably be a nice work to further on this research with some other types of time series. Right now, I'm trying to apply this method to another project I'm doing in astronomical data. But as expected, different hyperparameters are better for different kinds of data. So this recommendation is solely for time series, particularly for anything related to supply and demand.
Okay. I think we have no more questions. Thank you, Filipa, for your participation. And now we have to move on with the presentations. The second work has the title, A Benchmark Comparison of Different Classifiers for Human Activity Recognition. And the author is Paulo Ferreira. Paulo, if you are ready, you can share the screen and get started, please.
Are you hearing me well?
Okay, yes.
So I will share my screen.
Please.
Can I start?
Yes.
So, good morning to all. My name is Paulo Ferreira. I am here to present my work with the title A Benchmark Comparison of Different Classifiers for Human Active Recognition. I will start with explain the context and the motivation, the definition of the problem, the solution that I present, the algorithms that I use, my experimental setup, the results, and finally conclusions and future work. So, human active recognition aims to automatically recognize activities performed by humans through the analysis of sensing data. This human activity recognition has enabled novel applications in different areas such health, fitness monitoring, security, and entertainment. And most of these approaches have been developed using machine learning methods like PNN, decision trees, the naive Bayes, and most recently, deep learning techniques. In the early stages of sensor-based approaches, users had to attach multiple motion sensors to their body. Although these systems achieve high accuracies, they require elaborate setups, which is uncomfortable and not suitable for long-term usage. But in recent years, sensor-based human activity recognition approaches have received much attention due to the availability of smartphones. Smartphones have been increasingly used to develop our systems to the capability and diversity of the sensors that embedded in these devices. Also, these devices have other advantages over wearable devices, like the ability to collect and process sensor data locally, and the increase in the processing power and battery capacity. So the smartphones allow to overcome some limitations that initial hard systems have, like obtrusiveness of wearable sensors, difficulty of performing human activity recognition in real time, and the battery duration. But despite all the advances in smartphones, it is still necessary to consider energy consumption, which become more important in these devices since it's a very important device in people's life. We use these devices to everything in our life, to work, to entertainment, to phone calls, and many other things. Not all our systems are feasible for implementation in smartphones, mainly because these systems have a high computational cost and energy consumption. So the main purpose of this work is to propose a smartphone inertial sensor-based architecture for our system. For that, we'll evaluate several algorithms such as Kaplan, naive Bayes, decision trees, an ensemble algorithm, and a deep neural network. And I used the PAMAP2 dataset to evaluate these algorithms in terms of accuracy. The algorithms that I use, I will start presenting one. First was Kaplan. Kaplan is a lasing algorithm. A lazy algorithm simply stores the training data, and only when it sees a test instance starts an instance-based approach to classify the test instance based on its nearest neighbor. For that, it calculates use the distance function to calculate the distance of the test instance to the training instance. There have been used many distance functions in the literature. The most commonly used is the Euclidean distance, but also are the Chebyshev distance, the Manhattan distance, the Minkowski distance, and the chi-square distance. An important thing in this algorithm is the value of k. The value of k defines how many neighbors objects have in the class consulted. So, watching this picture, we can see that if we could assign 3 to kappa, the test object will be assigned to class B because there are more neighbors of class B. But if kappa is equals to 6, the test object will be assigned to the class A since there are many neighbors of class A. The decision trees is a tree-like structure where each internal node denotes a test on an attribute, each branch represents an outcome of the test, and each leaf node, the terminal node, holds a class label. Each branch from the root to the leaf is called a classification rule. Numerous decision trees algorithms have been developed over the years. Some examples are the C4.5, the CART, and the Sprint. Naive Bayes is a probabilistic classifier based around the Bayes theorem. The formula is on the slide. Naive Bayes is a generative algorithm and induces the classification based on joint probabilities, or the probability that a given object belongs to a particular class. This ensemble learning strategically generates and combines the output of several individual classifiers to improve the classification. For that, we need to take into account two important factors: the individual classifiers and the combination rule. The individual classifiers that I used in this project was the cap and yen, I-based and decision trees, and the combination rule, which is responsible for the final decision of the ensemble. In this case, combines the majority vote of the individual classifiers. I also use a deep neural network. The deep networking used includes 3 fully connected layers. The inputs to the deep learning structure were organized in a 2D matrix with n plus m dimensions, where n corresponds to the number of input signals. Since we have 9 sensors and 3 axes each, these correspond to 27 input signals. And m is equal to the size of the LC window when using raw data as input, in this case 300. The output of these 3 fully connected layers is flattened in one single vector, and this one single vector is classified by the output layer using the softmax function. The experimental setup that I used to conduct this work. This work was conducted in the desktop laptop with Intel Core i7 with RAM of 16 gigabytes and the Windows 10 OS. The dataset used was the PAMAP. PAMAP2 contains samples of raw sensors from 9 different users and 18 different activities. The data were collected from 3 inertial measure units positioned in different body areas: the dominant wrist, chest, and dominant ankle, and heart rate monitor. Each EMU has 4 sensors embedded: a 3-axis accelerometer, a 3-axis gyroscope, and a 3-axis magnetometer, and a thermometer. The activities are 18, and they are presented in this slide: walking, running, cycling, lying, sitting, standing, standing and standing stairs, playing soccer, rope wrapping, and among others. So before we feed the algorithms with the data, we need to prepare them. For that, we need to analyze the data more carefully. So after analysis of the data, I conclude that the data from the heart rate monitor were mostly invalid data, null. For this reason, data from this sensor will not be used. Also, we can see this in this chart that user 9 is the one with the least amount of samples, and besides that, these samples are just for one activity, in this case, rope jumping. So data from this user will also not be used. After removing data from the sensors and the users, we did not use in the experiment, the feature was extracted. The features were extracted based on the fixed sliding window of 300 data samples and overlap of 10%. These values comes from our previous work that we developed in the past month. From these configurations, we extract 10 features for each 3D sensor: the X, Y, and Z mean, the standard deviation of X, Y, and Z, and the correlation between X and Y, X and Z, and Y and Z. So in total, we have 90 features. The tools that we use to develop this work were Keras, where we implement the neural network. The Optune was used to optimize the hyperparameters of the neural network, and the RapidMiner was used to implement the traditional machine learning algorithms. As I already said, Optune was used to find the optimal hyperparameters which maximize the accuracy of the neural network. We conducted 50 trials to determine the optimals of the hyperparameters, and the hyperparameters that we tried to optimize were number of layers, the learning rate, the estimators, the epochs, and the batch size. This table represents the hyperparameters that we tell to Optune to optimize, the value that Optune provides, and the search space for each hyperparameter. In order to evaluate algorithms with a PAMAP dataset, we split the dataset in training and test set. To split the dataset, we use a node-out approach. User set was selected to represent the user of the system, the test set, and the remaining users constitute the training set. For the deep learning approach, the experiments were repeated 10 times, and the results presented are the average of the accuracies of the execution performance. the experimental results. This chart shows the results of the 5 algorithms tested in this work. We can see from here that KPN was the one who performed the worst. And individually, the decision trees was the one who in the traditional machine learning algorithms, that was the best score. The ensemble of the 3 previous algorithms was the one who obtained the best accuracy of all traditional machine learning algorithms. The ensemble was able to improve the accuracy of decision trees in approximately 2%. And regarding the network, the deep learning approach, the network users obtained an accuracy of 94% and 26%. And we can see that this is the algorithm that under the test that obtained the best accuracy. So concluding this work, with the rapid increase of smartphones, these devices have been increasingly used in human activity recognition. And in order to implement an R system on a smartphone, this work evaluates 4 different traditional machine learning algorithms and deep neural network. The main goal is to find the most accurate, the main goal of this work is to find the most accurate algorithm to recognize human activity. And the results show that the method that allows recognizing the activities with more accurate is deep learning network, improving on average the accuracy of the ensemble by approximately 1%. So in terms of the accuracy, this is approach that is the best to implement a more accurate R system on a smartphone. So as future work, we intend to try the approaches presented in this work in other data sets, in the machine learning, in the human activity recognition, like wisdom, opportunity, and we also intend to evaluate other algorithms, such long short-term memory, random forests, and support vector machines. We also will try to make more exploration of feature engineering for the traditional machine learning models. And most important, we evaluate these algorithms in terms of energy consumption and execution time. And finally, find a trade-off between accuracy, execution time, and energy to select the best method to implement our system in a smartphone, which is the method with the highest accuracy and the least computational cost. So thank you, and I'm open to questions.
Thank you, Paulo. Congratulations.
Thank you.
The goal of the paper is interesting. Since a benchmark comparison of different classifiers for a human activity recognition can be very useful for future research. Why did you use only one data set? And you also said that you selected user 7. But why did you select only one user?
Okay, the data set, because this data set I've been using in the past months in other works. So it's a data set I'm very familiarized with. And okay. And I think that this data set was good because there are different data for different users, and they are very well separated. Regarding user set, it was used based on other work that I consult that said that the user set was the user that allows to maximize the accuracy of data sets.
Okay. Now we have a question. Fernando Freitas asked the following question. Did you use all 90 features in all models, or did you try to reduce the features for some of the models?
For the traditional machine learning algorithms, I used all the 90 features.
Okay. For all the models, okay.
For the deep learning, I didn't use because it calculates the features automatically.
Okay. We have no more questions.
I have.
Okay, please.
Okay, Paul Ferreira, thank you very much. Now we are on our running away. So for the evaluation of the students, for the conference is also a pedagogical tool. So you have to be evaluated, and I'm here also. Me and Professor Carlos Soares are also here to do that. So I have some comments. Let me say for everyone that my comments are to be seen by everyone as for themselves. I will not repeat all the comments to everyone, okay? So I will mention in this case one thing, and in other case, in other student, I will mention other thing, etc. But I will mention the most important, I think, from the presentations. Paul, your presentation was very good, I believe. You made a very good structure of your presentation with the context, the motivation, the problem definition, after that, the solution that you are imagining. You discussed the algorithms, and after that, the experimental setup with experimental results, finally, conclusions. One or two things about the algorithms. You mentioned several algorithms as a list of algorithms only. Algorithm 1, algorithm 2, KNN, decision trees, naive Bayes, ensemble, etc., etc. And I missed some kind of comparison, some kind of global view of all the algorithms, okay? Even if they are not for the same objectives, but how can we join, or how can we choose from them, etc. The experimental setup was okay in my opinion, but for example, in the experimental results, you concentrated only in the accuracy. Finally, in the future work, you were speaking about having more work to evaluate execution time, energy of each algorithm, etc. So you were too much concentrated only in one parameter, perhaps, and you have to have a larger view of the system. Let me tell you about your presentation, your posture, your presence facing the audience and presenting is good. Believe me, being in a room with a physical audience is different, okay? So try to train this part of presenting to your colleagues in your labs, etc., because it is different to have a physical audience. It's even from having them in a video like this. Unfortunately, I have to point one or two things about your presentation. Your slides, many of your slides have too much text. You have to reduce the text for those important keywords, okay? And make a good structure in each slide of what you are saying, but with keywords, okay? And obviously, I know why you did too much text in each slide. It was because you were reading the slides. In several slides, you were reading the text, and this is not good. This gives a bad impression to people that are seeing, that are assisting. Okay, and I believe I'm done. I don't know if you have some comments to my comments.
No, Professor, I agree.
Okay, sorry.
See these comments as constructive comments, okay?
Yes, I know.
Help you to do better in the next opportunity. Okay, Carolina, time is yours. Thank you very much.
We have more questions from our colleagues. Hugo has the following question: what was the strategy to tune your voting ensemble? How do you reach the best weights? Have you considering stacking or multi-stacking for ensemble?
No, we just vote the democratic vote. So the majority vote was the decision. If one says that the label is running and the other two says that is walking, the opinion of the ensemble will be the majority, which is walking.
Okay, and and finally, Tiago asked the following question: do you consider running machine learning models on a smartphone viable? Would you recommend a cloud computing approach?
A cloud and computer approach implies that the user was to be constantly connected to internet. Many researchers have been doing these approaches, but it's not feasible that the person that they use in the app will have a permanently connection to the internet. So if the internet connection fails, they will lose the communication with the server, and will not be able to obtain the classification of the sensors.
Okay. Thank you, Paul, for your participation. Now we have the last presentation of this session. This work has the title "Optimizing CycleGAN in the context of Monet painting generation," and the author is Filipa Ramos. Sorry. Are you ready, Filipa?
Yes. Good morning.
Okay. Hello. You can share the screen. Remember that you have 15 minutes, and then we will have 5 minutes of discussion. Okay. Thank you.
Thank you. Okay, so can everybody see my screen? Okay.
Yes.
So, good morning, everyone. My name is Filipa Ramos. I'm here to present my the work that I've been developing up until December. So let's just get into it. So just give a brief introduction into the field that I will be speaking about. It is called image-to-image translation. And as you can see, I have here some examples of popular translations in this field. For example, if we have a picture of a winter landscape, we might want to translate it into a summer landscape. Or for example, if we have a painting, we might want to turn it into a photograph. If we have a photograph of a horse, turn it into a photograph of a zebra. So this is a field that spans a lot of different types of translations. Specifically, I'll be talking about a subset of problems from this field, which is painting generation. As the name says, it's just generating paintings from photographs. And specifically, I worked with the Monet paintings because I used a data set from a Kaggle challenge, which had all of the Monet paintings available for research. So the research objectives were first and foremost to create a working CycleGAN model, since this is the basis of this work. I utilized PyTorch. I wanted to analyze this network, try to find some possible improvements in the field of painting generation, since CycleGAN works on a broader set of problems from image translation. And I also wanted to conduct some experiments, try some different ideas, try and understand the workings of the inner workings of this model. So just give a brief overview. CycleGAN was proposed in 2017, works, as I've said before, in several subset of image-to-image translation problems. Their hypothesis is that if we can translate an image from one domain to another, then we should be able to translate it back to the original. So here we can see on the bottom right these three sequential pictures. So if we start with a photograph of a horse, we want to translate it into a photograph of a zebra, and then taking the translation, we would be able to translate it back into the original image. You can see it's not perfect, but the image, the context is there. Maybe the tints are a bit changed, and this is still a field with a lot of work. However, this model, why is it still widely used? It achieved unprecedented results. Okay, so and they do all of this in an unsupervised manner, which was pretty spectacular at the time, and still is. And this is very important because here we don't have paired data, so we cannot match a photograph to a Monet painting. So we need to go and explore unsupervised methods. So the methodology is that of CycleGAN composes three main modules. So we have the adversarial training, the cycle consistency, and the identity. I'm just going to very briefly talk about these modules. So the first one, adversarial training, it's just a generator discriminator pair. We have one for each domain. So one generator receives a sample from X and another generator receives a sample from Y, and then translate it back to the other domain. And we have a discriminator which is tasked with trying to understand whether the generated image is real or not. And through this process, we are able to train the model to kind of modulate the target distribution. We can see here the loss function for this component, which is the binary cross entropy. Then we have the cycle consistency, which is the backbone of this method. So we simply take the samples that were generated by our generator and we send it back to the other generator, and this one tries to translate it back to the original image. So we also have a loss here to ensure that the translations match the original image. And at last, we have the identity loss, simply feeding each generator its own sample, so that we are able to tune the network and tell it not to do drastic changes. We don't want to, for example, those tints there, we don't want to change the tints of the image too much. We need to keep the structure and some of the color, at least the color scheme needs to be kept, and so the identity is important. So putting it all together, we have our full objective, which is simply summing all of the component losses, and we have some hyperparameters which weigh the cycle consistency loss and the identity loss. So I started with the baseline architecture, and then I moved on. Sorry. I moved on to an encoder-decoder based generator with residual blocks. This was based on variational autoencoders. So I sampled noise from a normal distribution with a mean of 0 and standard deviation of 1, and added this noise right before the decoder. Also had a deeper discriminator. As you can imagine, this took a lot longer to train. So on that aspect, it was not much better than the baseline. So then I try to go back and make something lighter. And so I compose a UNet-based generator, such as CycleGAN, where we have skip connections, transpose convolutions, and also a slightly improved patch discriminator. Just give a brief overview. I'm going to use, I've used two main evaluation methodologies. So I have the Kaggle challenge, where they utilize the MIFID score. So the lower the MIFID score is, the better the general quality of the translations are. And then I have visual analysis, where I also did a small AMT perceptual study. So comparing all the free networks that I had, so the baseline is pretty much what we have on the paper. I achieved a MIFID score of 71.89, which is pretty bad, since the current, as we are speaking, the current best score is 34, around 34 on the challenge right now. So moving towards the encoder-decoder architecture, I was able to get a score of 62.95, and then with the improved baseline, which keep in mind was a lot faster to train, I achieved a score of 44.77. So that was a large improvement over the initial baseline. So the main differences here are just differences in stride and using instance normalization instead of batch normalization. So there's small tweaks, but they make a lot of difference. So I also tried experimenting with data augmentation, because I thought this could bring interesting results in this field. Normally it's widely used, but here we have some contradicting results. So as expected, if I start introducing a lot of data augmentation techniques, we see some kind of artifacts showing up. And we can see here on the pictures on the right, the first pair, we see from the original image, we have some red spots showing up. And then on the last two pictures, two pairs, actually, we have some kind of blackish spots with a green outline. So these are introduced because we are changing the target distribution too much during training, and the model kind of degenerates. So keeping only horizontal and vertical flips is the ideal situation here, because we get rid of the artifacts. However, in terms of score and visual analysis, doesn't make much difference using data augmentation or not. Also tried including shared weights on the Monet photograph encoders and generators. And although I did not get an improvement on the MIFID score, I did find some interesting insights into the network with this experiment. We can see here the original translation, and then without the shared weights, and then with the shared weights. And actually, consistently, the images with shared weights had less overall noise. And we can see, for example, it doesn't get influenced too much by the initial image, which sometimes is one of the reasons that these images look so fake. For example, it brings out strong shadows from the initial photograph without shared weights, and this is not truly ideal, because we can see the strong colors just create some kind of noise all around the image, and this wouldn't be ideal when we have a human observer trying to distinguish the images, even though in score it's overall the translation is analyzed as being better. I also tried some extra experiments, but they didn't make a lot of impact, so perhaps I'll just say the most determinant one, which was I realized that Monet has a lot of different techniques in his paintings, and so I thought this would be very hard to match this distribution, since it's so different within itself. So I tried creating sub data sets of paintings that I thought were more in tune with each other. For example, they had a similar brush technique and perhaps a similar color scheme. And I tried training on these sub data sets, and yet the results were not that different from training with the whole data. So I found that was interesting, and I'm going to discuss that a little bit later on. I also performed an ablation study. So this is just to realize the impact that the identity loss term has on the performance of the model. And as we can see, without it, we obtained the worse we worsened the score but slightly, so we had 51.71. And I also observed that the training was pretty unstable without the identity terms, so it does really, it is a positive thing for the model. Still, I have here some examples of some positive examples without the identity loss, so it's still able to perform decent translations, but then when we have strong colors, it changes the network too much, and this is it changes the photograph too much. Sorry, and this could be a problem. And we see some strange colors showing up which do not look realistic at all. I also conducted a very small AMT perceptual study. This is a study where I have here the pictures for the study. So I have 10 pairs. Each pair has one real painting and one generated one. And I just told participants to look at the pair and try to find the real painting and the generated one. So overall, the participants had 77.5 accuracy in choosing the real painting, but they confessed it was a difficult task, and some people really took quite some time to distinguish some pairs. Actually, the last test, we only had 50% accuracy in telling the real painting from the generated one, so that would be the bottom right corner. So I'm facing these results as pretty positive. The aspect that gave away most of the pictures from the participants, what they've told me is that there's some kind of noise that can be seen on the outlines of, for example, here I have on the left bottom, we can see some kind of noise around this rock formation, and that's what gives it away. So possibly in the future we could add some kind of term to improve image quality. So just give a brief overview. So data augmentation, in the end, I decided not to use it. So I believe that changing the target distribution during training might not be favorable. Shared weights, as I've discussed previously, I think could be an interesting area to try to pursue a little bit more, some more experiments, since we had those interesting visual cues showing up. And about the subdata set, I think that the negative results showcase that the discriminator is not truly tuned to distinguish Monet paintings. It's just, I think the network only has the information to distinguish a photograph from a painting, but it's not really matching the distribution of Monet. And this is still something that we need to research more. And even us, we do not know much about where the artistic formation comes from, and trying to emulate this on an artificial system, it could be something very groundbreaking in the future. So on this sense, I would like to try in the future and feed the discriminator smaller patches of the image, perhaps have some kind of feature maps on several dimensions, so that we can try to improve and get those details from Monet's technique. So these are some of the references that have been showing through the presentation, some of the main backbone of this work. And thank you for the attention. If you have any questions.
Thank you, Philippa. Congratulations. It's a very interesting and work and very good presentation. Can we extrapolate or generalize the results to other painters?
Yeah, I didn't try that, but we certainly can. And the original Cycle Gun paper, they actually try with Van Gogh and some other papers. I don't recall right now the name, but it is possible. I focused specifically on Monet because I wanted to see if those techniques were getting through. But it is certainly possible.
Okay, thank you. We
can continue.
Yes.
Okay, Philippa. While your colleagues prepare their questions, I am going to make my own. Excellent presentation, and let me make a small joke. Do you want to be rich with fake paintings from Monet? Is that what you want?
No, I just yeah.
Okay. Your presentation was excellent, very good. It's slightly different from, let's say, a new development, because you got new techniques and made some experiments with new techniques. So I didn't see, for example, a real state of the art about the problem. You presented one method mainly, okay? That was the method that you used. So in real presentation, you should actually present a state of the art, being or presenting more methods, more experiments from other authors about same subject or similar subjects, if you want.
Okay.
This is my main question about your presentation. About you started too fast with the presentation. Perhaps you could have a first slide or two first slides presenting yourself, the work, why, etc. You enter immediately into the introduction without good motivation, a good, and this is also something that usually we present. The type of problem was more or less understood, because the method, the cycle GAN, is exactly that. So you presented well. The slides were very good, in my opinion. Perhaps in one or two, the font used in the text was too small. In a big room, perhaps it does not result very well. Be careful with that. After that, you also described very well all the experiments that you made. About the experiments, and because I also work in image in a different area, we have many times the problem of evaluating things by humans. And humans have different perceptions of what they see, and I was in doubt about the perceptual study that you made. Was it made by experts in the area, by experts on Monet paintings, or only public in general? Because this is very different, okay?
Yeah. No, in this case, it was the participants were just ordinary people, as you would say, with no specific knowledge of art and with no specific knowledge of Monet.
But to this objective, facing this object, it would be very important to have expert persons, because it's different. The way the one effect is painted is different from painter to painter, and only experts can detect this. Okay.
Yeah.
And the other thing is, how were the tests conducted? In imagery in a computer, and the persons evaluating two images in the same computer. What was the rest of the environment? A dark environment, or was the screen calibrated? This is the common questions when we have personal evaluation of imagery. Did you try any of this?
Yeah. Okay. So the perceptual study was actually very small. It was more of just trying to get an intuition of what other people thought, because after me seeing so many pictures, I just don't have the same perception as if I were a person just coming from the outside and looking at these pictures. And so I just had a room with some kind of dim light, and people were always using the same computer. I brought them in one at a time, so they didn't know about the results from the other tests. And they always use my laptop, and I'm not sure about the screen, the brightness,
okay.
and this aspect.
It is important, for
consider.
example, to for the same person to make alternate presentations. For example, for one image, start with the real, and after that with the fake one. For the next, be the contrary. So make some noise on this presentation. So there are some random evaluation of the persons also. Okay. So the slide, your posture was okay. Yeah, you have, for the next time, you have to improve a little on the first slides, on your first impact to the audience. Okay.
Okay.
Thank you, Filipa. Very good
Professor.
presentation.
Thank you.
So, Filipa, we have a few questions from our colleagues. Hugo has the following question. Also, have you addressed the common issue of stability in cycle gain with some genre of adversarial loss modification to address convergence problems?
Yeah, that was in the slide that I kind of just went through because we don't have a lot of time, but I also tried the W-GAN loss strategy, so having gradient penalties, and I did have a lot more training stability with that. However, the model degenerated many times to doing simply reconstruction. So I also didn't pursue this much more because of that. I also tried to introduce a penalty term on the discriminator, on the Monet discriminator, under the premise that turning a photograph into a painting is a less defined translation than turning a Monet into a photograph, because we always know what a photograph should look like, or at least the structure is always the same, but turning a photograph into a Monet painting has a lot more aspects, I would say, to consider. So I did try those, adding those types of things, but I did not see substantial results, and that is why I didn't lose too much time on the presentation about this.
Okay. Paulo asked the following question. Monet has a great variety of styles and techniques. Doesn't this make it difficult to quantify what is a good translation from a photograph to a painting?
Yeah, it is one of the problems. Actually, I also chose Monet because of this. I thought it would be more challenging. For example, Van Gogh, we always know has that very characteristic defined style, and perhaps I could have obtained better results doing it on Van Gogh's paintings. Perhaps I would get those characteristics, but Monet is just, everything is so different, and especially the data set had so many paintings that were exactly the same scene but in different colors. So it's a lot about the color study, and I thought this would be even more interesting to try and study. But yes, it is a lot more challenging, and as I've said, I think the discriminator is still, we're not at a point where we can point out the slight differences artificially in these artistic qualities.
And finally, Afonso asks the following question: what are your thoughts on an adversarial transfer loss? This is common on action recognition, not to learn the actor, but learn the activity.
I have never worked on action recognition, so I haven't considered that as some other ideas. But actually, I'm going to write that down because it sounds interesting.
Okay, thank you, Filipa, for your participation. So we finished the presentations of the first track, the first session. Sorry, thank you. If you have more questions about these works, you can contact the authors, I think. And thank you all.
Thank you. Thank you.
Applause. A good applause to all the speakers and to the share of the session also. Thank you.
Yeah, thank you, Carolina. So we are a little bit behind the schedule, but it's not your fault, so it's okay. So we'll go very fast to the second session. This session will be animated by Afonso de Souza. I would like to remind that we have the possibility to ask questions through Slido. So you can access the website of Slido and use the code 482295. So, and please tell your name there. So write down your name, your first and last name. I would also request the session shares, not to delete the questions, but only to click on answers, and then they will be there anyway. All right. So, Afonso, are you ready?
Hi.
Okay. So the session.
First of all, I'd like to say that this will be a we are two shares, so me and Tiago, which must be joining right now. So.
Which one, Tiago? There are too many Tiagos in this class.
Tiago Mendes.
Tiago Marques, I would say.
Tiago Marques, I'm sorry. And secondly, I'd like to apologize to our sponsors because of the lack of background. Zoom hasn't been very generous with Linux users. So yeah, I'm sorry. I believe Tiago Mendes has already made all the remarks I wanted to about late scheduling, and yeah, I'll be doing this with Tiago Marques. So we'll now start the track on image graphics and interaction, which will have 2 papers from our fellow colleagues of Friday. So I asked Nelson Rodrigues to present his work on a virtual and immersive underwater experience for science communication.
Hello, good morning. I will share my screen. Everyone can see my screen? It's okay. Hi, good morning. My name is Nelson. Today I will present my paper called A Virtual and Immersive Underwater Experience for Science Communication. I will try to start by contextualize the problem, talk about literature review, methodology, the results, discussion the results, conclusions, and the future work. This work aims to talk about the use of immersive technologies in science centers and museums. It was designed as a serious game as baseline that has the objective of recover 2 plastic bags from the ocean floor and were tested to interaction metaphors, a grabber and a robotic arm. Then were performed quantitative and qualitative surveys, but due to the limitations of actual COVID-19 pandemic, it was not possible to share virtual device with many people. What is the object of using immersive technologies in science centers and museums? On past, this process is mostly passive. It's by observation. It can be some ludic games, but the level of immersion is not very high. So you can take most about the recent technologies like virtual reality, and we can use multiple sensor data in a completely virtual generated world. And that could be a high perception of the process of learning something. As an example, a past project, Dsie, that has the aim of improved science communication and emphasize the urgency of preservation of the ocean ecosystem, also use these technologies. Inspired by the human-robotic interface in teleoperating underwater vehicles, we try a new approach and bring some interaction from this field. To do that, we set up an experiment with 2 different levels. This was the initial approach was in Dsie that has a grabber, and this was the robotic arm, the new approach used in this project. During the serious game, it was important to give massive information to the user, visual feedback, the mission status, the number of plastic bags that he recovered. When he touched a button, we can also have the haptic feedback, to give a little sensation when user press a intermediate 3D virtual component. It also implemented in robotic arm and also added in the grabber 2 cameras. One camera has the front location that can be here in detail. And the third perspective was put in here that we can have a broad vision about where the plastic bag is. Then was mapped the virtual reality controllers to control the grabber that mimics a claw. We have to select the side button to select the 3D object and to grab the plastic bag but press the grip. So we need 2 buttons. On the other interaction, we map the robotic arm to the touch controls. So we use the gamepad to rotate the first degree of freedom behind his bases. Then also we use the gamepad forward and backward to move the second degree of freedom. And the third degree of freedom is on the other hand, and also is up and down. The same mechanism to grip the plastic bag and to open and close the claws was use the grip button. And important, these degrees of freedoms are dependent between them. So when we rotate, example, this also will add a side effect. To give a sense of purpose was implemented a small mission that has the objective of collecting 3 plastic bags using a grabber, or on the other level, using a robotic arm, and also was asked to the users to exchange between the cameras. About results, we tried to collect or to use agnostic surveys. As an example, we have the system usability scale that aims to measure the user perception of the usability of the system. It's a questionnaire with 10 questions that has a Likert scale and tries to measure effectiveness, efficiency, satisfaction. The users that were tested, they have similar results. The average is the same. So we try another agnostic survey that is NASA TLX that has the purpose of measure the workload of the task. And is the result of weight average of 6 components: mental demand, physical demand, temporal demand, performance, effort, and frustration. The results are similar except for user 1 and has a very high workload measure. In this kind of survey, less is better, less punctuation, less score is better because we have less workload. We have a tendency to see that robotic arm has less workload, but is not significant. We're also collected game metrics, and we're collected the time that user need to conclude the mission to collect the 3 plastic bags, or the number of trials, and we see that the time as for both users have tendency to decrease with the number of trials. So, complementary, we try to collect qualitative data by asking some questions. I will evidence these 2. That was asked if the camera perspectives helps. At the beginning, this utility was not immediately perceptible, and was also asked what were difficulties of controlling the robotic arm. And users say that at the beginning, the coordination between 2 hands, and also they relate some depth perception issues when they close the plastic bags. So, due to the small number of testers and the similar results, we cannot conclude what was real the better approach. We have one user that on the NASA TLX has a different and evident result, but this can be explained because these users don't have experience with virtual reality, and this user specifically never had played a video game. The perception uses can be probably because they never use a VR set. At the beginning of the experiments, we set 5 minutes to experiment the game and to test virtual approach, but probably that was not sufficient. What was possible? Was possible to recreate a virtual reality underwater experience, develop 2 interaction metaphors. Unfortunately, as I said previously before, due to small number, was not possible to confidently conclude what is the best approach. As future work, we try to space trials in time because we are in lockdown since January. During the development, probably I would like to add a new level with completely virtual handlers to control the robotic arm and a button to open and close the claw. Why? Because this could be a test, because we don't have so much cognitive workload to remember the buttons, but we still pin, and we don't have so much dependency on the manufacturer of the controls of virtual reality. The camera has to be changed. Probably the best position to have the camera, it's above the capsule, pointing down, that we have a broad approach or broad vision of the field. And to try to avoid that the user already knows when plastic bags are, and we see that the locks, the time is decreasing. Try to put plastic bags in random positions. And also, if possible, have access to other manufacturers besides the Oculus Quest. That was the user to set up this experiment. These were the references used in this presentation. Thank you, and let's pass to the questions.
Okay, thank you, Nelson. Thank you for your work. And if you don't mind me asking, I start with one question of my own. How do you compare works of this genre with the state of the art?
Well, I didn't find any example on museums that use this approach of robotic arm. So I tried to bring from other areas like human-computer robotic interface to this specific case.
Okay. And the statistical evaluation is kind of inconclusive because there are very few surveys done, right?
The surveys, the techniques used in surveys, I will try to use agnostic questions, like is the system usability survey and NASA TLX, that are not questions made tailored for a specific problem, are generic, and are being tested in multiple cases, and also can be brought to the game industry. They are not specific.
Okay, thank you very much. So I'm now, sorry.
Let me start while other students prepare their own questions also. Nelson, good presentation, but missing one or two aspects that I believe are important in a case like this. For example, showing more state-of-the-art discussion, okay, about other studies, about other cases, about similar or not similar, because there are many works done in gaming and other studies, and you could perhaps show us more studies about state of the art. Your posture, you need to be more assertive, let's say more convinced about what you are saying, okay? This is something that we have to train, okay? We have to train, and after many presentations, we get this experience. Until there, it's usual to, you need to try to use again your colleagues, your lab, in your lab to make presentations. Well, your lab when you can. Yes. When you may be back to the lab. Okay. Also, the entry in the problem, the presentation was too fast, and studently we were seeing the summary of the presentation and why this problem and why the motivations and who are the authors, and some one or two initial slides would be welcome to start, okay, to break the ice. Okay, in technical terms, I have one question also. That is, the controls that are used are obviously very known, and they are common in studies like this, but in virtual reality, I would say. But these are not common devices. For common people, it is hard to understand how they work, and they have two buttons, you know, and they are very sensitive to the direction where they are, and the position, etc. So they are not very intuitive. And for certain applications, for example, like this, you had buttons. Visually, you had buttons in front of you. You have a board controlling all the device, and you had buttons, and we are physically used to use buttons, okay? Press buttons, rotate buttons, etc., etc. So my question is, did you think or not in making something similar but with mixed reality, let's say with physical objects interacting with the virtual environment? Did you think about this?
Actually, I didn't think in mixed reality. I use directly the virtual reality because it's the most immersive technology that we have. That's the purpose. But yes, mixed reality could be interesting because we can visualize the two worlds, the 3D world and the real world. and probably for people that are not used to be in immersive virtual reality could be a nice experiment.
Mixed reality is a little different from augmented reality. Okay, augmented reality is mixing both worlds, but in mixed reality we are using physical objects that actually influence, they control the virtual environment. You know, this is the difference. Okay, and I believe that in your case, perhaps it is one thing that you could explore. Okay. And the buttons, the objects can be virtual, but have a real concretization. You see, you can be seeing in your glasses a virtual button, okay, but you could have a physical button in a certain part of you where you press with your finger. That is more intuitive for a general user.
Yes.
About your presentation, okay, the slides were very, very nice for the objective. You need to make a deeper study of the state of the art and explain better how this control influence. Obviously, we understand that in this case, it is not easy to have more users to evaluate the system because they have to use the Oculus, and it's not easy to share Oculus between different people nowadays. So what is important in this case is to have the principle, the methodology. For the future, we could have better experiments, namely to make a better evaluation, for example, of the workload. And the workload is perhaps related with, again, the controllers. Okay. Thank you very much, Nelson.
Thank you.
Thank you, Professor. I believe we have one question in Slido from José Rodrigues, which asks if you have considered using shadows to help with that depth perception or a spotlight above the plot that can help guide the user's movements.
Yes, this is an underwater environment. Shadows are a little bit tricky because it depends on the depth. Because if you go to real depth levels, the only light that we have is the light from the submarine. So it's not easy to use shadows on this case, the light, but it could be a further development. And the other question was, if I use light to shadows and?
A spotlight above the claw to help guide the user's movements.
Yes, I didn't use a spotlight, could be a nice visual cue. I was thinking some arrow or some object pointing to a plastic bag to help the users that have more difficulty on that. But yes, it's a nice add-on.
Okay, thank you very much.
Thank you.
I now pass my word to Tiago Marques, if you don't mind.
Okay, let's stop sharing.
Tiago.
Tiago, não te estamos a ouvir. Tiago Marques, estás sem som. Aparentemente tens o microfone ligado, mas o som não nos chega. Traz o microfone do sistema operativo desligado.
No, we can't hear you. Can't hear you, Tiago. Not at all.
Consegue ouvir-me?
Agora
sim.
Sim.
Okay. We can hear you clear.
Now, can you hear me?
Yeah.
Yes.
Sim. Estamos a ouvir bem, Tiago.
You can hear me? Okay. And now it's me who cannot hear you all, but so now we have another presentation from José Rodrigues, who will present the pilot study improve user performance with object interaction in virtual environments? So it's up to you now, Jose.
Thank you. Can you see my screen?
Yep.
Yeah.
Okay. Okay. Good morning. My name is José Rodrigues, and I'll present my paper that it's titled Pilot Study, Improve User Performance with Object Interaction in Virtual Environments. The presentation contents will be divided into the objective and motivation, some key concepts to better understand what I developed, the experiment, the results and discussion, and the conclusion. The objective of this study was based on a previous application that is being shown in this video, where this application was developed to elderly people to be used in occupational therapy and rehabilitation homes to help improve some movement in the arms and legs. And in this case, I chose this scenario, the fruit shopping scenario, and that in the previous study had some complaints about interaction and people not being able to interact with the virtual environment being really difficult to them. And to that end, and to improve user performance in this application, I asked these two questions: if it is necessary to have a self-avatar to help improve that performance, or having a high motion fidelity on hand representation is enough for help them to have a better understanding of the environment and the interaction that they are doing. Some of the key concepts in virtual environments, and it's the sense of the embodiment that can be subdivided in of these three concepts: self-location, which is the sensation of being present in a virtual environment; the sense of body ownership, which is a sensation that the virtual body is our own; and the sense of agency, which is the sensation of being in control. For example, we are moving our real arm and the avatar or the hand is moving the exact same way with the low latency times. This sense of agency can then be subdivided in two different fields, which is interaction and motion fidelity, and these were the focus of the study. So the experiment in regards of hardware, we used the Oculus Rift bundle, which is composed to the head-mounted display, 2 touch controllers, and tracking sensors. This setup only allows us to have the 3 tracking points, which later on we'll find out that can be a problem. And then a laptop running the application. The application itself was developed in Unity. The avatar used was based on an avatar that's available on the Unity Asset Store for free, and then some edits were done in Blender to do the rigging and some alterations in the model. The ends model we used were from the Oculus Developer Center, and the animation was done in Unity to the ends movements. To animate the avatar was used the algorithm inverse kinematics and the variation that is on Unity Asset Store FastIK. This animation is the only possible to be done when we only have 3 tracking points, the head and the hands. To animate the arms of the avatar, we need to use inverse kinematics to animate the user's movements. The objective of the application within the game, it's to pick up the basket, collect the required amount of fruit, which can be seen behind in this panel, and then place the basket in this original starting place. The experiment participants. There were only 3 participants due to the same reason that Nelson said, because of the COVID pandemic. It's hard to do this type of experiments with many people. And the age range was from 28 to 35, which was not the ideal range, since the previous study was done in elderly people, which were all 65 plus. And the aim was to help that group of people improve their performance, but this was not possible to be done, and I had to do it with a different age group. So the experiment methodology was divided into phases. The learning phase, which lasted for 10 minutes, and people were able to change between the self-avatar and the end representation freely as they wished. And they, during those 10 minutes, they were able to do whatever they wanted. On the right side, we see the end representation. On the left side, we see a photo of exterior photo of the self-avatar of the person. During the testing phase, the participants had to do 3 tests of each case. The case of self-avatar and the case of end representation. And the objective was to complete the test as fast as possible and with the least amount of errors. All the participants did the tests in the same order, which caused some problems also. Here we can see an example of the application, and this is what the participants would do in the learning phase. They would watch what they are doing, moving their arms, watching the self-avatar, and then be able to change from the self-avatar to end representation only. And then they were able to explore the environment, see how things worked. This is just a small example. This is not a video from a participant. This is me doing this interaction, which I do have a lot more experience in this, so it seems like I'm being fast, but this is due to habituation to the application. The experiment, in terms of collecting results, I used a Likert scale for the qualitative analysis of the participants had to respond to if it was easy to pick the basket, pick the pieces of fruit, complete the task, and move the environment. And other the quantitative results were obtained during execution, and it was the time that they took to complete the task, number of fruit pieces that were dropped on the floor, and if the basket was dropped or not during the execution. In terms of quantitative results in the self-avatar test, in completion time, we see that all the users in the first test took a lot more time, and the number of errors was also more in the first test and in the last, and this is due to habituation. In terms of qualitative results, we don't see any of these categories being above a 3 in an average score. In terms of the end representation, we also see that there's a lowering time completion and errors during execution. And we can see that in terms of qualitative results, we have an average higher than we had in the self-avatar. So in comparison between the two tests, the self-avatar in blue and the end representation in orange, we can see that the completion time was a lot lower with the end representation, and the users liked it more using the end representation. So this can be explained to various factors, and the self-avatar implementation could have been better because the tracking of the head and the end's position and rotation can be difficult to create a realistic torso rotation, and sometimes the users felt that the torso was in the way and obstructing the view. Sorry. And holding the basket felt awkward with the self-avatar. This was possible due to the lack of rotation, but was also possible because the model of the basket was considerably large compared to a realistic one, and the users needed to have the hand in the weird position. The order of the tests was not randomized, nor alternate, and this could also influence the results because the self-avatar was done first, and then the hand representation was later, and this could have also affected the results because people got habituation in the first case faster than in the second. In terms of conclusions, the hand representation had better performance in terms of execution time, subjective evaluation of the users, and the users felt more visibility and more freedom in the virtual environment while using only the hand's representation. The self-avatar with only the head and the tracking can feel awkward by the user. In terms of future work, so it's create a better self-avatar, apply a torso rotation based possibly only on not only on the position of the head, but also on the position coordinate mixing both the head rotation and the position of the wrist, or add additional tracking points, for example, small dots in the shoulders that can help position better the torso. And also expand on the evaluation tests, ideally with a target population and more users and a different evaluation type of qualitative results, just like the system usability scale. And that's all for me. Thank you.
Thank you very much, José. So I'm checking Slido, and we have a question from Nelson, which is, having an elderly population and or with reduced mobility, will be necessary additional development, for example, on tracking system to cover these use cases?
Yes, that's also a significant problem when dealing with elderly people, because sometimes movements that we do easily, it can be difficult for them to do, and having other tracking points might be helpful. For example, shoulders, elbow, waist, for example, could be helpful to make a more realistic animation in the model.
So for now, no further questions.
Okay, I can take the questions. José Rodrigues, good presentation, more or less in the context of this conference. You started with the context, the objective. The objective was very well described by the movie that you presented us, with the cubes and the hands as an alternative. So the question is self-avatar. Yes or no? You started, sorry, you continued with some key concepts with the sense of embodiment. And let me make one remark here. I didn't hear about this definition, sense of embodiment, later. So you made a definition, but you did not continue using it, okay? So it looks strange, okay?
Okay.
It looks like only I have to, okay? I have to do this. After that, you went immediately to the experiment. So the state of the art got more or less weak in this case. Okay. Again, you didn't discuss the several alternatives that we may have, we can find in the literature, etc., etc. You went directly to the experiment. I want to make this experiment. Obviously, we understand that the number of participants has to be low. Again, the same problem. You define it also the objectives of the experiment, and after that, the methodology. 10 minutes of learning. And I believe this is important for persons that are not used to this environment. But let me ask you one thing. The cubes disappeared.
Yes.
The experiment was only conducted with hands or complete arms?
Yes, the cubes completely disappeared, yes.
Okay, so this is not completely in accordance with the initial objectives that you presented in the paper, where you discussed cubes versus hands, okay?
The main objective was to replace the cubes with a more realistic feel for the user.
Okay, so you are saying cubes are to put on the side.
Yes.
We want to have the best solution, not the cubes. And so I want to concentrate only in alternative solutions, not the cubes. We can accept that. In the tests, I think that there is one thing missing here. You know, I'm not comfortable with those evaluations based on questions only. Do you think this is good? Do you think this is bad? We have been talking about this before. But I like making the evaluation of these situations, evaluating times, for example, in tasks, and evaluating errors, and etc. So we have to make different tasks, not repeated tasks. And here, I don't know if you have, for example, the task of taking that object. You have a basket with several fruits, and one thing is to take the first fruit that you have in your hand, in your virtual hand, okay? But another different thing, very different thing, is to have to choose that fruit, okay?
Okay.
Take the orange, and there is only one orange in the basket, in the middle of the other fruits, for example. Here you can measure the number of errors that can be more or less immersed in the rest if you don't think about this in this aspect, okay?
Okay.
As if I understood well, only hands are preferred than the complete arm. Well, is this a case of realism representation, or
probably because of the implementation of the avatar and the inverse kinematics that I used, because in other literature, when it's dealing with small objects manipulation, usually self-avatar and representation have the same, or more or less the same response from the users.
Yeah, so, because only hands is also strange, isn't it?
Yeah.
You see the hands, but no connection with you.
Yeah.
So the self avatar is difficult to understand, in my opinion. And the other thing is the order of tests not randomized, and this is your sentence, okay? And let me ask you, if you want to make this randomized, how would you do?
Either way, I would say, the user would start with a randomized order with a hand representation and the self avatar, and then with an alternation between them. So, for example, start with self, then hand representation, self avatar again, hand representation, self avatar again, and representation, or and representation, self avatar, and representation, self avatar.
So there are two families of experiments, in my opinion. You can maintain the same user and make several tests in sequence, okay? Or you can have the same test sequence changing the users. It's more difficult. It is more difficult, but is more reliable, in my opinion. What do you think?
Yeah, it's probably more reliable because people will, with more time between experiments, people will tend to forget the habituation, and that we can have a better understanding in terms of time, in completion time and errors.
Okay, and I am done. Thank you very much. Your slides were well. Your posture is good. Also, good objective, good context, poor state of the art. Okay.
Okay, thank you.
So we have another question on Slido from Mr. Anonymous, who asks, do you collect user profile information such as age, gender, etc.? Perhaps these informations could be important for future comparison. What do you think?
I tend to collect only age and gender. Age is important. I think gender not so much, but age people with old age most of them tend to have difficulty adapting to this type of technologies, and I could observe that in when I realized the first study which I based this one. But
okay.
In terms of gender, I did not see any difference in that.
So if there are no further questions, I think we are able to close this session. From what I see, there's now a break, but we are a bit late. So maybe I'll just pass to Tiago Mendes. Thank you very much.
All right, thank you, Tiago Marques. Thank you.
No. We have to applause the
all right, okay.
chairs and the speakers. I'm sorry.
Well done.
Thank you.
So, as you know, and some of us know, PhilP, and so the Faculty of Engineering is surrounded by research labs. These are very important, and they perform excellent research. So next, we will be exhibiting a video to present one of those labs. So the people that are following us on the streaming channel will be able to know what happens inside those labs and the projects they are doing. Following that, we will have a break. So we plan to have like a 20-minute break. So I will say we will be back to here at 11:30. All right, so guys, see you soon.
Can't we make a smaller break? Because we are a little delayed.
Okay. We have some margin on lunch time, so I think we can have it. Okay, all right.
So we'll be back by
11:30.
Okay. Okay.
CELSOS stands for Health Monitoring and Lifelong Capability Management for Self-Sustaining Manufacturing System, with the aim to reduce costs, increase OEE, but even more important, to increase production reliability. 15 partners from 6 countries approved the applicability of this solution on component, the system, and the line level.
CELSOS project for us was important to understand and to learn about asset utilization, because implementing Celsius in the press shop, in particular in our press line, up to now we are able to know exactly more about asset utilization, about predictive maintenance, and also we are able in real time to display the performance of the equipment.
Poor quality results in disruption on the production line, test failures, rework actions having to be done on engines, and ultimately this leads to ongoing costs for Ford, as well as possible quality issues in vehicles in the future. So the aim of Celsius is to address the root cause of these problems, which is the issues that develop here in the doser. So Celsius has added a number of sensors to these machines, such as these hydraulic sensors here, temperature sensors inside the working area, and these are monitoring the characteristics that the machine is showing throughout its cycles and looking for trends that are signs of deterioration. All of this data is uploaded to the cloud-based system.
In case of Harms and Wende, the main market is the automotive industry. In this automotive industry, it's very important to reduce the downtime because each downtime costs a high amount of money. For this, we developed here an algorithm to reduce this with the limping home mode.
This limping home mode, the data which are provided by Harms and Wende via the cloud services, we can use as IMF Werner to reduce the dynamics of our linear axis and therewith prolong the overall lifetime and reduce maintenance and therewith costs as well.
So equipment health is very important for us. The Celsius demonstrator is one of our flagship demonstrators in that area. And some of the things that it does for industry is it enables them to spend less time in non-value-added activities, for example, investigation of failures. By providing more information, it means that the operators can perform their tasks and activities quickly.
Here we have our Celsius demonstrator cell. It is a self-monitoring device that can self-heal from a catastrophic event such as a collision. So this is the collision that is programmed in. From here you can see that the springs have retracted, and this is now doing a pressure test to make sure that it has fixed itself correctly.
Welcome to the Sound and Music Computing Lab at the Department of Informatics Engineering of the Faculty of Engineering of the University of Porto. Our mission is to develop technology and content for users of all levels of expertise to engage in creative musical tasks. We aim at devising novel means for interacting with sound and musical content that sit at the intersection of sound and music description and interaction. Research and projects at our lab cover topics such as audiovisual information retrieval, including audio signal processing, computational musicology, and machine learning applied to audiovisual manifestations. Within the field of interactive music system, we cover research areas like sound design for non-linear media, immersive sound environments, new interfaces for musical expression, and 3D spatial sound. Our success lies in our ability to gather senior and postdoc researchers with junior researchers and students in a creative atmosphere. And this is what defines us, a place at the threshold of scientific and artistic innovation, fueled by its people, driven by creativity.
Okay, hello everybody. So welcome back. We're back to the DSIE 2021. Now it's time for session 3. This session subject is information systems and software engineering. André Gonçalves will be animating the session. So André, are you ready?
Yes.
Okay, move on.
So good morning. Hello, everyone, and welcome back to the Doctoral Symposium on Informatics Engineering. My name is André Gonçalves, and I will be hosting the next session, which will be devoted to information systems and software engineering. This track will feature, again, 3 papers by junior researchers under the doctoral program on informatics engineering at PhilP. And without further ado, I think we can call our first speaker, Soraya Felicio, who will be presenting her paper titled A Study on What Developers Ask About Issues Involving GIS by Using Text Mining Techniques. Soraya, if you're ready.
Ready. I share my screen.
All right.
All right.
The stage is yours. Please go ahead.
Can you see my screen?
Yes.
Yes. Okay. Can you start?
Yes, please go ahead.
Good morning. My name is Soraya. The title of my work is a study on what developers ask about issues involving GIS by using text mining techniques. Regarding the agenda, I'm gonna about the introduction with motivation and hypothesis and research question. After that, literature review, methodology, results, and conclusions. The context of this work, I consider GIS, Geographic Information System, is a computer system has functionalities that involve several techniques. Furthermore, a system has input and output of information. In this particular case of GIS, a GIS allows the manipulation of geospatial data, which are described by geographical location characteristics of surface. The work treats an informal context that involves Stack Overflow repository. That is a question and answer forum and content interesting information regarding geographic information system GIS topic. In addition, this work involves a formal context through the Scopal repository, is a big data with scientific works. Now, regarding the motivation, the software developers have demonstrated an increasing interest in technology for big data application. This is demonstrated with more than 4 million developer participants and 40 million questions answered in Stack Overflow repository. Continuing in the introduction regarding research question, the idea, this research question 1 is to identify related documents. How are related documents involve GIS and routing organized. About the research question 2, the main idea, GIS topics, what topics involving GIS do developers commonly ask? About research question 3, GIS topic hierarchy, how can these topics be organized into a hierarchy of topics? Finally, research question 4, the main idea, GIS topic popularity. What topics are more and less popular among the GIS developers? About hypothesis and the contribution. Initial hypothesis, I suppose that there are numerous publications and a lot of questions about this topic. About the contribution of this work, this study can help a lot of research and developers to deepen their knowledge about GIS topics within the scope of routing. In terms of the literature review, I study about Stack Overflow and GIS, finding data mining. There are many works about Stack Overflow. Stack Overflow is a question and answer forum that contains a lot of information where we observe several aspects about software development. The GIS, it is topics of growing interest. Our interest is within a context, routing, optimization technique, data collection process, improving of this process. About data mine allows to identify useful related patterns. It is a very popular area among the research. Now, regarding the methodology, this figure shows in an overview our methodology. The methodology has 7 steps. First step, this main ideas for each step. Step 1, download Stack Overflow data set. Step 2, we identify GIS tag set, about 60,000 tags, among other files extract from repository. Step 3, mine the main idea, mine tags from file XML. We employ tokenization by the use of RapidMine2 and text process extension. Step 4, we identify related documents from Scopus site. This step is related to question 1. Step 5, the main idea, determining GIS top tag set. This step is related to research question 2. We identify in this step 54 tags related to these GIS topics. Step 6, constructing GIS topic hierarchy. It's related to research question 3. We grouped similar topics into lower and higher level categories according to the objective of each topic. Finally, step 7, the main idea is to determine GIS topic popularity. This step is relation to research question 4. Now, about the results regarding research question 1, the main idea identify related document. Our finding 1, we identify 1,310 documents since 1980 to 2021. The year with the highest of number of publication in 2014 with 85 publication. The figure shows a decline after this year 2014 here. After year shows the graphic show decline after this in publication involving these topics. Now we have our finding 2. The table shows engineering and computer science areas stand out, like this. It is obvious because these topics are related to technology, but I observe that other areas that have some interest in these topics, different from the technologies. For example, social science, decision science, psychology, neuroscience, etc. Still, regarding research question 1, finding 3, the country that has published the most in the last few years until today was the United States, like this figure shown. In finding 4, finding number 4, there were 85 publications in 2014. The same idea, the same conclusion, the previous table. The table shows the engineering and computer science stand out, but I observed that other areas that have some interest in these topics. Regarding research question GIS topics, research question 2, the main idea GIS topics. 5 developers ask a question about a broad spectrum of 54 GIS topics, including these topics. These topics cover 184,262 questions about GIS topics identified. And finding 6, developers ask much question about Google Maps, and the last about RGEO. RGEO is a geospatial data library for web. In our finding 7 regarding is relation to research question 3, the main idea GIS topics hierarchy. According to the stable question that GIS developers can be grouped into a hierarchy with 9 higher level categories, algorithms, hierarchies, etc. We consider the objective for each category. We observe that Google Maps category, for example, have had more questions than this. However, the GIS category individually correspond to the majority of the related tags in relation to other tags. I could separate in another way. For example, I could put here is a platform, GIS platform, here and the ArcGIS are GIS platform. So I could separate, I could put here and the ArcGIS same category, but I think it is better separate them, because here and ArcGIS are different tools to routing system development. I use the same idea to other categories. Finally, find 8. The figure shows the popularity of these GIS topics measured using the quantity of question by tags, the quantity of question in axis Y. We consider the quantity of question to express the popularity of this topic, because we observe that each question generates several views. So first, we conclude that the more questions, the more views. In the axis shown name of tags. Therefore, the question related to Google Maps, for example, are the most popular, and the question related to RGEO. I said about these tags. Our conclusions in this study, we studied the Stack Overflow in an informal context to understand the interests in the GIS topics, and Scopus in a formal context repository for evaluation of scientific works. We infer that develops this question about GIS topics, organize them into a hierarchy of topics and measure their popularity from a Stack Overflow repository. The initial hypothesis was rejected. The results showed a reduction in the number of publications in relation to GIS topics over time. Although we find several interesting results in both contexts. About future work, I suggest leading similar large-scale studies using more triangulation with our results, investigate the GIS topic related to IoT, data mine, among others. The depending of this work related to find innovative idea to routing algorithms as Dsie and A star, matching with the techniques, libraries, tools found in this work. Thank you. Any question?
Yes. Thank you very much, Soraya, for sharing your work with us. I'd like to remind the audience they can submit their questions on Slido through the code 482295. And while we wait for questions from the audience, perhaps I can pass the word to Professor Augusto for some comments.
Okay, thank you for the opportunity. Soraya, first about the presentation. Your English is not completely bad. Don't understand me badly, okay? Your English is not completely bad, but you need to practice, okay? You need to practice more. You are in the same place as I am, okay? I have also the problem of not practicing too much. About the presentation itself, okay? You took the GIS subject that is curiously a subject that's in fashion because of the mobile devices nowadays that are introducing more and more this technology in or this area in the technology, better saying. But your conclusions are perhaps a little different from this, because you are saying that in the last time, the number of publications, the number of scientific works have been decreasing for the GIS area, and this is not accordingly to my understanding of the problem, because every day we have new technologies, we have new platforms, we have new applications of GIS. Do you want to comment on this?
I think this keyword only GIS and the routing. Perhaps I other way to search this about these topics. I and other way other areas within IoT or within data mining. I think I found more publication in the IS. I wanted to study more.
Okay, let me tell you also that during your presentation you showed us some graphics, some tables, and the subjects that were mentioned in them were sometimes, in my opinion, mix of different things. For example, you are mixing technologies with algorithms, technology platforms. You are mixing completely different things that obviously you are searching for everything about GIS. Okay, I can understand that, but for example here, algorithms, okay, it's great, but immediately you have here is an application, a platform.
Yes, yes.
Okay, after that you have ArcGIS also. Geocoding is a technique used in GIS systems. Geolocation is also a technique. you are mixing different things here, and it is perhaps necessary to search for subclasses. Let me use this word, subclasses. Okay, you need to classify what do you want to search for, because, for example, searching for applications here, or ArcGIS, or Google Maps, it's searches that are being made in the net about these subjects. It's not science, it's not scientific publications. I don't know if you want to isolate scientific publications or not, but you need to distinguish between things that anyone searches. Sometimes I make some searches. How do I do this in Google Maps, for example? Okay, but this is not an important search. It's the search that anyone can do in the net. Okay.
Okay.
So your hypothesis was rejected. Okay.
Yes.
Sometimes it happens. Our hypotheses are not true. I believe that your hypothesis is a little light. It's not too deep. Okay, it's a little light. But anyway, okay, about the presentation itself. Let me say that the slides have too much text, for example, this one. And sometimes you were actually reading the text in the slide. It's a defense of yourself. Yes, it's your defense, right? To be sure that you don't forget to say something. But try to do this with other technique, okay? The slides must be short, short sentences, keywords, not more than that.
Okay.
Well structured with a good hierarchy of subjects, of words, etc. And this is not what I can see in your slides, okay? Slides, okay, I'm done. Thank you very much, Soraya. You have to practice, but you are in a very good way, okay?
Thank you, okay.
Thank you, Professor Augusto. So we have not had any questions on Slido. So Soraya, if you allow me to ask you, and starting from what Professor Augusto said, do you think it is possible that Stack Overflow searches are not completely indicative of the attractiveness of the GIS topic we see nowadays?
I think I need to investigate more in another repository. Stack Overflow is the repository a lot of study and study and used for by developers, because
yes.
I chose this repository, but I think investigate more other repository.
Okay, thank you. And do you have any possible suggestion on how to complement this search?
Just the search, I don't know. That's all.
Well, okay, you reached the rejection of the hypothesis, so your study was well complemented. Thank you very much. And if we have no further questions, let me just double check. I think we might move on to our second speaker, who is Danielle Ping.
Stop my chair.
Yes, sorry. So Danielle will be presenting his paper titled Enterprise Architecture as a Support for Information Systems, a Review. Are you there, Danielle?
Yes, I'm here.
All right, so the stage is yours. Please go ahead. Good luck.
Okay, so as André has said, my paper is entitled Enterprise Architecture as a Support for Information Systems, a Review. These are the topics we'll be covering today. I'll start with an introduction, and I'll talk about the motivation of and the research questions, the methodology, the main findings we found in the literature. We will discuss such findings, and then we'll conclude. I have some concluding remarks. So currently, as one might expect, the current markets are highly competitive and things are changing all the time. And being able to react to these changes that happen is very important for us to ensure that an organization can stay afloat. Take, for example, what happened last year around this time of the year, when due to the pandemic, everything shut down and organizations and companies had to change the way they do business or even how they work internally to deal with such changes. Here I would like to introduce a concept of the information system, which is a set of software that contains, as you might expect, information about the organization, whether it's financial data, about people, manufacturing, inventory, etc. And it should represent the organization and how things in it are related. It should be a current relation. It shouldn't be about the past. It should be about the now. And so we have this need to keep up with the changes in the organization to ensure that what we see in the system corresponds to reality. Meanwhile, there's another concept I'd like to introduce, which is the enterprise architecture, which is a set of practices that help us deal with how we structure the enterprise. We should find practices and principles that we should follow to ensure that the enterprise has a healthy structure. It helps with the way the architects think about their systems, the enterprise that is. It gives them tools, and so this really helps with organizing the enterprise. There are several frameworks that help with this, such as Ackman and TOGAF, which are fairly well established, and they can really help with the enterprise. They can be applied to most types, almost all of them, types of organizations, whether they're governmental, they're private companies, or even, for instance, hospitals. And since they try to support organizations, we could see that they can probably support the information systems. And so our main objective comes from this. We want to learn more about how the enterprise architecture supports the information systems and thus the enterprise. Taking this subject into account, we have a main research question, which is about how the enterprise architecture enables the engineering of the information systems. And since this can be a bit vague, I've subdivided it into two sub-research questions. The first one is about the roles that enterprise architecture plays. And the second one is about how the enterprise architecture supports the migration of different states of the information system so that it can always be up to date. So since we want to learn more about the subject, we decided to do a literature review, and this had two main phases. First, it's about the selection of the papers, which I'll be discussing in this section. We have then from that part a list of papers that we will be analyzing and reviewing. And then we have the analysis phase that will be discussed in section 3, which is our findings. So it's important to know how we're going to search for the papers. And so we decided to, for the search query, we wanted to explore, as I've mentioned previously, the relationship between the enterprise architecture and the information systems. And if we also want to talk about the implementation from how information efforts will be about how the organization can adapt to itself, we want to also include that in our search query. Scopus also has a good number of relevant publications. And so limiting to a single database can also help with our reproducibility of our work. If you want to research again, we should try to research again, and doing the same database can help with this. So this is the search query that we ended up with. We combined the topics of enterprise architecture and the information system, and also talk about the implementation of the system. Our search process was conducted in November of last year, and we ended up with 51 papers. Although due to time constraints, I needed to reach a more manageable number. And so after reading titles and the abstracts of the papers that we found and choosing the most pertinent ones, we ended up with a set of 20 papers, although one of them was unavailable for me to consult, so it was reduced to 19. These are some statistics of the papers that we found that are in the final review sets. There's an even mix of conference and journal papers, and they have been mostly sprinkled out since 2005, with most of them being recent. As for the findings, the main ones are these 7. These are the concepts that, after reading the papers, I identified as being fairly frequent and related to each other. I'll be discussing them in this section in more detail. So starting to discuss about the enterprise architecture, as one of the key things that I found is that EA helps with the alignment of the business and the IT resources. The IT resources in this case being not only the information system, but other resources related to technology. There are different types of architects, whether they are business architects or IT architects. And so we have this need for collaboration between people with different roles. The fact we're also thinking about how the enterprise is organized also helps us see it brings the information system into view. And so we can put more efforts because we can be aware of its existence. Finally, as I have mentioned earlier in the introduction, the frameworks do help, and they list products and things we can do to help with the organization, such as for the information system implementation and the existence of the current state and where we want to go next can be helped with the transition plan. Now, as for good practices, there were different examples, quite a lot of them, but I chose here some examples to talk about, mainly the adoption of the frameworks and methodologies, because we have things already established and we know that they will work. The transition plans are also very useful because given 2 states where we are today and where we want to be in the future, we can outline a path to go through to ensure that we don't really stray from the path. As mentioned earlier, the good alignment of business and IT resources is very important because it means that the information system will in fact reflect the state of the enterprise and its objectives. And finally, being able to go through continuous maintenance and to have good documentation that's easy to understand can also help. As for effectiveness, it's important to be able to measure how effective a system is. And so having the commitment from the top managers, having clear defined goals about where we are and where we want to be in the future, also ensuring that being aware of the skill levels within the organization and having proper communication canals between different types of people helps are good measures for us to be aware of how effective it can be. It's also important to be aware of the innovation and adequate tool support to ensure that the enterprise architecture efforts are effective. Another concept that appeared, and it was quite important, was the IT governance, which means that the IT resources we can manage the IT resources, and we can, through decision making and strategic planning, decide where we want them to be best used. And it brings several benefits, such as being able to respond to changes in the market more quickly. It also helps with the business alignment that is so important. And also being able to manage proper risks and know what things we should avoid and what things we should lean towards is very important. It's also important to notice that the literature also talk about new things, new methods, new technologies, even the application of enterprise architecture to new contexts. Most of the literature talked about different methodologies or frameworks. An interesting example was the use of agents who have specific behaviors, and they could be proper, and they could potentially be used to deal with some issues that may be hard to automate. Talking about the alignment that I have already been talking about, it means that the alignment could be defined as the degree to which the IT resources and the business support each other. And both governance and other guidelines from enterprise architecture can help with this process. Having everything aligned is important to ensure that our resources from IT are functional, because they can essentially be useful where we want them to be. And having this alignment also allows us to see particularly due to the information system, we can see different views of the organization under different outlooks, so that we can be more aware of the different relationships between different parts. Of course, seeing that we are talking about enterprises who may be large, there are some challenges associated with it. namely the different people and different processes and different systems. It's important to be aware of this because the complexity can be a big challenge to overcome. It's also, we want to ensure that our software and our technology stack is up to date, and we have to deal with that. Additionally, other challenges, particularly relationships between the social context within the enterprise, the processes we use, the technologies in play, and also the proper organizational structures, such as the dynamics between high-level executives and lower-level managers, can in fact influence how we do things. And so being able to tackle these issues can also be a challenge. Finally, it's also important that there are many frameworks and techniques for enterprise architecture. And so we should be aware that there is no one size fits all. There is no silver bullet, and that depending on the situation we are in, we should attempt to analyze the situation properly and know what's the best thing to do. So taking all of these concepts into account, we'll be discussing it by trying to answer the research questions, starting with the sub-questions so that we can then make a more fundamental answer about the main one. So in fact, we could see that enterprise architecture does play a support role with this, not directly, namely the IT governance and its methods, and also the enterprise architecture frameworks are very important to ensure that the IT resource and the business resources are aligned. And if this alignment happens, it can mean that the information system is in fact in accordance to reality, because it's trying its best to model the business. As for the migration between the as-is and the to-be states, frameworks and implementation methodologies help this migration process, mainly because we can see from the frameworks, we can map out the as-is states and the to-be states, and then we can see that we can reflect on how they are and how we can get to where we want to go. And so the creation of a migration plan can really help us define the pathway and the roadmap for us to go from one state to the other. And also, if we are following our plan, we can be sure that we will not go off track. It's also important to note that if our needs change, if the market changes and our to-be state, in fact, shifts in another direction that we may not be expecting, being able to do this iteratively can provide some agility to our process, because we can adapt our migration plan and ensure that we aren't really losing much progress. So the main question about how enterprise architecture enables the systems engineering can be relating these different concepts as I have referred to before. The enterprise architecture, in fact, uses the concepts of IT governance and frameworks to facilitate the alignment that I have mentioned previously, which is a key component in the support of the information system. Additionally, the migration between the as-is and the to-be stage, which are mapped by the implementation technologies, supports the adaptability that we desire to see in an organization. So for our conclusions, the main takeaways from this work is that the information systems are valuable tools because they allow us to react to the market and help with our decision making. And they can be supported by the enterprise architecture, as we can try to ensure that our business resources and our IT ones are aligned, and the information system can map reality. Being able to iteratively use enterprise architecture practices and to ensure that we can know where we are today and where we want to go is very well defined, help this alignment, and we can be more adaptable as we can be able to react to market changes or different situations. However, there are some limitations to this work, which we aim to do so to tackle in the future work. Namely, we could expand our research queries, namely because we only chose one database. There are plenty more papers and journals that we could read in the literature. And also we can go deeper down into each area to really discover potentially new relationships. This has been my presentation. I'd like to thank you for your time and your attention, and I am open to questions.
All right. Thank you, Daniel, for a very insightful presentation. I can see you already have some questions coming in through Slido, but I don't know if Professor Augusto would like to make some remarks first, or if we should enter the questions before.
I can go on. Okay, Daniel, good presentation in some way. Your English is perfect. Perhaps sometimes you need to slow down a little. You speak too fast for some people, but it's okay. Your slides. Let me say that I enjoy that presentation based in cells like tables. Okay. On the left, you have each subject. On the right side, you have the comments for that subject. But sometimes in that cell, the text is too long, okay? And you have bullets inside the cell that are not easy to find, okay? You have to improve. Even it's a good technique, but you have to improve. Reduce the text and make things even more visible, if you want. My main question about your presentation is, I understand that you need to do this, but we are in an engineering school, and in engineering we are used to use numbers. And in all of your presentation, I didn't see any number in the evaluation, or it's only theory and more sentences and more let's say things that are not completely proved in this presentation. You say one sentence, you say something, but this is your interpretation, or that is a conclusion that you take from the data that you have seen. What we cannot be sure about those sentences. Okay, so all the evaluation is too much personal, if you want. Okay, and we need to understand that from all the publications that you have seen, this subject was mentioned in 3-5 publications, so represents 10%, or if we need numbers. We need to understand what is the tendency, and not only your own interpretation. We didn't see the papers, okay? So what you are saying may be true or maybe not, okay? It's your personal interpretation, and you need to show us that it is not only, I believe that it is not only your interpretation, but you need to show us that it is not only your personal interpretation. Do you want to make some comments about this?
No, your professors have pretty valid points. Improved materials could in fact be to outline which papers discuss this topic, which in the paper I state who the authors were, but for the presentation it just slipped my mind. And in fact, I could even posit a possible future work where we could in fact try to use enterprise architecture to see how well we could improve an information system.
Okay, try to answer the research questions with something that is we can measure. We all can measure. Okay, not only you. Okay. So this is my main remark. Your final conclusion in the discussion, before the conclusions, is the information systems are a way to facilitate the adaptability of the organizations. If I understand this well, it's more or less something that we know. Okay, I was expecting something more. Do you want to comment about this?
That part was mostly to reiterate things you already knew, to then add on the part of the enterprise architecture to reflect on what we have learned from the beginning to that current part.
Okay. And do you think that consulting more databases will change too much this?
Maybe,
You
of course.
mentioned this in the future work. Okay?
Yes, it's something that trying to find out more and researching more is always this. It will always yield that question because you don't know what you may not know what's out there. So we could in fact learn something new. However, we could also possibly have really covered our bases, and it could be time for a deeper dive into each part of each characteristic we found.
You used Scopus, wasn't it?
Yes, we used Scopus.
It's a good collection. It's a good sample of what is being made around. Okay, but okay, thank you very much. More questions from the audience?
Thank you, Professor August. We have at the moment 2 questions from the audience, so let's try to cover them with some haste. So Pedro Moreira asks, why was only one search keyword term used on the?
Hang on, let me just check this again. Okay, so the query, only one of the keywords?
Yes, I believe he's referring to enterprise architecture.
Okay, we decided to go with enterprise architecture because it was an established term. It has been in use since the 80s, at least maybe earlier. I cannot really remember correctly. And I felt that it could be wide-reaching enough to find out more about what we wanted to discover.
Okay, so thank you. Tiago Marques asks, EA can vary a lot across sectors. Did you identify different thoughts and implementations of EA in literature regarding IS according to this?
Yes, there are several frameworks that help with implementing enterprise architecture, namely the ones I mentioned. Zachman is very a famous one because it maps different parts of the enterprise to different roles, and so we can see a distinction between the responsibilities and where those responsibilities affect the organization. There were several papers outlining different implementation methodologies, namely to use different types of frameworks and different tools and different types of frameworks. And yeah, that's what I found.
Okay. I believe this. Oh, we just had a new question from Soraya Felicio. How do you intend to expand on your work?
Okay, namely, by going deeper into learning more about each one of these 7 concepts that I identified. We really learn more about how each practices can influence the system, how we can ensure that the alignment and how to measure the proper alignment between business and IT. These are examples. Also, for instance, how to measure, how to attempt to attribute numbers to some of these concepts that may be a little hazy. For instance, how is the governance? How can we set a number about? Can we classify the governance of a system with a number? Can we evaluate this? These are potential avenues to explore deeper.
Okay, all right. Thank you very much. I don't think we have any more questions. So thank you, Danielle, and good luck in your future works. And last but not least, I think I would introduce our final speaker in this panel, Manuel Figueiredo. Manuel will be presenting his paper, Competitive Advantages of Information Systems in the Resource-Based View. Are you there, Manuel?
Here, yes.
Okay, thank you very much for coming, and the stage is yours. Please go ahead.
Okay, share screen. Okay. Okay, it's okay?
Yeah. Yes.
Okay, so moments. Okay. Good morning, everyone. I am double happy because my son was born on the 4th. So I have been without sleep for 2 days. It's okay, and also for sharing with you this research entitled Competitive Advantage of Information System in the Results-Based View. Okay, first, we need to understand that RBV, results-based view, seeks the necessary resources to design, choose, and implement structures that generate competitive advantage. Truth is valuable, is rare, inimitable, and irreplaceable resource. Okay, which results generates its three competitive parity, temporary competitive advantage, sustainable competitive advantage. It's okay, and Hotel organization view to classify the level of competitive advantage. Where to simple questions we can see. First, is the resource valuable? If not, then there is competitive disadvantage. It's okay. If yes, is the resource rare? If not, competitive parity. It's okay. If yes, is the results difficult to imitate? No, then temporary competitive advantage. Okay, if yes, is the results difficult to imitate? Okay, então, if so, there is the potential to generation sustainable competitive advantage. Potential generate sustainable competitive advantage. Okay, and finally is the firm organization to capture value. It's okay. So temporary competitive advantage. Yes, here are sustainable competitive advantage. It's okay. Now that understand RBV and competitive advantage, let's see what is competitive advantage are and how it was done to find them. The methodology was divided in two stages. First, bibliometrics and content analysis with objective of identifying important research and to assess progress with our research fields. And finally was systematic review. Systematic review done to find and document all the competitive potentials of information system, IS, in the context of RBV. It's okay. Okay. The result of the first stage was identify the paper of weight. It's okay. Review the results-based view and information system research. Review, extensions, and suggestions for further research. 2004. Okay, referenced 1,714 times in the last 50 years. Okay, it's also organized in 8 keys information system, IS resource. Wow, and well researched, so much so that only information system development did not have a specific systematic review until yesterday, because now it has. Okay. A systematic review. The systematic review was based on the work do Kitchen 2004. Okay, it was three steps: review planning, where a protocol was built. Afterward, it was conducted, being found 91 papers and 66 deleted papers. Okay, and review analysis. Finally, analysis was carried on with 25 select papers. It's okay, and 25 select papers is no analysis. Okay. Competitive advantage is development is sustainable competitive advantage. Okay. Information systems development is a sustainable competitive advantage. A right level of capacity to develop innovation is competitive advantage. Valuable is unique knowledge which lead to better performance and competitive advantage. Development of dynamic organizational capacity contributes to performance of achievement and sustainable competitive advantage. And signification relationship between intellectual capacity, capital intellectual, and information system development performance. Okay, between relationship. And there was result research. I can say that the competitive advantage attributed to development of the information system based on results-based view is capable of generating sustainable advantage, and this has a direct impact on organizations and their decision-making process. It's okay? Thank you very much. Any question?
Thank you, Manuel. Let's wait just a minute for questions in Slido. Meanwhile, I don't know if Professor Augusto wants to take the stage.
Okay, Manuel, first thing, congratulations, and my best votes for the future of the new father and the new child. Okay, about the work itself. Well, first thing is you need actually to practice your English. Okay, you know
Yes.
it, but as you have to assume this. Try to speak to your colleagues in English. Try to use English as a more used language in your, let's say, day by day. You know,
Okay.
so you can improve it because even when we are more used to the language, when we face a room full of people, we get nervous, we get, and things get more difficult. I believe that your English is better than you showed us now. But obviously you get nervous and everything gets more difficult when you are facing many people in a room. It's not the case, but yes, you are virtually also facing many people, okay? About the work itself, well, it was a short presentation, short in time, but also in contents. Okay, you mentioned VRIO, for example. So you mentioned sustainable competitive advantage as one of the objectives in that diagram that you had. That, for example, what is VRIO? I didn't see a slide trying to identify what it is. If you are speaking with your supervisor, obviously your supervisor knows what is. But when you are facing an audience, you have to give one slide or something trying to explain what it is. Okay, And why this technology, methodology, or aren't there any other technologies or methodologies that are also candidates for this job? Okay, why did you choose this? Okay, and this is science. Okay, this is searching for science, not only take the first one that we see and put in one slide. No, this is not science. This is doing things by hardware. Okay, no, you have to improve a little this part of scientific research. Okay, scientific research is searching for different methodologies that are alternatives and search and choose the best one, for example, and if possible, try to develop an even better one. Okay, this is what we are accounting that you can do in your PhD. I don't have many other questions. It was a little small presentation, and again, without numbers. What is the evaluation that you do to this? Okay, a scientific work must have an evaluation. You have to evaluate your work, others' work. I don't know, but you have to evaluate. Okay, this work is a kind of survey. Okay, but you need to compare things. If it is a survey, you need to compare things. Okay. Otherwise, it's not. What we are seeing here is your personal opinions again, but this is not science. To do science, you have to prove that this idea is true, using numbers, using questionnaires, using whatever. Okay. I didn't see about the structure of presentation. I didn't see a real introduction to the problem. Okay. You started immediately speaking about a resource-based view. I don't know what is the main objective, the main target of this work. Okay, and you need to do a context. Okay, the context of my work is this one. I am working on this. I am working on that, and my main objective is to attain that. Okay, what is the problem that you want to solve? Okay. I didn't see this. About the slides, okay, when the student, I am used to this, when the student has more difficulty in English, the slides usually have more text because the student wants to read the slides. This is also the case. And thank you. We are here to help you if we can to improve your presentations, to improve your work. Okay?
Okay, Professor. Thank you very much.
Thank you, Professor Augusto. So if you can tackle the questions on Slido now. Daniel Pinho asks, out of the sources of competitive advantage that you mentioned, which one do you think would be easiest to implement in an organization?
Sorry, I understand.
So out of the sources of competitive advantage that you mentioned, probably close to the end of the presentation, which one or which ones do you think would be easiest to implement in an organization?
In organized implementation, in organize, and let's find.
Manuel, if you prefer speaking Portuguese.
Yes, please.
In this part of the presentation, if you want to speak in Portuguese, answer in Portuguese.
Okay, por favor.
Okay. So, em português, entre as fontes de vantagem competitiva que mencionaste na apresentação, qual ou quais achas que seria mais fácil de implementar numa organização?
Não é apenas uma questão de uma ser mais fácil, mas é um conjunto, sim, entre todas elas, são 8 categorias diferentes. Dentro da Information System, nós temos uma capacidade dinâmica, onde a equipe de desenvolvimento, tendo um conhecimento adequado para fazer implantações de sistemas que de fato funcionem bem nas organizações, e isso é crucial. O que acontece é que, por exemplo, computadores, sistemas de informação são recursos que são fáceis de se adquirir. Mas quando a gente está falando de capital humano que tem alto nível de conhecimento, então esse recurso já é um pouco mais raro. E então, por ser raro e difícil de se imitar, então nós temos aí uma vantagem competitiva sustentável muito forte.
Ok. Sim, muito obrigado. So switching back to English, thank you very much, Manuel, both for your presentation, and I congratulate you both on your work and on your newborn son. And I believe this will wrap up the Information Systems and Software Engineering panel for now. I would like to thank again all the authors for your contribution for this conference, as well as everyone in the audience who is attending right now. I believe we are closing in on our lunch break, so I will pass the word back to Tiago Mendes before we sign off for now.
Yeah.
Thank you very much.
Thank you, Andre, for the nice work that you've done animating this session. So next, we will be transmitting another video about the research labs from the department, the Informatics Engineering Department, and we will go into the lunch break. So I will say that we need to be back by 2 p.m. So I think it's enough for our lunch. So have a nice lunch, and we will see you all at 2 p.m. here in the same place. So thank you.
Okay. See you later, guys. Thank you very much for all.
Thank you.
Manuel, parabéns pelo Systems Lab at the Department of Informatics Engineering of the Faculty of Engineering of the University of Porto. We focus our work on the fields of computer systems, including advanced computer architectures, embedded and cyber-physical systems, and software notations and tools. Research and projects at our lab cover topics such as compilers and domain-specific languages, reconfigurable computing and non-conventional computing, performance engineering for high-performance computing, embedded and mobile computing, and distributed computing. Our success lies in our ability to gather senior and postdoc researchers with junior researchers and students in a creative atmosphere. Our mission is to perform applied and fundamental cutting-edge research to achieve consistent scientific advances, contribute to the education and training of human resources, establish cooperation with industry, and provide solutions for problems with societal impact. Here, one finds state-of-the-art tools and compiler techniques, FPGA and GPU-based heterogeneous computing, hardware that adapts on the fly, but mostly a constant look to the future of computing. And this is what defines us, a lab driven and inspired by custom computing and methods for accelerating changes, achievements, and innovation.
you.
Every day, researchers try to solve real problems through real science. Here, we do the same. We just take it with a pinch of humor and a creative mindset. Welcome to GIG, the Computer Graphics, Interaction and Games Lab at the Faculty of Engineering of the University of Porto. GIG is a place where science meets imagination and innovation is an attitude. Our mission is to research, explore and develop the fields of computer graphics, interaction and game design and development through the continuous evolution of the connection between people and systems. And we do so in a highly transparent, efficient, natural and pleasant manner. GIG is all about its people and what they can achieve together. We gather senior and postdoc researchers with PhD and master students and other junior researchers in a collaborative atmosphere that leads to top-notch research projects. Research at GIG in computer graphics revolves around 3D modeling and animation, realistic and real-time rendering, as well as procedural modeling of 2D and 3D environments. These core topics are explored at higher levels in contexts such as multi-sensory virtual and augmented reality or games. In the field of human-computer interaction, we focus on user interaction and user experience, applied not only to regular computer applications, but in particular to immersive or mobile environments. We combine technology and design principles to research and develop multimodal, natural user interfaces and study their usability. Graphics and interaction come to play together with other topics in the multidisciplinary field of game design and development. Here, we work not only in the processes of game creation, design, and development, but have a particular focus on serious games, location-based games, and gamification. At GIG, we believe that excellence in these main fields of research is only achievable through creative collaboration. To uphold this multidisciplinary approach, we work together with other key players at our faculty, such as the Sound and Music Computing Research and Development Lab or the Computer Graphics and Multimedia Students Group. We go beyond the Faculty of Engineering, having frequent collaborations with research groups at the faculties of Fine Arts, Psychology, Sciences, Liberal Arts, and Economics. This is what defines us, a passion for enabling engaging experiences through multidisciplinary research, from people to people. While Hollywood movies and science fiction novels depict artificial intelligence as human-like robots that take over the world, the current evolution of artificial intelligence technologies isn't that scary. From its beginnings in the 1950s, with neural networks steering excitement for thinking machines, through the rise of machine learning in the 80s, to today's boom with deep learning, artificial intelligence has, and will have a profound impact in our lives. Welcome to the Artificial Intelligence Lab at the Faculty of Engineering of the University of Porto. We are devoted to contributing to the theory and application of artificial intelligence, carrying out research and development activities spanning all dimensions of intelligent systems. Research and projects at our lab cover a wide range of topics, such as data analysis and engineering, multi-agent systems, natural language processing, intelligent robotics, intelligent transportation systems, and parallel and distributed computing. Our device solutions benefit from approaches built upon distributed and decentralized coordination and cooperation mechanisms to improve performance in rather dynamic and uncertain environments, as well as robust machine learning and data science algorithms with a vast range of applications to real-world domains. This is what drives us. A commitment to ensuring the ethical, transparent, and accountable use of artificial intelligence to impact society.
Hello everyone. Welcome back to the DSIE 2021 for the afternoon session. I hope you enjoyed your lunch and you are completely ready for a fantastic session that we will have. So fantastic phase of our conference. We'll have 4 sessions this afternoon. So we'll have one for NLP, so natural language processing. The second one will be about robotics and simulation. Then we'll have artificial intelligence divided by 2 sessions, one for techniques and another one regarding applications. So without further ado, I will call Gonçalo Leão to start the first session of the afternoon. So Gonçalo, go ahead.
Thank you, Tiago. Good afternoon, everyone. My name is Gonçalo, and as track chair of the Natural Language Processing track, I'll be moderating this session. This is the first of 2 sessions dedicated to NLP. The second session will begin tomorrow at 11 a.m. In this first session, we have 4 very interesting papers lined up. Our first paper is related to argumentation mining and will be presented by Afonso Souza. Afonso, the floor is yours.
Thank you very much. Hopefully you can see my presentation.
Yes,
so
we can.
my work is named Cross-Lingual Annotation Projection for Argument Mining in Portuguese. And this work is framed in the field of argument mining, which is the process of automating and identifying and extracting inference structures and reasoning over the arguments within various pieces of natural language mediums. And works in argument mining have almost been exclusively been performed monolingually, most prominently in English, German, and Chinese. This makes the availability of open source materials scarce in other languages. On the other hand, acquiring high quality data sets for new languages is an expensive effort, normally entailing hiring expert annotators or querying large crowds of crowdsourced experiments. So in the absence of good quality data sets, we can lean towards cross-lingual approaches, which are increasingly recognized as necessary to work in less resource languages. As such, this work emphasizes on the construction of a Portuguese machine learning version of the persuasive essays corpus. For this end, an annotation projection algorithm was proposed with some tweaks to improve performance for verbose source languages. Also, the created dataset was evaluated both intrinsically against its back projection version and extrinsically evaluated in a token level sequence tagging task against the state of the art. So the corpus used was the persuasive essays because it's the only public available dataset that conforms to the premise conclusion argumentation model. This dataset comprises various essays written by students in response to controversial topics such as competition or cooperation, which is better. The annotation distinguishes between major claim, which is the central position of the author, the claim, which is a statement for or against the major claim, and premise, that give reason for claim or other premises and either supports or attacks them. For this work, I used a pre-processed this dataset in a pre-processed state, which is Connell formatted, which has the structure seen in the figure, with word indexes, token, and label type separated. It's also in paragraph level, which is important for inference tasks, where in opposition we would have in essay level, which each batch would be a much larger quantity of tokens. And the literature suggests that in a paragraph, all the argument structures are contained in a single paragraph. So that's the intuition behind the using of paragraph level over essay level. And also the labels are comprised of both component type and a bioscheme, being the bioscheme an acronym for beginning, inside, and outside, which denote the beginning of an ADU or an argumentative unit. Inside, it's inside the ADU, and outside, it's not an argumentative unit. So firstly, for a dataset creation, set proposed. Firstly, translation was performed using a transformer, a pre-trained open source transformer-based model trained on the Opus dataset, which is a dataset on parallel data for other languages. And they just achieved a blue score of more or less 50% in the Tatuebe English to Latin languages dataset. And this image illustrates more or less the pre-processing required to build the translations, which were basic NLP processing of the corpus. So after the translation, the alignments were computed. The alignments specify which words in the source languages correspond to the words in the target language. For this, I used the SIM-align, which is a method that reports the superior performance over other alignment methods that do not require parallel data. This alignment basically builds a similarity matrix using contextual embeddings from transformer-based models, namely BERT, the one used, and proposes 3 different algorithms using this similarity matrix. The argmax, which is just a baseline purely relying on the similarity matrix. The itermax, which iteratively uses the argmax to improve the alignments, and the match, which is an approach based on a bipartite weighted graph induced by the similarity matrix, which got a much better performance than the others when assessing the amount of ADUs missing with the amount of ADUs with tokens missing in the alignments generated. So after translation and alignment, finally the annotation projection algorithm, where we first get the tuples start, finish, and label for the source language. The start and finish define the interval in the sentence where there is an ADU with the label. We found the respective range, but in the target language, by labeling with label, every translated token with an alignment index between the max and min target indices. This is basically for the sentence at hand. The target ADU interval is limited by the tokens in the max and min indices from the target alignment. We will see better how this works in the next slide, where we have an example of a sentence in English and a sentence in Portuguese, its translation. And notice that the first word in Portuguese has no alignment. So given that the right numbers in the pairs are the indices for the target sentence. So we are missing the 0, which is the article, which should be part of the ADU. For this, also there's a slight tweak to the algorithm implemented, which basically, if there's a token in a target that has no alignment in the source language, the start index of the ADU interval is shifted. So basically, because that article has no alignment, we start the ADU from there, which helps for more verbose languages to have less errors, because this is a prevalent error when using these, at least this alignment algorithm. Then to evaluate the created dataset, which is also formatted as a canal-based and paragraph level, as we've seen before, but for Portuguese, to evaluate it first intrinsically. So for this, an English version was created based on the Portuguese one, and using the reverse techniques like reverse translation, then the back alignment was computed and back projection also were computed. And then we can compare it using, in this case, the F1 score and compare this this newly created English version with the original one. The intuition is that the one converted from the Portuguese should be similar to the original one. And that seems to be the case with 91.44% of an F1 score of 91.44, which is high. Then also there was an extrinsic evaluation, so into a task of NLP, namely sequence labeling. In this case, I used a BILSTM, CNN, CRF, just because it's better for comparing with existing results in the state of the art. But yeah, future work should lean towards the transformer-based models. So for this, it's more or less straightforward. There were some tests made also on direct transfer, which entails doing inference with a model that was trained on another language and just changing the embeddings. If we use multilingual embeddings, we can have more or less good performance theoretically. So the results I got with those experiments. So the third row, it's the literature, which is not, it doesn't have also always the same metric, but this is more or less it. So when we have English, so firstly it's English to English, then Portuguese to Portuguese, then English to Portuguese. English to Portuguese is a direct transfer task where we train in English and then infer in Portuguese. I'm sorry, there's a typo in this table because the final 3 columns should be French to French, Spanish to Spanish, and Chinese to Chinese. So just notice that the results I got in these experiments were not yet in line with the state of the art, given that not even my in-language performance of 62.41 is in line with the 66.69 proposed in the literature, which ultimately suggests that my implementation or some kind of hyperparameter tuning or even the quality of the embeddings is not the same as the ones used to achieve such a score. Finally, to conclude, this work resulted in a new machine translated Portuguese version of the persuasive essays and an algorithm to annotation projection, to do an annotation projection. As I said, I addressed the poor performance on the extrinsic evaluation to hyperparameter tuning and embedding quality, and future work should lean towards employing subword multilingual tokenization and transformer-based architecture for extrinsic evaluation, and extend the application of the algorithm to other datasets or even domains in the NLP field. Thank you.
Thank you, Afonso. Currently, we don't have any questions yet on slide. Oh, we just received one. I'm going to give just a couple of minutes so we can receive a couple more questions. And in the meantime, I would like to invite Professor Augusto to say something about the Afonso's presentation.
Okay. I'm not an expert in these areas, as you know, so I will not discuss the scientific side of this presentation. But there is one thing that we are trying to make a study for the Portuguese language, but using the studies that have been done or comparisons with other languages. And it is to me a little difficult to understand this because several languages have completely different constructions of sentences, of ideas, etc. The alignment problem seems to be one of the problems that come from this. Is this a usual work done for other languages?
Maybe I was not clear. Yeah, I wasn't. But so the proposed work should be a step forward to try to mitigate the gap between the most resourced languages to the less resourced ones. So most of the work is developed in English, and so there are a lot of English English data sets available. So here I propose a Portuguese version of that same data set, the persuasive data set, and try to assess its quality. So both the extrinsic and intrinsic evaluation is just to assess the quality of the data set. And to do so, I try to see if the performance on a model trained on that data set and making and testing on that same data set, but well, with a train test split, as it's common in the machine learning, if that performance is similar with the state of the art, with models trained on, let's say, Spanish and tested in Spanish. Because, of course, there are challenges on the language, but Spanish and French should be good reference points.
Better references, at least.
Yeah.
Better.
Yeah.
Not completely good, but better references. Okay. About the presentation, there is one thing that I should advise you, Afonso. You should be more assertive in the way you speak, in the way you present things. Okay. Yeah. This has to be trained. Okay. You have to make more presentations and talk to your colleagues and make more work, more communication work, so you can get these skills that you need to develop, because your speech is a little, too much posed, okay? And you have to deliver a higher rate communication sentences, okay? The rest of the slides were okay. Well, you showed us state of the art that was a little reduced. It was not a really state of the art, if you understood well, but it is also, I would say, a particular work that perhaps does not have a large set of other solutions to discuss. So I don't have any more questions, but try to make more presentations with your colleagues in your lab, etc. This must be training, okay?
Yeah.
Thank you, Professor. In the meantime, we already received a couple of interesting questions. The first one was asked by André Gonçalves, and his question is, Afonso, in your opinion, what are the most promising potential applications for argument mining in Portuguese?
Well, we have the same challenges in Portuguese as we have in English. The problem is that we don't have the same resources to make the same tests or experiments, and that's kind of the motivation of this work. It's hopefully to enable some more work that was otherwise just developed for English or German or Chinese, also to Portuguese. So the same sequence tagging. The way this work was framed, for example, in the extrinsic evaluation, lets you understand the premises of a have a given argument and the claims, and so what is the author saying in their essay, and how are they defending their arguments? So it's very interesting field, I believe.
Okay,
Hopefully
thank you. So basically, the applications are the same. The contributions of your work is to create a base so that we can use the same algorithms and the same solutions in Portuguese. To finish, we are already on time. I'm just going to ask one last question, and I will ask you, Afonso, to please answer in 1 minute or less. This is a question asked by Hugo Oliveira, who asked, did you find some ambiguities in the annotation projection? Maybe different possible annotations from different projections can be integrated?
There are some, at the current state of the data set, it seems to be of very good quality, but there were some challenges like those. The alignment is not always precise in this approach. Is very reliant on the quality of the alignments, and the alignments are an external algorithm which I don't control. So there's that.
Okay.
So
the challenge, it's the challenges of working with a black box. All right, Afonso, thank you. So let's move on to our second presentation of this session. So from argument or argumentation mining, as you prefer, we're now going to move on to sentiment analysis. And we have here a paper that will be presented by Ricardo Gomes. Ricardo, the microphone is yours.
Hello, I believe you all can see my presentation by now.
Yes.
Yes. Okay. So let me start it. My project is regarding topic modeling and sentiment analysis in COVID-19 tweets. First, just a small introduction on what was the trigger for this project. The trigger was the World Pandemic Declaration by the World Health Organization last year, which brought us to this new reality that we are all in, and that made these microblogs and social media platforms to become some sort of confessionary for people to post their ambitions, their feelings, their hopes, their fears regarding this new situation we are all in. So it raises the problem about what is the public perception regarding COVID-19. And to address this problem, this project has two main objectives. The first one is to investigate what are the main topics under these tweets regarding COVID, and what's the latent feeling, the latent positivity or negativity regarding them. Has a more broad and superficial purpose. This kind of works may be used by governments and the public health agencies to better grasp how their measures and how their communication is being perceived by the general population, and how well population is addressing this kind of communications. So just to give a small grasp on the related work, there have been already some scientific works regarding COVID-19 tweets, most of them regarding topic modulations. And it was found that most of them have some latent feelings regarding deaths and increasing racism, some psychological condition fears also. But there are also another from Samuel with data collected in May last year that showed some positive sentiments on trust and anticipation towards the reopening of the American economy last year. So it's intended to see if this positive feelings is still present with the data that was analyzed on these tweets. So the data was collected from a publicly available data set from Kaggle, which collected almost 1 million tweets from all over the world. But for this project, there will be only analyzed 32,000 tweets from United States users, and these two tasks were performed on them: the sentiment polarity and the underlying topics. So starting with sentiment analysis, the scorer used was Vader. Vader is a Unigram scorer that is particularly suited for this microblogging and social media environment, because it supports the particularities of the language that are very present on this kind of environment. The initialism, the acronyms, the slang, the sentiment testifiers by punctuation marks, the all caps, the lowercase words, and this is the most suited and most fitted scorer for this kind of task. Vader has a pretty straightforward functioning, since it gets the positive and negative value of each word in each document. The documents here are the tweet texts, and the compound score of each document is given by the summing of the valence scores of each word, and then normalized between -1, which is the most negative feeling, and 1, which is the most positive feeling, becoming the neutral value of the sentiment between -0.05 and 0.05. Before engaging in this Vader analysis, some pre-processing has to be done. Extra white space were removed, URLs, hashtags, HTMLs, and mentions were also removed, since Vader is not able to get any kind of interpretation of these signs, of these characters. Stop words were also removed, but not all the stop words that are present in most lexicons, because Vader is able to classify some stop words. So those stop words that Vader is able to classify with positive or negative feelings scores were kept in the analysis. Furthermore, no stemming and lemmatization was performed, because in Vader, Vader can classify different constructions of the same word. So to say, the word craziest has a different score, has the word crazy in Vader. So the words were kept in their original form. So as a first presentation of results, we see some slight positivity polarity on this course, and a high stake of neutral scores also on these tweets. This may come from two possible causes. The first one is that it wasn't made any kind of misspelling correction on words, so there would be lots of misspelled words in these tweets, and they were not corrected. So Vader is not able to classify them because it doesn't acknowledge them. And the other thing is that Vader is suited for this kind of environment, but has a small extent. It only features 7,000 words, so it's very easy in such a large set of tweets to find many words that Vader is not able to classify. After this, it was built some word maps with the words that were related with the most positive and the most negative polarities. It's curious to see that some words are shared between them, like pandemic, like people, like Trump, and there are other words that were kept in each division, such as the masks on the positive side and crisis and death in the negative side. After this, the topic modeling was performed. Topic modeling is an unsupervised machine learning technique that builds topics that underlie the documents, and each topic per document is modeled has the reflect distribution. So the name. Once the number is defined, once the number of topics is defined by the user, LEA just arranges the topics in each document and the keywords in each topic. We'll understand it a little better on the next slides. Before going to the analysis, some additional preprocessing activities have to be done. Stop words were removed, and tokenization and lemmatization have to be done in order to keep the words with the context that they were posted on those tweets, so the analysis could be more accurate, so to say. After this, the LDA topic model algorithm requires a document word matrix as its main input. This document term matrix is a matrix that describes the frequency of terms that occur in a collection of documents, in this case, tweets. To build this matrix, of course, some options have to be made, like to decide what is the minimum frequency of words, so it features in the matrix, the minimum number of characters in each word that would make it available to be presented in the matrix, and how many words does this matrix might have, and this matrix is to be fed to the LDA model. After this matrix is built, then it's fed to the LDA model, but the LDA model requires several inputs to be set. So at least 16. So it would be not feasible to generate a good model in a trial and error way to generate the best model. So some hyperparameter optimization was done with a grid search, but not all the parameters were optimized. Only the two regarding the number of topics and the learning decay of the function were optimized. And then the model that retrieved that would maximize the likelihood function that would best represent the distribution of the data was selected. Of course, some more optimization tricks could have been done on this subject, but the results retrieved were intended to be satisfying for the purpose. So the topics that were defined were these three, and each word on each topic has an assigned weight inside each topic. So test has a much higher weight than family has in topic 0. The same way for the other words in each topic. And the topic definition, as this is a unsupervised machine learning, is totally on the researcher to assign. They are quite separable, I think, and they were defined to be community affairs, health measures, and COVID updates and reports. So after this, each topic was again tested in Vader to assign the positive, neutral, and negative polarity on each one. The health measures here get the prize with the positive sentiment, but again, it is to be seen that there's a lot of neutral tweets analyzed inside each topic. This comes again from the inability of Vader to classify many words that appear on these tweets. So as a discussion, Vader presents a non-negative sentiment of 70.8 on the collected tweets between July 24 and August 21st on the last year, which is kind of aligned with the previous studies that show the same order of magnitude of non-negative sentiment. Attention must be paid that this study did not use the same data that was used on this study, but pre-processing activities did not change the magnitude of values for Vader. Several sets were done, and it ranges always from 65% to 70.8%. This again proves that the words that we are extracting or including in the analysis many of them are not read by Vader. The data was collected after the reopening American issue that was issued by the White House. So maybe this be unbalancing the data a little bit too positive. And then there's another trick by Vader, because Vader has a unigram scorer. Positive feelings may be misinterpreted, such as positive test, positive COVID test is labeled as a positive sentiment, which without context would be a positive sentiment, but in context of COVID, a positive test is not a good thing. So here is some tricky analysis to be made. Again, there was no differentiation between normal users and official institutional users. These official institutional users tend to be federal agencies or some state agencies that tend to post inspiring and hopeful messages on tweet, which also may be tending the overall analysis a bit too positive. Again, misspellings and grammatical mistakes were not corrected, and that may cause Vader to analyze even less words that it already is capable of. And many neutral scores also come from this short Vader lexicon, about 7,000 words. Regarding LEA, topics definition is closely related with one of the found studies. The topics are easily distinguishable. The exhaustive search for the best model ensures some accurate results, but maybe some more improvements on the parameters could have been done to get a better model. However, the LDA model also is very sensitive to the input data, to the words that are in the document metrics, and the maximum of unique words and the length of the words. And another maybe drawback is that topic determination is purely on the researcher decision, since it's an unsupervised task. So as conclusions, the results show overall positive results, which is congruent with other studies. And the preprocessing on Vader did not change the results quite much. On the other hand, LDA is very sensitive to the input data. So maybe further and deeper analysis on LDA could have been done to get an even better model. As the future works, COVID-19 tweets have lots of works that are possible to be done, such as in social science to announce the tweets in some singular time frames, like when the elections occurred or when the vaccine was approved. It is possible to compare different positions between countries. On the technical level, maybe using other techniques for words representation on the metrics, and even more complex architectures, something like neural networks could have been used. And if feasible, to include other lexicons that are suited for this microblogging and social media environment. Here are some of the references that supported this study, and this is it. I am here to answer your questions, and thank you all.
Thank you, Ricardo. As usual, I would like to begin by inviting Professor Augusto Souza or any other professor we have here on stream to say a word or two about Ricardo's work.
Okay. It was a nice presentation, I would say, with in the introduction explaining the problem, the objective, the proposed, with pictures, not too much text in those slides. I would reinforce, and after that, section for the related work. After that, speaking about Vader and LDA, to methods, methodologies, techniques, I don't know, and finally an evaluation with a discussion and conclusions. It's a classical presentation that accomplishes with more or less all the parts that are expected in a presentation like this. About the related work and the methods that are presented. Perhaps I would say an introductory 1 minute or one slide about the two methods that are presented and how their relation in the scope of the problem and to each other. How do they situate in the problem as an whole and with other solutions, etc. I missed a little miss on this, because when we started speaking about sentiment analysis, you immediately presented Vader, and with no much explanation about this. It's so the first question that comes is why Vader? Why not another one? Are there more solutions or not? Okay, some words, one slide, perhaps preparing the reader, in this case the listener, to what we are going to say next. After that, the results were more or less well evaluated. I have here one small question that came into my mind. You are classifying several as positive, several sentences as positive, others are considerably with a certain are classified as negative, and in the middle you have the neutral. And neutral, in my interpretation, may be two things. One, the sentence itself is neutral, or the software is not able to detect if it is really positive or really negative. And so it classifies as a neutral. Do you have any idea about this situation?
Yeah, I was trying to explain that during the presentation. In my opinion, and without further insight on that, that is due to two main reasons. The first one is that Vader is a kind of small lexicon. It has 7,000 words classified. So in 32,000 tweets, it's very easy to find words that are misspelled or that Vader is not able itself to classify. So again, without further detailed analysis, it's my belief that that is the main that's the main reason. It's not that they are very positive or very negative. My belief again is that Vader was not able to correctly classify them. Maybe future work could also be done on that regarding to use some of the work of the colleagues in the NLP to get the correct words to be analyzed by Vader.
Yeah, and it must be difficult when the tweets are written, most of them in mobile phones, etc.
Yeah, and the language
many mistakes
is evolutive. And the internet language is very dynamic, so to say. Terms are appearing like mushrooms, so to say, and it's difficult for the lexicon to be up to date with these new terms that are coined every day.
Okay, if you permit me one small advice, be careful with the fonts in your slides. In this case, that the projection is made in a screen is perfect. If you have a big room and you are projecting the slide, in some slides, the font was too much small, okay? But obviously here it results very well, but it's the quality is completely different. Okay. Thank you, Ricardo.
Thank you.
Nice presentation.
Thank you, Professor. I have here a question by Afonso, who was the last presenter, who has a doubt about the word clouds that you presented. His question is, what is the meaning of a word appearing in the word cloud? How do they contribute to the sentiment analysis?
Because, as I said, Vader, I'm just putting it behind, so it's easier to understand. So Vader classifies each word with a positive or a negative score given the lexicon. So all the tweets, all the words in each tweet were analyzed with that lexicon, and the tweets have this score, this neutral that was explained by me to Professor Augusto. And then the world map collects the most frequent positive words in the tweets and the most frequent negative words on tweets. I could have done most found words in neutral tweets, but for the sake of the project, I understood it wouldn't add much information. So I hope Afonso is clarified now.
Okay, so basically those two clouds represent the words that in a way generate or create the strongest feelings on the people, the strongest positive and negative feelings.
No, it are the words with positive feelings that are most frequent.
Most frequent, yeah, okay, not the strongest, the most frequent, okay.
I don't know if Trump is a highly negative or highly positive classified words, so do people or pandemic. This is just the words that are most frequent in each one of the tweets.
Very commonly used on tweets. Okay, Ricardo, thank you for your presentation.
Thank you.
We'll now move on to our third paper, which is about bias detection in a very interesting field of study, the study of law. And this paper will be presented by Hugo Oliveira. Hugo, the floor is yours.
Good afternoon, all. Thank you, Gonçalo, for the presentation. So my work concerns bias detection in court opinion. This is a holistic study. It approaches this kind of bias interaction in different dimensions. So I just give a quick overview on this outline of this presentation. This is what has been done. This is just a bit text raw, but just to summarize what is here, of course, the bias opinions are hard to detect. we know that some bias statements are cultural natural and others are unaware of the discomfort may cause. And we know that these biases are present in many fields of society. Of course, they have different order of importance, but relevant and more transversal to among the societies concerns the fact of implicit racial bias. This most of the times are done in a precognitive way, and we can find many examples of this. So, of course, this genre of implicit bias concerning racial is that's a great influential or social political behavior, since there are at least some studies state that they are responsible for the continuous racial disparity among the society. So, perhaps with this in mind, we can state or not, or find some evidence that this kind of racial bias might be entrenched in the language of the law. This is relevant since the law must be equal or at least fairness for all people involved. And of course, how we want to assess this. The problem is that assessing the opinions in a reasonable time is hard, because many opinions are produced by ear, and so this is where computational linguistic methods appear. So, just a brief contextualization, very briefly, concerning racial discrimination among the United States society. 41% say that the discrimination is the main reason why Black gender people cannot go ahead, and even a larger percentage say that the reason they cannot go ahead is by their own responsibility. So very polarized opinions on this. Also, immigration, a large percentage say that immigration is good, because they bring talents and hard workers, and while others, a relevant percentage, say that immigrants come here to steal their jobs. Of course, this is on the United States society. So, just a brief contextualization in our work is very well framed with these two references. There are more, but I just contextualize this one. The stereotypes in decisions from Elliot Nash, exploring word embeddings, in particular Glove, to identify several genres of bias. So many conclusions. Interests are, for example, lower decision courts are more likely to be reversed if the lower court is a woman. It's interest. Also from Douglas Rice, we have here a lot of bring up many inspiration to our work from this work also. Racial bias in legal language from Douglas Rice, explores linguistic models, trying to find the implicit racial biases in the United States Supreme Court, or also our data set, and analyzes several time frames in detail. So an observation, we also made this observation, African American names are more frequently associated on a negative presence, contrary to white gender people. And perhaps some implicit bias are entrenched in the language of the law and reason in future decision. This is very important because normally law decisions are based in past decisions, because the contexts are the same, and if a bias exists, it continues towards the future. So our hypothesis is to say that are racial bias present in court opinions? It's possible to identify those bias justice. It's perhaps is spread by justice own opinions, how this may evolve during several years concerning, for example, civil rights era, and how partisan nomination influence those opinions. So our data set, Supreme Court of the United States, encompasses almost 50 years of opinions. It contains opinions from 26 well-identified justices, and we see what are the differences, and majorly author name, category, so on, and the text by itself. So our proposed approach is to provide high-level statistics, content lengths, and so on, modern opinions by topic and cluster to assess the content of this corpus, with perhaps finding some correlations with ideological or social tendencies, with main object to classify opinions by author, identify some kind of bias evaluation using pre-trained impedance, and classify opinions by partisan. So without further notice, we do exploratory analysis. Most of the opinions have fall in three categories. Majority, they are mostly done by several staff members. They lay out the groundwork, and normally are the longest. Concurring opinions, they basically say, okay, I agree with the majority of the opinions, and dissenting is somewhere in the middle because they agree with the majority, but have some points to be made to those particular majority opinions. So concerning just a brief exploratory analysis, there is much more in my work on this, but we see that during the years, we see that the opinions tend to be, number tend to be shorter, but in reverse, the opinions text tend to be larger. So this states that the justices are, let's say, in recent years, they have more complex cases to handle, and this requires more time for them to provide an opinion. That's why less opinions, but they are much longer. So also some outliers concerning some individuals' justice. For example, one of them is Justice Scalia. Present a lot of dissenting opinions. His nickname among the United States society is the Great Dissent. So if you find some evidence in YouTube, you see that some of the opinions of them initially were controversial, but during some years, all people agree with them. So just brief in terms of exploratory of this data set, we see that the topics are, let's say, on government and union, employer, benefit, and so on. When we move to bigram analysis, you see that state law, district court, and First Amendment, and so on, are words that are related. And this suggests some of findings that this also words, district court, and so on, must be used as stop words because they don't convey too much information to our problem. So then we move to our exploratory analysis. Here we move. We made three analyses different concerning topic modelization. Use latent semantic analysis, and we try to find, let's say, some kind of feature topics that summarizes at least the corpus opinions. And we see that, for example, death, reservation are concerning a feature concerning land rights, candidate election, also considering political issues, school, religion is something very relevant in the United States concerning religion in schools, artifacts, and so on. And of course, stuffs that are related with that. Many other topics are here. We evaluate also different approach, latent rich allocation, different set of features were obtained. We evaluate several components, several number of components. Some of them, of course, when we increase the number of components, they become a lot of messy and they don't convey too much information. And with this, I find that some limitations, and I move on to non-negative matrix factorization. Using the criteria coherence, I evaluate several components. This is just a summary of the 48 components, but the components I plotted this in a different way because they are well aligned. The features are, let's say, well encapsulated inside. For example, Indian tribe reservation, as we know, United States of America has a lot of problems with land rights concerning the Indians and so on. For example, schools and religions, education, public, of course, there is some kind of religious related to schools. Police stop, Miranda, this is a case, officer, suspect, probable suspicion, and many others topics. So with this in mind, we made auto similarity, and we find here a relevant problem because we assess trying to identify the authorship, and we see that the topics and the language used by the several authors are very similar. That will be expectful in context of the law, and this will pose many challenges to this, and we see perhaps a different problem will be suitable to fit to this. So we will supervise learning to see clusters how they evolve using the just rank index, also using the entropy and silhouette score to try to find the best number of clusters. Here 24 clusters were plotted around several topics, and also use hierarchical and also spectral clustering to have fair comparisons. But one main concern is there is a central cluster hard to separate that encapsulates several business-related issues, and other clusters that are to layers are well defined. So clusters here are not perhaps suitable to be used, but also enables us to discover some kind of patterns. So we move on to authorship identification, and with this in mind, we explore latent additional allocations and non-negative matrix factorization with the several models, and also using clusterings, also using pre-trained webs, deep learning, and so on. And we find out that Roberta was in pre-trained word embeddeds achieved a macro of 0.40, almost 46. So concerning the models by itself, using the simplest models, random forest was able to top around 38%, and it's not a magnificent score. We have here 20 classes, 20 authorships. Some of them are in balance, but the latent structure of the random forest suggests that these topics, the problems fall well behind the subject type of area, or they don't convey information about the author, but the text by itself. So this perhaps were suitable for a text classification than authorship identification. But Roberta almost enabled to increase the results without major work. That is important, but of course you don't have explainability on this. So then we move to word embeddings by detection. Here we just made two plots concerning the black and the racial to see how the words are around. Of course, black, Negro, white is the contrary, opposite Latino. Racial, we see that some words appear nearby, near minorities, individuals. Concerning partisan, it's interesting to appear here. But this is just an initial glimpse of this. And then we move on to make some queries concerning the use of global negative pre-trained word embeddings, and also use others, but these were the most relevant concerning common word of United States Association of African American, LeBron James on the Lakers, and the negative white, and the opposite to Jim with opposite black. And we found that the LeBron, for example, is many times related to offense and obfuscation and transgression, while contrary to a white common European name or a European American name, is related to names, Eugene, Adrian, and so on. So this does not convey that the corpus is the justice have some bias, but it's immediate state that black gender people, black gender people are frequently associated with unpleasant concepts, proving or at least corroborating the work of Douglas Rice in this. Of course, the use of different embeddings produce different results, but these were, let's say, the most relevant. Then we move on to concerning partisan detection by means of classification, concerning the fact that each justice is nominated at least by the president in office, and the president has two parties, or it's a Republican or Democrat. And we collect this information and we reuse our models to train to a new objective. So concerning the justice and the partisan, Bert and Case almost achieved a 0.7 F1 score. So this means that Republicans, concerning the other Republicans, this means that partisan opinions, or at least there is a leakage in terms of the partisan that the justice are nominated to the opinions. But this might be also related to the fact that opinions by the United States Supreme Court are normally made in a conservatory way. And we see in terms of history that Republicans are more, let's say, aligned with this view. So perhaps here is something interesting to know and perhaps pursue new works on this. But in terms of conclusions, this is topical clusters producing clusters seem to be coherent. Supervised tasking of authorship remains challenged due to the nature of this corpus. Tracking political changes will be interest to be made more deeply, and the ordinary evidence demonstrated the existence of some racial context language doesn't convey the existence of bias of the opinions by justice, but further studies must be conducted. So with this work, we employ this exploratory analysis, and you also open new problems to be explored. So this is what I have to say now. Please, in terms of comments.
Thank you, Hugo. Before I pass the word to Professor Augusto, I would just like to remind all our viewers that you can ask questions to all our participants using Slido. There, in that website, you can add questions, and another important feature is that you can upvote questions asked by other people, so that myself and the future moderators can select the questions that you are most interesting to hear about. So without further ado, Professor Augusto, what is your opinion on Hugo's work? Your microphone is muted, Professor.
It is a good opinion. Okay, Hugo, I was afraid that you overpassed the time, but you finished exactly.
Yeah, it was on time. It was on time.
Exactly.
Exactly on time. I was also looking.
But this does not avoid that it was too strong communication, very deep, very full communication, too much things, speaking with a high speed, etc. So you know, you have to be a little more calm with the presentations. So you have to try to be more synthetic. Okay, instead of explaining every details, you have to synthesize using black boxes when it is needed. You don't need to explain everything. Sometimes it is necessary to put a black box and okay, this is a black box and the result is this, okay? The rest, okay, outline, a context, a literature, so you revised state of the art into 3 papers, if I believe well, 3 papers, but 3 papers discuss it. It was not only the method is this one, no, you discussed the paper with the topics, with the methods used, etc. And this is a good point of your presentation. I enjoyed that. I don't know if the literature is wider than this, if there are more things that could be here explained or not, but I enjoyed this discussion, okay? About the hypothesis, I don't remember the number of slides, but the hypothesis, no, sorry, Hugo, that's not an hypothesis. That's a set of research questions. An hypothesis is a sentence, not a question, okay? An hypothesis is something that you say, we can do this using that methodology with that result, something like that, okay? And what you are doing here is making questions about. They may be scientific questions or not, I don't know. This is what you want to prove. They are not scientific, let's say, some of them are, some of them are more informatics on the informatics side. Some of them are more on the social sides, things that we want to prove or not, but they are research questions, okay, not hypotheses. After that, you presented the proposed approach, and during as an exploratory analysis, you made several slides about this. Sorry, Hugo, your graphics are not understandable. They are so small that we cannot understand them. This one is more or less. Others are very small. For example, this. It's not easy to read this.
Just a matter, this, all the work, all the notebooks and so on. Of course, this is just encompasses a small glimpse of the work, focus more on the social part, not in the technologies, because I didn't talk about lemmatization, stemming, and so on.
Yeah.
But it's all on my GitHub. You can play with it and even reuse it for other tasks. But yes, they are a little bit small, and I focus this. Yeah.
Yeah. After that, you mentioned 3 techniques: LSA, LDA, and MF, and you made some work with them. Another graphic, slide number 15, this one, that I really did not understand because you have names in vertical, names in horizontal. Can you explain very fast what?
This is the correlation author by author in terms of the opinions they produce.
Okay.
And of course, if it's all green, it states that they are very similar, and this poses problems to authorship identification concerning these authors.
Okay.
Because if the language was too dissimilar in terms of, we see here different colors. But they are very close to each other, of course. For example, Justice Kagan concerning himself, it's green, right? But we see a lot of many similarities among the different authors, even that the authors are different. But sometimes the topics they address and the language they use, and that it's related to the topics they address, are very similar.
Okay, in this case, it is not easy to make perhaps other representations, but you know, colors, sometimes it's something difficult also to be understood by some persons, daltonic persons. Here you are using same color with the different saturations and different levels. Sometimes I believe it is more understandable. But in graphics, many times in science, we use graphics with signs, not only a line red and a line yellow, for example, but we use signs with the points in the points, so to make the several lines different from each other because they correspond to different graphics. Just because of this. And after that, you mentioned authorship identification. This is bias detection, word embedding, and finally the conclusions. Let me make a final question about this. Did you obtain the conclusions that you want? Not the conclusion, but the type of conclusions that you were expecting. In other terms, are you answering to the research questions?
What I've stated to do, I managed to do, but during the encompass of this work, I find that many open areas also. For example, I focus mostly on implicit racial bias, but there are many implicit bias for example, sexual and so on. But there is some clear evidence. The main problem of this data set that is not labeled. You don't have a specific opinion say that, okay, this has a bias in this particular set of phrases and so on. This was challenging in terms of it demanded a lot of interpretation of, that's why I presented this way. But of course, there are still, at least I identify many open questions that arise during the exploratory analysis. But concerning the racial, there is a presence. It doesn't convey that the justices are biased, but there is a strong presence of racial context among the opinions.
We can understand that. We can understand that, especially nowadays. But about the research questions that you mentioned, when we make a list of research questions, it is somehow elegant at the end, try to answer those questions. The answer is this one, the answer is that one. We cannot answer. Sometimes we have to say this. It is not possible to give the answer to this, etc. The same for the hypothesis. The hypothesis is proved, the hypothesis proved to be the contrary, or the hypothesis is not proved. Okay.
Yeah, that's why I don't make a claim, a bold claim, because if you say that a particular justice is biased, there is a problem. So, of course, no one wants to say that a particular authority has some kind of bias. But the true to our society is that there exists racial bias, even in Portugal. Even the person don't want to admit them, but they exist. But proving it is a really difficult.
It's more difficult, yeah.
Sensitive
we have
topic.
a social problem. We have a social problem. Yeah, thank you very much, Ugo. The slides are okay. You speak a little speedy, okay, but I have already told us. Okay, thank you very much.
Thank you, Professor. We have, okay, this presentation went a little bit overboard, but still I want to give just opportunity for one of the viewers at home to ask a question. I have here a question that is a relatively closed question and that will not require too many seconds to answer. Pedro Moreira stated that the Supreme Court opinions can be categorized in three main groups. He has a doubt, Hugo. Could you please explain again what the concurring group means?
Okay, I'll move to the slide that is here. For example,
majority, the dissenting, and
majority, and so on. So this is the graph. Majority is made by a majority of staff. For example, it's not only the justice, perhaps is auxiliaries and so on. And normally, these majority opinions don't have a particular author. For example, justice. But concurring are basically, for example, concurring are the shortest because the author that produces basically say, okay, I agree with the majority. That's it. And then dissenting. Dissenting is something on the path that some persons agree with the majority, but they have some opinions contrary to be made. So this is, let's say, someone in the middle. Okay, I agree with these opinions and so on, but I have some opposing points to be made. And for example, if you see Justice Scalia, we will find easily on YouTube and so on. I was aware of the name, but not the context. And it presents a lot of dissenting opinions. This is the three major categories of the opinions that are labeled, at least.
Okay, thank you, Hugo. Okay. So now we'll move on to our last presentation of this session. The last paper of today's session is about complaint classification and will be presented by Tomás Osório. Tomás, the microphone is yours.
Okay. Hi, I hope you are seeing my presentation.
Yes.
Okay, thank you. So my name is Tomás Osório, and today I'm going to present a paper about complaint classification for economic and food safety. So first of all, I'm going to talk a little bit about the context. So for whom this work is about, the case study, so the problem, the related work, the dataset used, the methodology, the experiments, some final remarks, and what are we going to do in the future, right? Some Q&A. So what is the Portuguese Economic and Food Safety Authority? So this work is for them, so to Dsie. So it's an entity responsible for monitoring and enforcing the regulatory legislation for food safety and economics. So annually they receive thousands of complaints by their citizens, and this could be via email or their website. This is our main focus, but could be also via manual, so by form. Currently, these complaints are processed by an officer, and as you can guess, this process is very labor intensive. So this is what we're trying to do to optimize its time. So what are the complaints? The complaints are user-generated text. So it can contain misspellings or different structures. and they are classified according to its jurisdiction. So if it's from ASI jurisdiction or not, its infractions. So if it's a crime, an administration infringement, or other problem, other issue, and is economic activity. In this work, you are going to focus on economic activity. So this problem is a text classification problem, and the normal approaches taken are using SVMs, applying TF-IDF or bag of words. It could also be used neural network models, using word-based models, character-based models, or using transfer learning. So using something like a language model and then fine-tune it for text classification. We are going to focus on the word-based and transfer learning regarding the NN models, and the previous work on this regard, it was done by Filgueiras and used the SVM with TF-IDF, which achieved 75.5 accuracy, and we also exploring some this approach as well. So the dataset. The dataset contains complaints from 2008 till 2018, which, as I said before, are received via email or their website. The average sample length is 255 words. The test set used is the same as the previous work, and it uses 16.3% of the dataset. And it uses the stratification, so the distribution of the test set and the training set is similar. So one of the main issues with this data set, as you can see in the table, is that it's highly unbalanced. So for example, the first three classes represent about 72% of the complaints. So, and for example, the bottom three represent less than 1%. So this is a big issue for us. Also, the number of complaints is not that big. It's about around 146,000 complaints. So we have to have this in mind. So that's one of the reasons that we did not choose using character-based approach. So the methodology. So what did we did with these complaints? So since they are received via email or their form via their website, we remove the HTML, URLs, emails, or numbers. Then we tokenize the sentences. Then if we train the embeddings from scratch, we also remove stop words, punctuation, and accents. The tokens are stemmed, and the tokens are only considered for its vocabulary if its frequency is higher than 100. The reason for this is to diminish the vocabulary size and to try to improve its embedding training size. It's not that large dataset, it's a small dataset. So as for models, we are going to explore fast text, CNN approach, LSTM approach that is similar to CNN. So it's for comparison, BERT, and SVM with TF-IDF and with different n-grams. And we use the cost function, a balanced cross entropy. So fast text consists on a simple model that it's embedding layer with 100 dimensions. Then it's applied an average pooling layer that is going to constrict the size of the document, so we can pass it then for a fully connected layer. So it's like a baseline for comparison to the other models. CNN architecture consists on embedding layer with 300 dimension. Then it's used n parallel convolutions with different kernel size. This kernel size it's normally used between 2 and 5, and the idea is to mimic the n-grams idea that sometimes is used in SVMs, for example. And then it's applied to each of these parallel convolutions and one pooling layer. So to normalize the layers, and then it's concatenated and passed through a fully connected layer. And our another approach that we also made is using an LSTM, so a bidirectional LSTM with the same size as for the embedding layer. Then it's using a hidden size of 70 for having the same number of parameters or similar number of parameters comparing to the convolution architecture that I explained before. Then it's applied also a 1 max pooling layer to the length, and then it's passed to a fully connected layer. And we also explored BERT. So currently it's one of the state-of-the-arts for text classification in multiple data sets. So what we used is used BERT for multilingual case text, which includes Portuguese. And we replaced the last layer so by a fully connected layer that receives the last hidden state of the token CLS, similar to the paper How to Fine-Tune BERT for Text Classification. And then it's applied a learning schedule, one cycle policy anneals to avoid catastrophic forgetting. So as for SVMs, as I said before, we used different n-grams and we used a different cost function, a squared inch. For the multi-class strategy was 1 versus rest. And we also used the balancement strategy, inverse class frequency, and the implementation was from Xu et al. So the experiments. As you can see at the bottom, we can see the previous result from Phil Gers. And he got a F1, a macro F1 score of 57%. And regarding this, the only model that we achieve a similar result was using BERT. However, the time that it took and the number of parameters is completely different. And regarding the accuracy, Phil Gers achieved a better accuracy than us, despite being pretty similar. We also can see that, for example, fast text that has a limited number of parameters. So we are only considering the parameters from the fully connected layer, not from the embedding. So it was just 221. And despite that, they achieved a better result than the other models, for example, CNN or LSTM approaches. So that's pretty amazing, I think so. So we also try to use train some models with using pre-trained embedding for Portuguese using word-to-vector. Sometimes we achieved a better result, other times we did not. This might be due to spell the missing spelling that occurs frequently in the data set. So, however, if we look to our results regarding the SVMs, we achieved worsened results than Phil Gers et al. So we export this. We also export this. So one of the reasons that this might occur is because we decided to restringe our vocabulary to 100. So a token was only considered if its frequency on the training set was higher than 100. However, in this kind of issue of this problem, this might make the classification worse, since some key words can be removed. So if we include all the vocabulary in the training set, we can achieve a much better F1 score and accuracy, and actually we can get better results than Phil Gers et al. When we use n-gram higher than 1. So if we use 2 or 3, in both ways we can get better results. So regarding cross entropy balancement, so if we applied balancement or not, what's the difference regarding our results? As we can see, we can obtain a better F1 score in this kind of model when we apply the balancement. However, the accuracy size is not balanced in this measure. Sometimes it could not be better. So, however, in the overall, we consider that using cross entropy, it's with balancement is a good approach. So for the conclusions, the statements that we can make is that despite NLPs moving towards the use of neural networks techniques, in small data sets and highly unbalanced SVMs can still be competitive and achieve better results and are easier to train, in my opinion, and faster also to train. As for vocabulary restrictions in these small data sets, we might remove context, which can make more difficult or harder to make the correct predictions. So it might be avoided, an option to be avoided as well. On unbalanced data sets, using balancement techniques, it also improves an overall the results. So we think that's a good strategy. As for future work, one way to improve our neural networks models is using a cost function similar to focal loss. We actually tried and we obtained better results, but we did not introduce it in this paper. And applying spell checking to enhance the results on pre-trained embeddings. Since if it doesn't, the vocabulary is not already the word is not in the vocabulary, it will be considered an unknown token. So it all go to the same bag, let's select that. And with this, I'm finish my presentation and waiting for some questions.
Thank you, Tomás. So as usual, we already have here a couple of interesting questions, but first of all, I would like to pass the word to Professor Augusto for him to share his comments and his opinions on this work.
Thank you, Tomás. Good presentation, a good work in my opinion. My first question is, in the past it was manual processing of all the messages, etc. And my question is, are they using this automatic processing or not?
So currently we are going to the next stage in Dsie, CSSCOP, and these models are going to production, and we are working on a platform so they can track all the complaints and see why the complaints are classified like that, using looking at the features, at the models, so that's it. I think so.
We may believe that this is a finished project or almost finished project.
It's not a finished project because the next phase, almost. So I would say that the next phase we're going to have more data. So we are going to receive from 2019 and 2020 complaints, and due to COVID reasons, the majority of complaints are made using the online complaint book. So we are going to improve our models, but this is in the final stage.
Let me a social question, okay? The type of questions that they have are or not dependent on the moment, on the time they appear. For example, nowadays they are more questioned about things like restaurants that are serving and could not be serving, etc., because of COVID. In other situations, we had problems with meat of a certain animal. In other, things vary with time also, with the news, with the problems that we are going in history. Do you notice any evolution with this? It's quite independent. What do you think?
Yeah, of course. So as language is mutable, the complaints also are. So they are always changing, and from year to year, the focus changes a little bit.
However, you don't need to make a special tune of the software for these different behaviors?
Yeah, we do not. So regarding the economic activity, so generally what I can say about the model, we have like a paper that is submitted. So the way that the model works is basically it tries to search like keywords. So for example, if you have like a company that regards like restoration or industry, it's going to that bucket, let's say like that. So it's more like a smart keyword search at the time.
Okay. We are having here some solutions with an accuracy about 70%, a little more, a little less than 70%. Do you think this is a good accuracy for this type of job? Shouldn't it be more on the numbers on the 90% or something?
I think that it's like iterative process. So regarding the agents, it's helpful. So it will take some reduce their time to separate to classify the complaints. So I think it's always a good thing for them. And since it's an iterative process, we hope that in the future we can improve on that.
Okay, in the experiments when you were describing in a table the several methods and the corresponding results, you mentioned the number of parameters of each one, and I understood that some methods have a huge number of parameters. For example, BERT, the first one, 100 million of parameters. What are parameters in this case?
So are the number of parameters that are trained. Are the number of weights and bias that are trained for this model. So if we have like a fully connected layer with 10 nodes, will be 10 plus 1 to the bias. So
but they are not to be controlled, are they?
No,
human controlled, by, let's say.
No. They are trained using.
Wouldn't be possible. Okay, you know, the term parameter is something that has this connotation. Okay. Finally, in the conclusions, you also mentioned for the future work the possibility to make some spell checking. Do you think that we can improve if we make spell checking, but replacing words by?
Okay, so the idea is sometimes people misspell a little bit the words, and two tokens can go in the vocabulary to different buckets. So if, for example, someone spells, I don't know, like can or with I don't know some word and they spell it badly, it can go to different buckets. But if we try to use, for example, unspell dictionary to map it, and we can calculate the edit distance between both tokens, so the suggestion and the token. If it has like a small distance, we can consider that the person just misspell it. We have to consider that these complaints are done by the public in general, and the public in general is very sparse and different, and the level of literacy is very different, and you can notice that when you look at the complaints.
Yeah, the only thing is when you do check spelling or spell checking, you are replacing one misspelled word by a correct word. Okay. I think that this is what you are trying to do, but are you sure? How certain are you that that is the correct word that the user wanted to use?
Yeah, so you can, for example, when you use, as I said before, the unspell, it does like a suggestion of different words. And then if you compare that word or the token to the other token, and you calculate the edit distance, so the distance between two words, so the number of
Tomás?
yeah.
Did sorry, I didn't listen the last part.
Okay, so when you are using spell checking, if you use unspell, for example, it gives you different suggestion words, and you can measure the distance between the word that the person wrote it and then the suggestions, and you can calculate the distance. So basically it's the number of deleted characters, inserted characters, or substitution characters. And with that value, you can have like a threshold. So for example, if we say that it's like 1 or 2, the distance is like 1 or 2 is because like you have just to add one character or remove one or substitute one. So you know that it's pretty close. If
so you
it's
can
bigger
decide
than
to
that,
maintain or not the new word.
yes, exactly.
Okay. Okay, about the presentation, I enjoyed your presentation. Some slides have too much text, in my opinion, but it was very nice and well structured also with the most important parts of the presentation. Congratulations. Thank you.
Thank you.
Thank you, Professor. To finish our session, I just have here one question that I would like to ask Tomás Osório, which was posed by Tiago Costa Mendes. And he asks, was the overfitting risk mitigating in the support vector machines? Did you use any cross-validation?
No, we did not apply any cross-validation. So we used the same. No, we did not use any cross-validation to perform this. We used the same approach as was done in the previous work for comparability purpose.
Okay, thank you, Tomás. With okay, we already went overboard with our time for this session. So this brings an end to our first session on natural language processing. Stay tuned tomorrow, where we'll have a second session at 11 a.m. where we will have 3 more papers to share with you. Now we will move on. I'm going to pass the word to Tiago Mendes, and we'll move on to our next track.
Thank you.
Good applause for the speakers and for the share, okay?
Thank you.
Well done. Okay, so thank you, Gonçalo, and the speakers for the interesting session. Without further ado, because we're a little behind the schedule, we'll go to robotics and simulation. And we have Fernando Freitas, who is going to coordinate this session. So Fernando, please go ahead.
Yes, thank you, Tiago. So good afternoon, everyone, and welcome to the robotics and simulation track session. My name is Fernando Freitas, and I am one of the track chairs, being the other one, Paulo Jorge Ferreira, but I will be hosting the session. This session is quite smaller comparing to the others. There are only 2 presentations, and the first one will be about the simulation environment for beam picking. And the person who will tell us about that is Gonçalo Leão. I don't know if you had time to switch context from their session to presenter.
Yes, let me prepare here my screen.
Yes.
Just switching the context between presenter, session chair, and presenter.
Yes, I can see your presentation. You can start when you are ready.
Looks good.
Thank you. Okay, so good afternoon, everyone. My name is Gonçalo, and I'll be presenting my paper entitled Using Simulation to Evaluate a Two-Perception Algorithm for Bin Picking. Bin picking is the task of using a robotic manipulator to remove, one by one, a set of objects that are randomly piled in a container. This challenging task is present in many industries. Examples include the installation of wire harnesses or refrigeration tubes in the automotive and aircraft industries, and processing orders in a warehouse, where the objects inside the container may be randomly stacked. The first step of any bin picking process is perceiving the contents of the bin and creating a representation for them. This perception is usually performed using a 3D scanner, which captures a point cloud of the scene. The robot then uses this representation to decide which object should be picked next and how the gripper should be positioned to grasp it. Thus, it is critical for this representation of the items to be accurate. To evaluate a perception algorithm, one needs a ground truth system, which indicates, given a point cloud of the scene, to which object each point of the cloud belongs. The ground truth can be acquired by using real-life sensors, but this has two main disadvantages. First, it is costly in terms of both money and time, since accurate depth sensors are rather expensive, and it will take days to generate hundreds of test cases. Secondly, this task will be rather cumbersome, since it often requires manual annotation of the point cloud to establish the correspondences between items and points. An alternative is to use simulation to generate synthetic point clouds. Several researchers have proposed this type of solution by using computer-aided design models of the items inside the bin. In this work, I focused on the case of curved tubes, and I present an alternative solution. Rather than using CAD models, I propose a procedural generation algorithm to allow for intra-class variation of the tube's shapes. I also propose a metric to evaluate the accuracy of modeling algorithms. Finally, to illustrate both the test case generator and the performance metric, I apply them to evaluate, in an automated manner, the performance of a tube modeling algorithm that I developed on previous research and that I will briefly present. This algorithm was originally evaluated manually. So starting off with the dataset generator, each tube is modeled as a linked list of cylinders. The procedural generator receives as input a graph that indicates the length of each section of the tube and where its bifurcations are located. Then, for each linear section of a tube, it performs two steps. First, it splits the tube into a set of cylinders at random intervals. And then it randomly defines the angle between consecutive cylinders. To perform the dataset generation, I used Gazebo, a simulator commonly used in robotics, to create a virtual scene which is initially composed of an empty bin. Then, each tube is spawned at a certain height above the bin and at a position that enables it to fall inside the bin. After spawning all of the tubes, the simulator waits for all of them to have a linear and angular velocity below a certain threshold. Making the tubes drop into the bin rather than simply spawning them directly inside and without using gravity provides much more realism for the tube's positions. This generator has a high number of parameters that can be defined by the user, such as the number of tubes to be added to the bin and their shape. To evaluate the efficiency of the generator, 3 sets of tubes were defined. Sets A and B consisted of tubes without bifurcation, where those in set B have a higher curvature. Set C, on the other hand, contained tubes with 2 bifurcations. Each test set contained 20 test cases for distinct amounts of tubes between 1 and 15, and an additional 20 test cases of bins with 20 tubes to determine how well the generator scales. All of these generated datasets are publicly available on GitHub. The results show that, on average, test cases on set B required the least time to be generated, whereas those in set C required the most. I hypothesize that this is due to the tubes in set B occupying, in general, a lower volume in the bin compared to the other datasets, which reduces the number of collisions between objects and thus enables the items to stabilize inside the bin faster. Moving on to the tube modeling algorithm that we developed on previous work, this solution has 4 main phases: filtering, segmentation, cylinder fitting, and tube joining. The filtering phase removes all the points that do not belong to the tubes. Also, the cloud may be downsampled in order to reduce the processing time of the following steps. The filtered point cloud is then used as input to the second phase, which divides the point cloud into a disjoint set of regions where the surface normals vary smoothly using a region growing algorithm. In other words, it detects clusters of the point cloud that correspond to continuous portions of a tube. During the cylinder fitting phase, each segment from the previous phase is processed independently. We repeatedly apply random sample consensus to each segment, with the outliers of a cylinder serving as input to the next call to ransack, until the number of remaining points is too low to form a new cylinder. Creating multiple cylinders for each segment enables us to model curved sections of the tubes. Finally, the fourth phase progressively combines the cylinders into complete tubes by prioritizing pairs of cylinders that are closer together. The algorithm produces 2 outputs: a representation of the tubes as linked lists of cylinders and a labeled point cloud, where each point is associated with the respective tube and each tube is given a distinct color. The points that were not associated with any of the cylinders during the cylinder phase are labeled with a null color. Our proposed metric to evaluate perception algorithms compares 2 point clouds, one with the ground truth colors and the one with the colors returned by the perception algorithm. If the algorithm applies any filter to the cloud, then only the points that are kept by the filters are considered in this metric. And this is done to avoid penalizing solutions for removing points that they do not require in their computations. As a result, the 2 point clouds that are compared have the same amount of points in the same positions, and they only differ in their color. To establish a matching between ground truth and label colors, a bipartite graph is defined where each vertex has the color of one of these 2 color spaces. Edges are created to connect vertices of these 2 colors and have a weight equal to the number of points that have each pair of colors. The matching between the 2 color spaces corresponds to the classic problem of a maximum cost assignment, which can be solved using the Hungarian method. This matching indicates for each ground truth color which is the correct corresponding label color. And finally, the performance metric, known as micro-recall, is simply the quotient between the amount of correctly labeled points and the total amount of points. To evaluate our tube perception algorithm and compare its performance with the manual evaluation of previous work, we used sets A and B, where the tubes in set B resemble the most those used in real life on previous research. We did not use the tubes in set C since the modeling algorithm currently does not handle bifurcations. The parameters of each phase of the algorithm obviously are the same as those used on previous research, so that the results are comparable. And in addition, we experimented using different ratios for an initial downsampling filter, which only keeps a percentage of the points of the input point cloud. For each test case and distinct downsampling ratio, the perception algorithm was executed 10 times to compute an average performance. This first set of results show that for a fixed downsampling ratio, the accuracy decreases with the amount of tubes in the bin, which makes sense since larger amounts of tubes lead to more occlusions and entanglement, which makes it harder to accurately reconstruct the tubes. Also, in set B, the performance of a single tube was smaller than with 2 to 4 tubes. And we speculate that this is due to issues with the region growing step, which sometimes fails to create a sufficiently large cluster for a tube section. And since the performance metric gives equal weight to all the points, this issue becomes more prevalent in smaller point clouds. These two phenomena were also observed on previous research, which helps to establish that the micro-recall metric allows for a reliable evaluation of the modeling algorithm. The second set of results show how the performance and execution time are affected by the downsampling ratio. As expected, as the downsampling ratio increases, so does the performance of the solution, since the algorithm has more points, more data to work with. However, that comes with the cost that more time is needed to produce the models. Therefore, we have here a trade-off between execution time and modeling accuracy that is regulated by the size of the input point cloud. And this illustrates why it is very important to fine-tune the algorithm's parameters according to the application domain. To sum up, the main contribution of this work is an entangled tube dataset generator that allows for intra-class shape variation and enables a user to create datasets of over 200 test cases in a single hour. In addition, the proposed performance metric allows one to evaluate bin picking modeling algorithms in an automated manner. Experiments with synthetic datasets and our proposed micro-recall metric produced similar results to those found on previous work with data from physical sensors. So this suggests that the generated point clouds and the micro-recall metric are reliable. As future work, one could extend the procedural generator to create objects or of other shapes. In addition, the dataset generator allows for an enhancement of the modeling algorithm since its parameters could be calibrated using synthetic examples. As an alternative, these examples could be used to train machine learning models to model the items inside a bin. Thank you for your attention. I have here a short slide with the references that I used to support this presentation. And now I'm available to answer your questions.
Thank you, Gonçalo. And I remind you that you can submit questions on Slido while people submit questions. Professor Augusto, I don't know if you want to comment or should I jump to the questions?
Okay, thank you. I'm here. Gonçalo, nice presentation.
Thank you.
Let me, one or two questions. When you are taking pictures, you have, let's say, illumination, and you were my student in computer graphics. We have also illumination variations of the objects. Does this help in, or can this be a help in detecting the shape of the objects or not? Because we are speaking about tubes.
When you're talking about illumination issues, you mean the grayscale, or for example,
Yes,
RGB.
yes.
Both of these approaches can be used to enhance modeling algorithms, and there's already a vast body of knowledge on this topic. In my work, I focused solely on processing the 3D information, only the position.
It's not a 3D information; it's a 2D information, isn't it? What you are seeing in this picture.
Yeah, what you're seeing in this picture is the RGB, but I'm not using these colors to help me separate the tubes. What you're seeing here, the colors that are in this GIF correspond to the ground truth colors. So they're like the answer sheet. They're telling you to which tube each point belongs. The algorithm is not supposed to use these colors, or else
what I was saying is different, Gonçalo. You didn't understand. What I was saying was you are actually processing only 2D information. You don't have any 3D information, because the only thing that you have is a projection.
No, I'm processing 3D information. This is an image of the gazebo simulator from a 3D perspective. I'm processing 3D point clouds, only 3D information.
You have the depth?
This is a picture. Yes, I have the depth. This is just a picture. But I thought you were asking the question, which is also a very interesting question. You could be asking me, oh, if you have the colors there, why don't you use them? I thought that's what you were asking.
To obtain a third dimension, if you understand me, from the illumination, but you have the third dimension from the depth.
This picture comes from Gazebo's GUI, graphic user interface. This is from a specific perspective. I can freely rotate the camera and have taken pictures from other perspectives.
Okay, this changes a little my understanding of the problem. Can you put the slide number 19?
Sure.
This graphic tends to be, the right graphic tends to be, let's say, monotonic, okay?
Yes.
But in the number of 10 tubes, there is something strange, some noise, I don't know. It is not so monotonic in that part. Do you have any explanation for that?
I have an explanation. Yes, there are a couple of steps in our modeling algorithm that have stochastic factors. In particular, RANSAC, which is inherently a randomized algorithm, and also the region growing algorithm, which is very sensitive to changes in the test case. Some test cases work very well, others work a little bit less well. So I believe that using a larger sample than the 10 test cases that I used, that we will be able to obtain a more cleaner monotonic line.
And above 10?
Above 10?
Is also monotonic. It's the thing is, it's more or less monotonic over 10 and
below 10
and below also. The number 10 is the strange.
It was 10, but it could have been 9. It could have been 8. I admit this. I could have performed the experiments with a larger number of test cases to have a cleaner line, but that was not the main goal of my research. The main goal was to establish, was to try to find common points between the results using simulation and the results on the table that you can see on your left. That was the goal.
I understand.
So it's fine if there's some irregularities.
Yeah, sometimes we have some irregularities in the behavior of some graphics because a certain part of the implementation, a certain detail of the implementation, okay?
Yes, and
sometimes it's not the case, but sometimes we have in time processing, we have problems that are related, for example, with the size of the cache, okay?
Yes, yes.
And we have to deal with those problems. About the future work, other shapes did you mention? Okay, you did mention this. Other shapes mean bifurcations or other objects?
I'm talking about one example that in my laboratory in Cris of Inesctec, an example that a couple of researchers worked on in the past was with some refrigeration tubes from a car, from a vehicle. And what happens, there are tubes, very large, heavy tubes that have bifurcations, but along with the bifurcations, they also have some attachments to them. They have like a point with a shape that looks like a sphere or other points next to them. What I'm suggesting here in this first point for future work is that in my procedural generator algorithm, I only create cylinders. I can also create other types of shapes.
Okay.
To try to model these more complex types of tubes, such as the ones used in vehicles.
It is not only to include the bifurcations that you put aside until now.
It is for the bifurcations and for other attachments. And it can also be in the future for other types of objects that are not related at all to tubes, because my micro recall metric is completely generic. It's not specific to tubes.
Okay, the only thing I could mention about your presentation is smaller discussion about the state of the art around this subject.
Yeah, I was.
Okay.
Yes,
okay.
I was expecting that comment. Actually, I thought for some time if I should add more information about the state of the art, but due to time management issues, I consider that it was not as relevant. What I presented in detail was this previous work that we researched in our lab, and I mentioned also here in one of the slides where with the objectives, I mentioned here the names of the main authors who also developed data sets for bean picking.
Okay.
I did not mention them due to time management, but I added them to this slide. It was,
okay, Gonçalo.
If it were 20 minutes, I would most likely present that part.
Okay, thank you. I'm done. Thank you,
Professor.
Okay, thank you. Gonçalo, your presentation is one of the most popular. A lot of questions.
Wow.
I will start with the most voted. João Souza asks, why did you use a micro recall metric for the evaluation? Why not a metric that gives equal weight to all the tubes?
That's actually a very good question. So basically, if I understood well the question, what João is asking is why did I use a micro recall metric and not a macro recall metric, for example? A macro recall metric would give each tube the same weight versus what I did where each point has the same weight. And that's a very pertinent question. I chose the micro recall because when we're in a bean picking scenario, it's fine if we have a couple of tubes that have too many occlusions. It's fine. What we need is for a small subset of tubes to be correctly modeled, so that we have a subset of tubes that can be easily picked by the robot. So if we have more tubes, as we remove some of the tubes, the ones that are below will become more visible. So in my metric, I want to penalize algorithms that are not able to correctly model tubes that are more visible to the camera. That's basically the reason. But that's a very, very good question.
Thank you, Gonçalo. I feel tempted to ask more questions, but I will ask participants to reach you directly because
yes, you have my email.
Yes,
if you're interested.
And if they are here in Zoom, they can ask you via chat. So please contact Gonçalo directly. Sorry for not answering all your questions. So thank you, Gonçalo, for your presentation.
Thank you.
So the second and last presentation for this session will be about the simulation environment for a blockchain system. So blockchain has been a buzzword for the past years. Let's hear Denis Trigo. Are you online?
Yes.
And over to you.
I'm going to share my screen. Okay, so can you
I can see.
Okay.
You can start when you want.
Okay, so as you can see from the title, my work is an agent-based simulation of a blockchain incentive system to support the auditing of traceability data, more specifically health research data. So the title might seem a little bit scary, but let's start by describing the context. So in this context of health data, we are able to identify three main entities. We have the patients, the health companies, which provide service to the patients, and we have the research projects. Our main goal is to support the interests of the research projects so as to improve their progress without compromising the interests of these two entities right here, the patients and the health companies, namely the privacy, because it's a very important topic these days, especially when we are talking about health data. And with a decentralized approach, with blockchain, we are confident that we can support the cooperation in a system that we have competitive interests and even between the research projects. So this simulation aims to evaluate a previously developed solution called iReceptor chain, developed as an MSc thesis. So on a very high level, this solution is composed by two main components, being a decentralized traceability data registry, which is a registry where the research projects can create traceability data entries to register the health data traceability. And on top of that, we have an auditing system to verify that traceability data, where entities are incentivized to cooperate with each other, verifying the data, as well as providing a way to have more confidence about the veracity of the data stored on the blockchain. On a more lower level, we have voting rounds as a process to audit the traceability information. And we used the reputation as an incentive resource. Classical blockchain approaches use money, and here we use reputation because we believe it's a very important resource for these entities. And on a more technological level, we used, of course, blockchain technology to power our decentralized database, and we use a proof of stake as a consensus algorithm. It's not exactly the same as the one used in cryptocurrency, but it's one more adapted to our health data context. So our main goal here is to evaluate incentive systems, an incentive system that is already designed. So first we need to understand what is important when we are evaluating that. And for that, we need to see what an incentive system should be capable of. Well, it should provide a balance, a natural balance of rewards and penalties, so that users are naturally incentivized to perform correct behavior and discouraged to perform incorrect behavior, without the need of legal penalties from the outside, from the police or whatever. We want to incentivize correct behavior using just our system, not being dependent on external forces. So we performed a state-of-the-art review, which has the three main top areas into account: multi-agent systems, modeling and simulation, and blockchain. We found 38 articles regarding multi-agent systems and blockchain, but from these ones, we are most interested in 11 of them, which are multi-agent systems, multi-agent system approaches to model and simulate blockchain systems. So zooming in on those 11 approaches, we have 4 that are dedicated to modeling and simulating the Bitcoin mining, 2 are dedicated to modeling and simulating specific blockchain-based approaches. And 2 are to evaluate consensus protocols. And 3, and the most interesting, are the 3 generic purpose blockchain simulators that aim to be able to simulate blockchain-based approaches like ours, and that they aim to be generic enough to simulate blockchain-based approaches of any kind. So the first ones, the ones for Bitcoin mining, modeling and simulation, they model users and miners as agents, and which act rationally and maximize profit by choosing the action that is most profitable for them. But these solutions are not very interesting for us still, because they are specific to the strict domain of Bitcoin mining, and our domain is health data, which changes a lot. So it's not exactly what we are trying to do here. Then we have the blockchain-based solutions. They are still specific to certain solutions and strict domains, which are not health data. So they are not exactly comparable to what we are trying to achieve here. And they don't focus on evaluating specifically the incentive system of the blockchain, but the entire approach as a whole. And then we have the evaluation of consensus protocols, which are closer to our goal, but still they are specific to certain consensus protocols, and none of them involve health data. But although they provide general ideas on how to evaluate incentive systems. Then we have the most interesting ones, that are the approaches and frameworks to model and simulate blockchain systems. These are meant to be generic approaches and frameworks, and allow for simulation of blockchains in general. So we were confident at the beginning that they would provide us with a possibility of simulating our previously developed work. However, they are not customizable enough, and they, or at least to our understanding, they are not suitable to simulate our blockchain-based approach. So we kind of started from scratch and just developed a simulation right from a simple Java application. Going into that, so we built an agent-based simulation that is rather simple in terms of execution flow. So we have the creator agents that create traceability data entries by calling the blockchain, and we have the validators agents that submit votes to the blockchain, and then the blockchain decides by consensus whether the data created is valid or not by the majority of the voters. So in our agent-based model, we have multiple types of behaviors. We have two main types, the creator and the voter. So some agents are creators, some agents are voters, and both creator and voter can be ethical or unethical. So an ethical is one that only creates correct traceability data entries, and then an ethical agent is one that is trying to spam the database. A voter, an ethical voter, is one that always performs the validation and always submits the correct vote. The unethical does not perform the validation because that is computationally expensive, and he tries to cheat the system either by submitting a random vote, which is not very smart because he would mathematically be outruled by the ethical voters as long as they are in majority. And then we have other smarter unethical agents which follow the majority or contradict it. The reason why we have this contradict majority here is because if you follow the majority, you have more probability of being right, because it's what the majority said. But if you contradict the majority, you may have a higher slice of the reward, because it's split by the ones who said what you said. So that's why we have the contradict majority here as well. So for our simulation, we set up two different scenarios. One, to evaluate the Byzantine fault tolerance of the system, meaning whether the system is able to react properly to Byzantine faults. And Byzantine faults are faults that are not fail-stop, that we have a node that is introducing some weird behavior in the network, either intentionally or unintentionally. And for this Byzantine fault tolerance, we study how different ratios of ethical versus unethical agents influence the entire wealth of the network. And we also want to evaluate the scalability and cooperation, so that we can study how different ratios of creator versus voter influence the wealth of the system. This is also important because we have to remember that this is not a matter of only Byzantine fault tolerance. We have creators asking for a service and voters providing that service. So we need to have a balance here. If you have too many people asking for a service and not that much people providing the service, we have a problem. And we want to evaluate that as well. So we started with the Byzantine fault tolerance. We started with the majority being ethical. We have 98% ethical and 2% unethical, 10% creators and 90% voters. So pretty balanced for the wealth for the second part, because we're not testing it here. And between trials, we progressively increase the amount of unethical agents with a step of 2%. And the creating versus voting ratio is not changed because we're not trying to evaluate that now. The last trial was run with 66% unethical and 33% ethical. Sorry, the order is wrong. There is an incorrect spelling here. So we after running the trials, we were able to present to elaborate this chart. We can see here that we start to have more than 2% of incorrectly classified entries only after 30% of unethical agents. At 50%, we have around 8 to 10% maximum of incorrectly classified entries, which is well, could be better, but it's not too bad. But we were actually surprised that at 66%, we were expecting, since we have a lot of unethical agents on the network, we were expecting to have more problems here, but we don't have that much of a problem because we only have 80% of incorrectly classified entries. So moving on to the creator voter ratio, the creator voter ratio balance. We started with 10% creating and 90% voters, and then we progressively increased the amount of created agents with a step of 2%. The ethical versus unethical ratio was not changed because we're not studying that now. And the last trial was run with the majority being creator agents, of course, and we have 80% creators asking for a service and only 20% voters providing that service. And what we got was this chart. This is not as good as the last one because as soon as we reach 25%, until 25%, everything is fine. But as soon as we have more than 25% agents asking for a service, this percentage of entities of traceability data entries awaiting validation goes up very fast, and at 50% we already have 60% of the entries not being validated, and this is a problem. We know that our system does not handle very well when we have a lot of creators versus voters. So, but it's normal when you have a lot of people asking for a service and not that much providing it that this happens, but it's something that we need to keep in mind. We were satisfied with the Byzantine fault tolerance, but not so much with the balance of creators and voters. So in conclusion, we were able to support the Byzantine fault tolerance. However, this research work is not concluded yet. We want to further evaluate the solution better by using real world scenarios with the ratios of these metrics that we studied, possibly through a case study on a research project of this field. So that was my presentation. Thanks for your attention. I am now open to comments and questions.
Thank you, Denise, for your presentation. I already have one question, but I will hand over first to Professor Augusto to give you some comments. Professor Augusto.
Okay, thank you. My first comment is a good presentation, and during the state of the art, always showing at the bottom the references that are being the basis of that slide, okay? And that was enjoyable to me. So it means that you actually saw those references and are using data from scientific work done before yourself. About the presentation, Denise, I missed a little first slide with the agenda of the presentation, a small summary of what you are going to present, okay? But immediately you started with the context, with the previously developed solution, and mainly with the goal that you want to obtain. The state of the art was long and good, in my opinion. I'm not sure about the deepness, scientific deepness, because I am out of this scope, but it looked very well structured and as I told you, with references, etc. After that, you made a simulation with scenarios. You described the creators and the voters, and immediately at the beginning you made some comments about the numbers of creators and voters, etc. And actually, it was more or less proved by the numbers that some of these initial comments were true. For example, this last conclusion of yours about the 25%. To be honest, I was expecting a number a little higher. 25% looks me a small number in percentage of.
You're talking about this or
yes,
the,
yeah.
No, this.
This one. This 25, 24 or 25% looks to be a small number in the overall system. I was expecting more, something about around 40 something percent, 50%. Do you have any comments to this?
Yeah, so you were expecting the system to only get overloaded at 40. That's what
yes,
you.
More yes. On that numbers, yeah.
Yes, yeah, I think you are. It's absolutely normal to expect that. It's what most people will expect. Well, it's due to the fact that this kind of processing really doesn't take much necessary effort to create, or the creators don't need to do much work. the voters need, because we are talking about health data processing, which can easily take multiple hours of processing. And since it's a very computationally heavy work, we have this problem where we can't have too many work flooding the network. Otherwise, this can happen. However, I want to make clear that we still aim to use more real-world numbers of how heavy this work is, but I'm pretty sure that it won't get as good as only 45%.
Do you mean that the work that is being done by the voting is harder work than the work that is being done by the creator?
Yes, or at least what they do on the blockchain system, it's certainly heavier, but obviously the creator is assumed to have done that processing before, otherwise he wouldn't be creating. But ignoring that processing done by him before, then yes, the interaction with the blockchain, it's much easier by the creator, because it's simply an upload of data, whereas from the voter it requires validation. We still need to use, like I said, real world measurements to see how well balanced this would be.
That's another question. What is real world measures? How do you obtain this?
Through a case study on a research project with entities that actually work on this field. That's my idea of a future work for this.
But isn't that to focus in a certain type of application?
Yes, because I can imagine two kinds of applications. One more industrial, where the processors would have supercomputers, the voters would have supercomputers running the processing, and another to a more academic community, where the creators simply want to share knowledge with other researchers, and they don't have supercomputers. So it does change the numbers a lot. But yes, it's something I want to tackle in the future. Okay. It's definitely an interesting point of view.
Simulation has certain problems, because when we try to fit simulation to the real world, we have in simulation we can have numbers without units. Let's say units of time, units of something. But in the real world, we have real units to accomplish with. About the presentation, I enjoyed the slides. I enjoyed your posture, and it was okay. The only thing is the initial. You should include a small slide with what are the main topics of your presentation, a summary of your presentation, conclusions, discussion. It was good. I enjoyed very much the state of the art, the way you showed us the state of the art, always with the references. So next time you will do a perfect presentation. Okay,
it's an agenda. Yes.
Thank you.
Okay, thank you.
Thank you, Professor Augusto. Dinesh, there is a question submitted. So Abdurreza asks, the blockchain generates additional traffic to update the registries in all involved devices. Why you did not consider this an important item?
That's an interesting question. I would have possibly provided an answer to that if I had time to explain the solution better. But what was missing here to answer that question is that on the simulation, we are only interested in evaluating this second component here. Let me just get. Okay, so the previously developed work is composed by two main components, a decentralized traceability data registry, and on top of that, an auditing system to verify that traceability data. And we are only interested in evaluating the performance of this auditing system, but not worrying too much about blockchain and networks itself, just focusing on the logic, on the outcomes generated by each action of the agents on this auditing system. And therefore, we actually didn't model the network part of the blockchain, because there is a different layer of the work. This is a layer done on top of it. But yes, it is important to also provide a simulation of the system as a whole to evaluate different performance metrics. However, on this one, we focus specifically only in the auditing system. So that's why we didn't include that.
Okay, thank you, Dinis, for your presentation. We don't have time for more questions. So I want to thank you, Dinis and Gonçalo, again for the presentations and the virtual applause to you. And I'm going to close this session.
Thank you.
And over
Also
to you,
for the chairman.
Thank you.
Thank you, Fernando. So we are 20 minutes behind the schedule, so we will go to, and the next thing will be another lab. So we will be knowing another research lab from FEUP or around FEUP. And after that, we will do a break. We plan to have a break of 20 minutes. I say we will reduce it to 10
minutes.
And that means that we will all be back here for the next section at 4:50.
Welcome to InfoLab, the Information Systems Lab at the Faculty of Engineering of the University of Porto. Our mission is to design, implement and evaluate information systems for a broad area of applications, addressing relevant problems in research, industry and society in general. Research and projects at InfoLab cover the topics of information management, research data management, information retrieval, human information interaction, information visualization, and World Wide Web. To do so, InfoLab combines different backgrounds on informatics engineering and information science. We gather senior and postdoc researchers with PhD and master students and other junior researchers in a collaborative atmosphere that leads to top-notch research projects. The current research projects at InfoLab include Dendro, a platform designed to help researchers use concepts from domain-specific ontologies to collaboratively describe and share datasets within their groups. Another example is Lab Tablet, a mobile application that tackles the often cumbersome task that researchers have in describing their research by facilitating the metadata production while also considering the existing standards for its representation. With Ant, a web search engine prototype, we created an original information retrieval framework and workbench for innovation in entity-oriented search. For researchers, academics, and professionals interested in media studies, we developed MediaViz, a platform that aims to provide them with a set of analytical and exploratory resources to answer high-level and complex questions about the online media ecosystem in an efficient, visual, and interactive way. APISA, Entity and Property Inference for Semantic Archives, is a project that works on the 3.5 million records of the Portuguese National Archives using semantic web and linked data technologies. APISA will deliver a semantic model for the information in the archives, as well as a prototype applications for archival description and flexible interrogation. The new archival infrastructure provides application interfaces to streamline the incorporation of new resources and access by international aggregators. Another project that is inherently interdisciplinary is Stop Propagate. Stop Propagate uses artificial intelligence to help detect and reduce hate speech in online news media. Our prototype provides news organizations with a way to automatically identify hate speech within comments, but also to predict the likelihood of a news piece to prompt such comments in the first place. When it comes to health, we developed innovative tools such as health talks and health suggestions. The main goal of these tools is to improve the access and comprehension of health information by lay people. Health Talks is a mobile app that helps to manage personal health information, recall physicians' advices, share the advices with someone of trust, and clarify the information provided in medical appointments. Health Suggestions is another Google Chrome extension to assist people searching for health-related subjects in the main three search engines, Google, Bing, and Yahoo. It suggests related search queries in lay and medico-scientific terminology using English and users' native language. These are a few examples of what can be achieved through interdisciplinary research. And this is what InfoLab is all about. A place that brings together teachers, researchers, and students with a true passion for developing projects that impact the community.
Celsus stands for Health Monitoring and Lifelong Capability Management for Self-Sustaining Manufacturing System, with the aim to reduce costs, increase OEE, but even more important, to increase production reliability. 15 partners from 6 countries approved the applicability of the solution on component, the system and the line level.
Celsus project for us was important to understand and to learn about asset utilization, because implementing Celsus in the press shop, in particular in our press line, up to now we are able to know exactly more about asset utilization, about predictive maintenance, and also we are able in real time to display the performance of the equipment.
Poor quality results in disruption on the production line, test failures, rework actions having to be done on engines, and ultimately this leads to ongoing costs for Ford, as well as possible quality issues in vehicles in the future. So the aim of Celsus is to address the root cause of these problems, which is the issues that develop here in the dosa. So Celsus has added a number of sensors to these machines, such as these hydraulic sensors here, temperature sensors inside the working area, and these are monitoring the characteristics that the machine is showing throughout its cycles and looking for trends that are signs of deterioration. All of this data is uploaded to the cloud-based system.
In case of Harms-Wende, the main market is the automotive industry. In this automotive industry, it's very important to reduce the downtime because each downtime costs a high amount of money. For this, we developed here an algorithm to reduce this with the limping home mode.
This limping home mode, the data which are provided by Harms-Wende via the cloud services, we can use as Werner to reduce the dynamics of our linear axis and therewith prolong the overall lifetime and reduce maintenance and therewith costs as well.
So equipment health is very important for us. The Celsus demonstrator is one of our flagship demonstrators in that area. And some of the things that it does for industries, it enables them to spend less time in non-value-added activities, for example, investigation of failures. By providing more information, it means that the operators can perform their tasks and activities quickly.
Here we have our Celsus demonstrator cell. It is a self-monitoring device that can self-heal from a catastrophic event such as a collision. So this is the collision that is programmed in. From here you can see that the springs have retracted, and this is now doing a pressure test to make sure that it has fixed itself correctly.
Hello everyone, so welcome back. Let's get to the next part of our conference, so DSIE 2021. And now we're going to talk about artificial intelligence. And for that, for session 6, we have Tomás Osório, which is going to animate the session. So Tomás, are you ready?
Yes, sure. Hi.
Okay.
Good afternoon. This session will be about artificial intelligence techniques. We are going to have 2 presentations. The first is reducing the portfolio of machine learning workflows using a meta-learning approach by Fernando Freitas. Fernando Freitas, if you're ready, go for it.
Thank you, Tomás. I'm going to start sharing. Can you confirm that you can see the screen?
Yeah, we are seeing.
Okay. So, hello again. I'm going to present the work reducing the portfolio of a machine learning workflows using a meta-learning approach. So, a small introduction to the agenda. I'm going to talk a little bit about background context and motivation for this work, and then tell you about the proposal and the objectives of the work. Really briefly, just discuss about related work, and then going to present average ranking, which is an algorithm that you will be using for our study, and then describe the methodology for the workflow production. After that, I'm going to tell you about the experimental setup, and then the experimental results and the conclusion. So from the past years, the machine learning has been popular, and with that, not only people with the computer science background has been using, it's everyone with different backgrounds. So that means that those people need at least to master the data domain and the design process, which includes the pre-processing tasks and model configurations and tuning. And the number of algorithms has been increasing from the past years, and it is known that no algorithm fits all purposes. So the process to find the right algorithms goes through a trial and error process, which is time-consuming and resource-intensive. And it's because of that, the automated machine learning, it's an area that is getting some interest in the recent years, and is dedicated to automating the constructions of pipelines in automatic way, and therefore avoid the wasting of testing poor performing algorithms, and then save computational resources. So one way of saving those resources is by reducing the configuration space. So if we have a list of workflows, then we don't need to have them all go through the trial and error process. So here a workflow, I'm talking about pre-processing and algorithm selection and hyperparameter configuration. I have an example of a very generic workflow. Of course, there can be more interactions between all these phases, but when I talk about workflow, it's about some pre-processing tasks and also the algorithm selection and hyperparameter configuration. So how to reduce this configuration space? So the proposal is a two-step method, and the first one is to identify the competitive workflows and then eliminate from the portfolio those that are not competitive. And second step is to eliminate redundant workflows. If there are some that achieve the same accuracy, we don't need to use them as well. I will go deep dive in more detail to this proposal. And the average ranking is an algorithm selection method that will be used to study this production of workflow. So the main objective is to establish if the reduced portfolio can also opt for good performance and fast workflows when comparing with the full portfolio. So just to talk a little bit about related work. For time's sake, I cannot present the extensive related work. Just to mention that this is related also associated with just algorithm selections or hyperparameter optimization, or the combination of both, right? Some on the hyperparameter optimization, grid search and random search are very popular. I've heard today people mention grid search today. So these are quite used, but the state-of-the-art, more recent approaches using Bayesian optimization, where probabilistic models are taken into consideration, or multi-armed bandit approach. And also I want to mention that there are some tools and libraries that are being used for automated machine learning, and therefore they are also using somehow a reduction of the portfolio. And AutoEK is one popular, and the library it's Hyperopt scikit-learn. So I'm going to introduce a little bit about average ranking, which will be used to conduct the study. And this is a simple algorithm selection method that in which the final ranking is the average of the behavior of the performance of the algorithms in several data sets. So have here this example. So on this data set one, we have the performance, the ranked performance, and then according to the performance across several data sets, we have an average ranking, and the one with that as a most consensual performance among all data sets is chosen. So this is the recommended ranking. So I'm using the algorithm selection, but I'm talking about workflows. And what is going to be done here is that by merging, it's merging the configurations and parameters configurations into a single space. So if we have an algorithm with 3 or 4 hyperparameter configurations, that can be used in average ranking as 4 different algorithms. And this is a common practice in algorithm selections and hyperparameter optimization works to unify these configuration space. The average ranking uses the accuracy, but I'm going to use a variant that also takes in consideration the runtime of the workflow. And this and there is a parameter Q for that metric that is called A3R that controls the importance of the accuracy and runtime. This parameter was studied by Abdul Rahman, and then he found that the 1/64 is the best one to use in average ranking. So I use based on that work. Just to tell you that to evaluate ranking, I'm going to use loss time curves. And this is a way to measure the difference between the performance of the algorithm of the ranking comparing with the best performance. So if you look here at the curve, that means that at almost 100 seconds, the ranking found the best algorithm, and therefore the loss time curve reaches 0, and that's when the best algorithm was found. So these curves can also be translated into a number by doing the average of the loss between this interval, and this is known as mean interval loss. So deep diving into the methodology, I mentioned 2 steps. The first one is to identify the competitive workflows. And that is then what the data set at the time. For example, this data set one, we have we ranked the workflows by performance, and this workflow 4 is the top performer. We are going to compare with the rest of the ranking with the best one. If they have compared performance based on a statistical test, then it is considered competitive. So among all the collections of data set in this example, we reduce the 5 workflows to 3, considering the union of all the competitive workflows. The second step is a step further to the step 1, and picking the competitive workflows, we sort the workflows by frequency, and then we do a minimum cover set procedure, which means that we are going through selecting the workflows by frequency, and then when we reach all the data sets in the collection, then we stop, and then we have these two workflows in the portfolio. So this is based on the idea that if these are considered experts between all the data sets. So the experimental setup, it was used 37 data sets and 368 workflows with 62 different algorithms with default configurations, and then added some 30 variants with different type of parameters, and then two pre-processing tasks like feature selection and feature standardization was added, and the combination of 1, 2, or none of the pre-processing tasks. So we are going to do 3 comparative studies. The first is the baseline, which is to do the average ranking that uses the entire portfolio, which is 368 workflows, and then use the ranking using only the competitive workflows, and then the cover set where we use both step 1 and step 2, where we eliminate also the redundant workflows. It was used a leave one out cross validation, which means that we did 37 experiments, and one was left out to do the study, and then the evaluation was then doing the average for all these cross validation experiments. So going to the results, and as I present the results, I also give some discussion about it. So going through the competitive workflows, and there are 14 data sets that only the top performer workflow did not have competitive, and the highest number is for the dataset 23 with 29 workflows. We have an average of 6 competitive workflows per dataset. So if we look how much the ranking was, the ranking was reduced on the first step, we have different numbers for different data sets because we are on leave one out cross validation, but there is an average of 128 workflows, which means that it was reduced 65% of the workflows, so we don't need to test them. So we are with only 35% of the workflows at step 1. If we use step 4 for the second, then we can reduce those down to 5% of the workflows. We have an average of 20 workflows from 368 from the second, using the first and second steps. So is this enough to find the best? Let's find out. So I have here the lost time curves. And then I mentioned those can be converted to numbers, which is easier to read. This is a translation of the curves into numbers. And we can see in red that when we reduce the workflows to 35% of workflows, they have a similar behavior to the baseline, which means that it was able to find, and it is likely to find the best performer in the reduced portfolio. That's why the red dotted line reaches the 0. But when we look at the further reductions with the cover set, we have only 5% workflow, but the curve did not reach 0, which means that is not likely to contain the experts and the best algorithm. So for using the second step, you are reducing too much of the portfolio. But if we are looking at a scenario where we have very, very budget constraints, it can be competitive because up to 10-second mark, it was the best one. So it depends on the scenario and if users are willing to compromise performance if the time is more important. So as the conclusion, it was proposed a method to reduce the portfolio of the workflows using the average ranking as measure. And the first strategy using step 1 only reduced workflow down to 35% and with a lost time curve similar to the baseline, which means that is likely to recommend the best workflow. And avoiding testing 65% of poor performing workflows. When you go to the second strategy, the lost time curve did not reach to 0, so 5% of the workflows is not enough and is not likely to find the best one. But if you are working with a very low budget in time, we might use this strategy. It's a compromise between time and accuracy. As for the future work, we could study the impact of parameter Q, which is the control time and accuracy, and see what would be the results. And also, when we are looking into the accuracy, we are looking at a micro level diversity, which means that we look at the entire data set. So we might be on second step reducing too much because we are looking only in a micro level measure. So if you consider a micro level similarity measures, maybe we reduce not too much on second steps, and maybe could have also a further reductions without losing the best algorithms. And thank you. I can answer your question.
Thank you very much for your presentation. So first, I would like to ask Professor Augusto Sousa, if he has some remarks regarding this.
Okay. I'm here. Fernando.
Yes.
Good presentation, starting with the agenda, background and motivation, proposal and objectives, related work with references, average rank. Actually, related work could be a little more extended, but I believe that you could not fit the presentation in the time that you have. And after that, a practical analysis, let's say in a case study or something similar, presented a methodology and experimental setup. Let me, my first question is a generic question. That is, reducing the workflows, doesn't it depends on the type of application of the study that you are doing?
So we, of course, that depends on the performance on different data sets. Of course, we should have as much as possible the number of data sets, but of course that could be have a different behavior in a different. So to be successful, we should increase the collection of data sets to have a good representation. And I did not mention, but one of future works is to enrich that metadatabase. But you could have different results in a different data set. You are right, but that is what. But it's better to rely on these meta performance data rather than just randomly pick some of the algorithms like people do, because this is just a recommendation. Of course, it's always up to the user to try and error and see and evaluate every workflow.
Okay, can you put? I don't remember. Can you put slide number 9?
Yes.
To me to try to remember. Exactly. How did you conclude that the 3 the three workflows are 1, 2, and 4.
So in this case, these are the top performance for each the data set, right? So for data set 1, this is the top, and we did a statistical test to check if the workflow 2 has the same performance, at least according to a statistic test. And then for the entire portfolio is the reunion on all these competitive across all data sets. So if you look here into the blues, so it's the reunion of all the blues.
All the blues. Okay, but the blues are those that appear more times. Is that?
No, there are the top performers for each data set. These are on the top, and these are competitive on that data set.
Ah, competitive.
Yes, so that means they have a similar performance, high performance, according to a statistical test.
I was thinking that number 3 and number 5 could be also, they are in the second place. In other terms, workflow number 4 has in data set 2 and data set 3 has a poor performance. And I was thinking that why do enter number 4 and do not enter number 3 and number 5?
The reason is because they are not considered in any of these data sets. And this is just an example with 5 data sets. Of course, we use 37. So in order to reduce that means that they are not competitive in any of the 37 data sets.
Okay. After that, in slide number 16, the green curve.
Yep.
Actually, we have the green curve as the better in a small portion of the graphic. If I am so that's why you don't think that it is a good solution, because after that it's worse than all the others.
Exactly. To have this 5%, which is the green, to have include the best algorithms, and they need to reach 0, and did never reach 0. So it means that it's not very likely to find the best algorithms. Well, like I mentioned, imagine that we have a very time constraint, and if we have only 10 seconds to evaluate a ranking, then we could reduce to 5%, and it's better to use that comparing to the others.
But if you compare curve in blue with curve in red, what could you say?
So they are similar, so it's better to work with 35% of the workflows, and so they have similar, and they both find the best solutions for all the data sets. So it's better to have just work with 35% of workflows, because we avoid testing the other 65% that will never reach results. That's the idea of this work, is to have initial portfolio instead of using all of it, just test 35, and then you get the same results.
It's also a question of profit. And it is in your conclusion, slide, about the second strategy is more or less related with the same. It's an economic decision, let's say like that.
Exactly. So I would say that most of the users will not use the second strategy because they give high importance to accuracy. But imagine a scenario that you have very, very low budget, then you won't go with that strategy. But I would say that most of the time people will not use because they will not. It's not likely to find the best workflow.
Okay. So I think I can finish. The slides were okay. You have good push it also, and your English is also good. So I'm done. Thank you very much. Good presentation.
Thank you, Professor.
So just one final question from the audience. Could this competitive workflow construction process work with reinforcement learning algorithms?
I'm not expert in reinforcement algorithms, but I think yes, because we are talking about a meta-learning approach, which means that it's taking in consideration previous time and accuracy. So I would say that it's possible. I cannot tell you why, but having understanding how it works, I think it's possible. It's a matter of doing the setup.
Okay, thank you very much for your presentation.
Thank you.
Without further ado, we are going to move to the next presentation, Cooperative versus Individual Learning in a Constrained Environment, presented by Tiago Carvalho. If you're ready, Tiago, please.
Can you hear me?
Yeah, and we are seeing your presentation as well.
So I'm going to present now my work, individual learning versus cooperative learning, where I try to compare both learnings to check if agents can create a cooperative behavior or not. So I think I should start by explaining what individual and cooperative learning are and what are their differences. So individual learning is the learning we are used to. Each agent is responsible for its own knowledge of the environment. Its actions and rewards only affect him and his knowledge. The cooperative learning consists in allowing the agents to share knowledge. In this work, this knowledge sharing is done by making all agents having the same knowledge, like a hive mind. This means that the actions and rewards of one of the agents will contribute for all agents. All agents that use this cumulative experience will use it to decide their actions. For example, in the case of Q-learning, all agents will share the same Q table, but they will their rewards will only affect their action. It should be point out that the environment stays the same and gives the reward to each agent depending on its action. Okay, with that being said, the main goal of this work is to discover if this approach to cooperative learning could create cooperative behavior between agents, while in individual learning, it would usually create a competitivity between agents. The theory behind this approach is that on an environment where agents can affect other agents, the policy will tend to maximize the reward of all agents, since all agents are affecting the shared knowledge. All the rewards received by them will be received by that shared knowledge. But to test that, we need an environment where agents can interact and affect negatively other agents in a negative way. Okay, so in terms of state of the art and literature review, by my understanding, the majority of the research done in cooperative learning is focused on obtaining the cooperation between agents in diverse forms. The most common we see is cooperation by considering as the reward of the entire system. This means the output of the system. This means that the agents will try to shift their policy to maximize the system output and sometimes even ignoring their own interests. Some works also try to create cooperation by making the reward received by all agents the sum of the rewards received by all agents. This means that agents that perform actions that impact other agents negatively, a negative way, are going to receive a negative reward because of it. There is also many works that create cooperative agents using communication, either by sharing rewards, sharing environment states, or even experiences. Some works do this communication centralized with one agent handling all information, while others do it decentralized, like, for example, a football field. Others also do it by making complex data structures such as graphs. There are also many works that focus on the exploration and exploitation in cooperative scenarios. They make use of the extra communication to maximize the exploration in the environment early on. This means that the agents try to communicate and say, okay, I'm going to explore that, so you can explore the other way. So about the simulator. Simulator is responsible for starting all the agents, environments, the logic behind the setup of the parameters and the logging the results. It allows the user to run either one or multiple simulations. Once multiple simulations is used to make the agent learn by multiple iterations of the environment. Well, a single simulation is sort of testing the learning created by the multiple simulations, so we can pinpoint what is happening more correctly. The agent state can be saved to use later. In its base, the simulator is an agent-based simulator. This means that it has a queue of events to perform, and when the agent is free, this means he does not have any more events to perform. He decides upon an action and creates more steps for the queue to perform. Okay, so about the environment. The environment has two positions, the farm and the workstation. The farm is responsible to have crops which the agents will need to survive, while the workstation will give a constant reward for the agents that work there. The environment has information about the agent's positions, whether it's on the farm or on the workstation, the current time of the simulation. The simulation itself has a certain time that for the agents to execute actions. For example, when they go to work, they take, for example, 10 units of time. Crops take time to grow, so there is a time thing on the environment. The environment also stores a farm state, which crops are growing, which crops are grown already, and which slots are free on the farm. It stores the agent states. The agents have a state that is the food reserve. They can reserve food. They have saturation, which is responsible for their survivability. They also know which crops are theirs, so they don't steal other crops. And the environment steps, because the environment needs to know that. The agents receive, however, from the environment 6 values. They receive the free space in the farm, the crops ready to harvest, the position, the crops that are growing that are theirs, the saturation, and the reserved food. These are the 6 elements that best describe the information the agent needs to know to decide upon a good action. So what the agents can do is perform 4 actions, which are usually linked to positions. They can eat food anywhere. They can either eat on the workplace and on the farm. And what this does is it reduces the food reserve. They eat the food, right? And increase their saturation. The saturation is important because it's something that decreases over time. And if it reaches 0, they die. They can also work at the workstation, as I said before, and receive a fixed rewarding, but they take time. They can plant crops at a farm, which after growing can be harvested and increasing the food reserves. Changing positions on the environment also takes time, which makes the act of going to work and receiving a bigger reward more costly, and perhaps more efficient. For example, work multiple times and then going to the farm. So in terms of learning, unfortunately, only Q-learning was implemented correctly. Other reinforcement learning algorithms, such as the deep Q-learning and the Monte Carlo policy improvement, were tried, but they didn't work correctly. Not sure if it was a bad implementation. The Monte Carlo policy improvement did not work because how hard it is for the environment to explore, and I'm going to explain this later. But this reinforcement learning also did not work correctly with a restrictive environment. I did not talk before, but this environment is restricted by the amount of places in the farm. So for the agents to survive, they need to eat food, and to eat food, they need the food, right? So they have to plant the food. If they do not, for example, if one agent occupies more than 50% of the farm, the other agents will not have enough space to plant the food they need to survive, so they will die. And that's how the agents affect each other. So this implementation did not work correctly with a really restrictive environment. It works with a smaller restricted environment, but not enough to try to compare the cooperation that exists, to corroborate our hypothesis. And both the cooperative learning and individual learning performed use the same reinforcement learning, so they could be compared. So why does the learning is not so trivial in this environment? On the first place, it has a great number of states. As I said before, the agents receive 6 parameters. This is not a problem on neural networks, but for tabular states, it's something that increases exponentially. So it has a really big number of states. Currently, it has 600 plus states, and this is after discreting the environment a lot. So it also has a problem that different states take different efforts to reach. So if we put the agents performing random actions, they will not reach all states quite far from it. So if we give all the same chance to all the actions, they'll, for example, never reach a good amount of food reserved. They will never reach a good amount of saturation, etc. And they will die quite soon, quite fast. Also, performing actions on certain states does not guarantee to reach other states. This is because other agents are also affecting the environment, and this can change the state while we are performing an action. And there's also the existence of impossible actions. For example, the agent cannot plant if there is no space in the farm, the agent cannot harvest if there is no food to harvest, and the agent cannot eat if he doesn't have food. Okay, so in terms of results, this is the results of the Q-learning with a slightly restricted environment, which did not affect that much, I believe. So reward over time over simulations completed, that is this graph, is the average reward on the end of each environment iteration when using the time of the simulation. So as I said, reward over time, basically. As we can see, it starts on negative values. This is because of the impossible actions. In the start, the agent performs multiple impossible actions, and we can see that it starts to increase slowly. The green, the orange color is the cooperative learning, and the blue is the individual learning. As we can see, it improves way faster using cooperative learning. This can be explained because cooperative learning has multiple agents learning the environment, which makes the converging way faster. It also, this value is not 0, by the way. This value is 3 or 3 point something. This means that the agents do not perform impossible actions, but can also work at a reasonable amount of times. In the individual learning, we can also see that they improve quite a lot. The fact that this is at the end and not like a line is because I cannot see. Okay. It's because at the end, the time of the simulation takes a lot of time to run. So these last simulations wasted 10 times more than all these simulations. So that's why. This is on top. Okay. So as I said, the cooperative learning is faster than the individual learning. About the total reward over simulations completed, as the name explains, this is after a simulation, the total reward the agents receive. We can see that it also starts on the negative values, and then it reaches close to 0. This is not close to 0. This is a trick in a sense, because at the very start, the agents take a long time to die. So they accumulate lots of negative rewards. So after a few simulations, they will reach almost 0 time alive. So they do not accumulate that much total reward. But as we can see, they also have perform a lot of impossible actions. The reason for this straight line here is because, as I said, in cooperative learning, the policy is shared. So after they converge and the epsilon in the epsilon greedy policy reaches 0, for the cooperative learning, the policy becomes deterministic. So they all perform the same actions. They all do the same thing. While in individual learning, it still continues to continuously learn. In terms of average lifetime, the max is 100,000. It's a time limit I gave, so otherwise it will go to the infinite. It survives on a loop, right? And we can see that the individual learning and the cooperative learning both learn to survive all the time. The standard deviations of actions done is basically for each action, the difference between the amounts of time they are executed for each agent. For example, if both agent 1, 2, and 3, and 4 perform the action of eating 50% of the time, the standard deviation will be 0, right? So that's the difference. If it will be like 0.2, 0.3, 0.4, 0.5, it will be a big standard deviation. As we can see by the values, the action with lowest standard deviation is usually the action of eating, and is the only action that we can see that the standard deviation decreases. The standard deviation of the cooperative learning after the epsilon reaches 0 is obviously 0 in everything. As I said, it's a deterministic value. But as we can see, eating, it starts to decrease both in individual and both in cooperative learning. This means that the agents learn that they can eat on that specific times. They do not do it more, basically. All the other actions are still a lot chaotic and cannot be, we cannot extrapolate anything from them. So to conclude, were not able to corroborate our hypothesis because we cannot check if the agents were in fact cooperative. They learn faster, but the fact that they have they reach a good policy and less chaotic is because they became deterministic. But we can see that as it was expected, the cooperative learning is learns way faster than individual learning. As I said, the environment was not that much constrained. If it would be more constrained, this wouldn't happen so much, right? Because they would have to reach its break-even point to survive the longest possible. Okay, and then an effort still needs to be made to improve these results and reach our intended questions.
Thank you very much for your presentation. Professor Augusto Sousa, do you have any remark?
My first thing is about time. You started by 5:23, and it is now 5:43.
My bad.
So the double of time. It was 10 minutes or 15?
It was 15, I think.
15, okay. So 50% more. Be careful, Tiago, okay? Be careful.
I didn't start the timer, so I did not.
In a serious conference, the chairman will cut your speech. I saw that before, okay? I'm a little tired, I must confess. So I didn't understand the most of the presentation, but it is my fault also. It is my fault. I'm getting tired at the end of the day. So let me see your presentation. You started immediately with the introduction. You missed the agenda slide saying
the index.
An index, summary, agenda, overall, anything that help the person in the audience to imagine what is coming. Okay. After that, you made an introduction and we speaking about individual learning and cooperative learning. So you are defining the main target of your presentation. After that, motivation and objective. And you went to the state of the art. Until now, I have seen no hypothesis. However,
the hypothesis was on the objective will be if cooperative learning would lead to cooperation.
Let me say one thing. In the conclusions, you mentioned that you were not able to confirm your hypothesis. Okay, if you say this, you must have an hypothesis at the beginning. At the end, you cannot
explain
say
better that was the hypothesis.
You should say my hypothesis, this one,
okay.
And you write the sentence of the hypothesis. Okay, my research questions are this, and at the end, you will be able to confirm or not the research questions and the hypothesis. Okay, Tiago?
Okay.
After that, the state of the art was, in my opinion, too general, without deepness. It was, well, we have this and that, and without references, without classifying methods, without, you should say, we have this method that do this, we have that method that do that, we have that method that do that. And finally, we can compare or something. You were too general,
okay.
Too general public, let's say, and we are in a specialist audience. Okay. After that, you explained your environment, the agents, the tasks, eat, work, plant, harvest, and you said learning. Why isn't it so trivial? And I would like to discuss a little more about this. Do you have 5 seconds to speak about that? Why
Sure.
learning is not so trivial?
Okay, so I can repeat. As I said before, we have a
Do not
big...
repeat after. Try
Okay.
to use other explanations. A few words, short sentence, without repeating again. Try to
Basically,
summarize.
I had some really big problems while making the agents learn, and these 4 reasons were the ones that while I was implementing the learning, I fall on. It were the walls I fall on the most. Great number of states, especially the impossible actions. I was mismanaging how I worked with them. I use them like I consider that when they perform this, I give a negative reward. Sometimes it even ended in deadlocks, where the agent was always deciding the same action because they couldn't do any of the impossible actions, and basically these were the problems. Why?
Okay, we need to, just to say this, sometimes we have to go in deepness, explaining with all the details. Sometimes we need also to answer in an overall answer. Okay, your state of the art was only high view without details. Here you entered perhaps too much detail, and it was also confusing. So we have to balance, and sometimes a good strategy is to start with an overall view and go in deepness in some parts of that overall view. Okay, it's a good strategy to pass the idea, to pass the image of what are we presenting. Okay, conclusion. Okay, to finish, let me say that some small problems with your presentation. Slides without numbering. If I want to say go to slide number, okay, I can. Okay, yeah. Slides without numbering, slides with too much text. Impossible to read this and listening at the same time what you are saying. Okay, also with slides. One thing that you used and in Portuguese abused, that was going forward and going back to the slides. Okay, go forward, go back, go forward, go back, and it gets difficult to follow where you are. Okay, sometimes it's difficult.
It's because it was hard to place everything in the constant flow. Because sometimes
you have to think the good strategy to present your ideas, but a sequence of ideas, and try to avoid. Sometimes it is necessary, as we saw in that graphic, and you go 2 or 3 slides, but once only, and you repeat it many and many and many times. Okay, this is not nothing good. Another thing is you need to train your assertiveness. You look not too much assertive. You have to look more convinced about what you are saying. Okay?
Okay.
Try again. I told this to other colleagues of yours before. This must be trained. Okay? You have to make many presentations. Do it with your colleagues, do it with your family, do it. This is trained to make yourself more how to say in English, in Portuguese is mais à vontade, more speedy in presenting things. We saw some colleagues of yours that were too fast, but you were too slow. We must be in the middle, okay? Okay, and I'm done. Thank you very much.
Thank you.
Thank you. Just one final question from the audience. So, to plant crops, did you define an action for each free-farm plot or a single action to plant a crop on the closest plot available?
Yeah, it was a single action on the first crop available. The positions are actually only two positions. There were not cells. They were not cells. They were just single positions, farm or workstation.
Okay, thank you very much. Unfortunately, our next speaker is not available at the moment, so I think I'll pass to Tiago Costa.
Yes, yes. Thank you, Tomas. This was a good session. Let's get an applause as well, right? Okay, well done, well done. So the plan was to have now a break, but I would suggest differently, since we are late and we had a paper, one less paper in the last session. So I think we can start with the next one. And this is about artificial intelligence applications. Our animator is Ricardo Gomes. So Ricardo, are you ready?
Yes.
Okay,
Tiago,
so move on.
good afternoon again. So we are having this last session on the CI. There are three papers to be presented. The one from Abdurreza Alavi Garabach, I hope I say the name correctly, Tiago Mendes Neves and Vahid Hajil Hashemi. The first one would be Abdurreza with a K-means wavelet neurofusion method to forecast the number of road accidents, a case study of Karaj Kazvin Highway in Iran. Abdurreza, are you around?
I think not. He's not here.
I don't think he's here. So
just please give me give him a second, okay? He tried to join us. Just please give me a second.
Sorry. Can Abdurreza do his presentation after Tiago?
Yeah. Tiago. Let's make it with Tiago Mendes Neves with discovering soccer strategies through reinforcement learning. Tiago, I hope you're there.
Yes, I am.
Okay, so the stage is yours.
Confirm me that I am indeed sharing my screen.
Yes.
Yes.
Okay, so I will start my presentation now. My presentation. Hello, I'm Tiago Mendes Neves. My presentation is about discovering soccer strategies through reinforcement learning. Okay, so I will present the work that was done in two PhD courses, one modulation and simulations, and another in multi-agent systems. In this work, what I developed was a novel soccer simulation environment that attempts to model the soccer game from a different point of view. Also, we will try to use reinforcement learning to discover new strategies in this environment that I implemented. And at last, we are going to evaluate if the strategies found by the reinforcement learning algorithm are valid or not. Before starting talking about what I did, I will start talking about what's the motivation behind this work. Simply put, reinforcement learning has been an area of research where in the last half decade I've seen a lot of success. And a lot of this success is that it is able to solve some games that revolve around decision making at a level that is above human level. This means that humans are not able to compete with these artificial intelligent agents. but for this they need enough computational resources and time to train. One of the opinions of the players that face these reinforcement learning agents, and this is an unanimous opinion from what I researched, is that these agents are getting the edge because they are innovative. They find new strategies that the opponents are not expecting. This means that they are not simply faster. This means that they can have faster reaction times and stuff like that. No, it's because they have better strategies than humans. One quote from the CTO of OpenAI, which is a company that develops a lot of these applications, says, "We see this happening in test games all the time. The bots do action X, and the humans laugh, and then the humans lose." This is elucidative of what I mean by innovative approaches. Sometimes they are unexpected, but they produce really good results. And so why not replicate this approach in soccer? The main problem when applying this to soccer is that reinforcement learning requires a suitable environment for learning. If we do not have the environment, the algorithms cannot learn the new strategies. This is easy when you use simple games like chess, because we can replicate it 100% accurately using software. And when you use computer games, because, well, they are already in the computer, so it's easy to extract data from those games. There are also some environments for soccer, namely computer games and stuff like that, but they generally fall into one of these categories of problems. Either they attempt to model human behavior, and human behavior is very complex and predictable, and each person moves in a different way, which means that they are adding error to these differences. They are computationally expensive. They have complex control mechanisms. Regarding the game of soccer, you have to control 11 players. So this demands some nuances that are not usual in this kind of problems. And also, usually these environments are made for business purposes, and this means that sometimes they prioritize other decisions that are not realistic from the simulation point of view. Now, describing the environment, we needed to build an environment, but this is a very complex task. The solution that we found was to try to build the environment using machine learning and data to model the environment actions instead of building the rule set by hand. This means that you are replacing the biases that human programmers would introduce in the game with data biases that exists in data. This is very easy to build the models, it's very easy to build the environment, and it also guarantees us that we can tailor our environment to the problem that we want to solve, which in our case will be useful for later applications. The data that I use follows this type. It's event data from Opta Sports, follows the Portuguese League from the season 2017-2018, and we can see a small filter of data used there, and this is the subset of data that was used to build the simulator. Talking a little bit about the environment. The environment only has to follow the ball. It does not follow players, and it does not follow any other agent, only the ball. And the ball has one coordinate, or rather two coordinates, the X position and Y position of the ball. And also the state space also includes some other variables that give us information about the previous action that I think influence the actions that occur after that. And we also have the action space, which are shots, pass, and dribbles. And if we choose to pass or dribble the ball, we also need to say which coordinates are our target to move the ball to. Here we can see the maps that indicate probability of success in each of the actions. We use deep learning to build these models and Optuna to tune the hyperparameters to build these models. So, for example, in the left side, we have the probability of scoring from this position. This means if the spot is darker, a shot from a darker place will have a higher probability of scoring. a shot from a lighter space will have lower probability of succeeding. On the right side, we will have the passes from this position marked in orange, and the same thing, darker places, higher probability of success, and lighter places, lower probability. The dribbling follows a similar pattern. This is why I didn't choose to show it here. So the environment is very simple. We start from a space or a state, we choose an action. If the action is a shot, the environment ends and the agent gets a reward. If the action is a dribble or a pass, it can either fail and the environment ends with no extra reward, and if it is successful, then the agent continues in a loop and chooses another action until it chooses to shoot and gather its reward. Here I'll replicate is one use case of the environment. I replicate some famous goals in famous competitions of national teams. And for example, we can obtain a lot of information from here, even though it was not the goal of this project. But if we have a sequence of actions, we can obtain some statistics, like, for example, how many shots we would obtain from, in this case, 10,000 runs, and how many goals would result from these shots. So the last thing we need to set up for having a possibility of using reinforcement learning algorithms is to build the reward system. In the reward system, what we do is we have a reward for every shot that the agent makes, and we give that reward with we reward that with the probability of scoring. This is for the general purpose of learning. We want to learn the algorithm to learn that he has to score goals. This is the main objective. Then we have some other auxiliary reward systems. This is, we give a tenth of the expected goals from the shot, from the end position of a pass or the dribble. This is to help the models train faster, because you are guiding the models towards the goal and towards the positions that have high probability of scoring. And then we add the fixed rate, because if you are before the midfield, the probability of scoring is 0, so we need to give a little bit of reward there. Also, we penalize every action that is opposite to the direction of the goal. This is simply to avoid infinite loops of high probability actions that will lead to the agent sitting there and not obtaining the result wanted. And finally, we penalize every time the agent goes out of the pitch, because it's the rules of the game. For reinforcement learning, our algorithm adds 2 requirements. Our environment also adds 2 requirements. It adds continuous state space and continuous action space. There is one algorithm that is able to face these problems. That is DDPG, which is Deep Deterministic Policy Gradient, which is simply an extension of DPU networks for continuous environments. Essentially, it's an extension of DQN, uses the same tricks, replay buffer, and target network, but adds one little detail, which is when it attempts to calculate the best actions to use, it has a target policy network that handles that case. First, to obtain our results, we establish a baseline using manual control of the simulator, just to get some baselines to compare our algorithm. And the best we obtained was using a wide short strategy, which is using short passes in wide areas of the pitch. And we obtain reasonably amount of 0.056 reward per each instance. And DDPG managed to overtake our best approach and obtain nearly 0.1. This means that it is not exactly this, because we had other components in the reward system, but every 10 attempts it is able to score a goal. Exploring a little bit more the results, here we see a plot where we see in orange area where the agent prefers to pass rather than other actions, and in blue side where the agent prefers to shoot rather than the other actions. You can see here that the agent does not address the dribble action, perhaps because it finds that the high risk, high reward component of dribbling is not better than the low risk, low reward component of passing. Therefore, it prefers to use passes over dribbles. One critique that we have over the environment strategy is that the zone where it shoots is very, very small. This means that it's probably picking up some biases in data, which mean that passing towards the area in blue is easier than what it should be, because else it wouldn't be attempting this strategy this much. This is the area when in a real game it's usually covered by the keeper, so it perhaps has some biases that we need to address in the future work. Also, when addressing the direction of the passing actions, we can see that the agent tends to avoid the wide areas of the pitch. We can see in both sides that the passes and the actions usually point towards the inside of the pitch. This means that probably it might have been because the penalization that we give every time the agent goes out of the pitch might be inducing him to avoid it at all costs, leading it to have this kind of results. When it is in the middle, it simply advances to the goals. When regarding the length of the passes used, I didn't find anything of relevance. The length of the pass is independent of the place on the field and is usually a short pass equivalent to the length of the big box. So, discussing a little bit of the results, the agents are able to find some simple rules. They do not move out of the pitch. They avoid going backwards and go towards the actual goal. It ignores the dribbling action. Maybe removing the dribbling action would be good because it is adding unnecessary complexity to the environment, and it's actually leading to the environment taking more time to learn. Continuous variables, it didn't learn them in a proper way. For example, when choosing the best action, it was easy. It learned it very well. But when was choosing how long would be the pass and where to pass, the action was not so good. And also, we need to be careful in taking conclusions about this because the algorithms have a lot of moving parts, the environment, the algorithms, the reward system, and they need to be carefully checked because they might be biasing the results that we obtain. Concluding, there is potential in the approaches that I present. They need to be carefully as designed, namely the environment, because we remove human biases, but we add data biases, and we need to fix those too. Reinforcement learning is one solution, is promising, but we need to keep addressing other state-of-the-art techniques that can solve the problem that I propose. And a third and the last, which is more of an advice to my friends at the conference, which is I knew that there was an OpenGym API that is widely famous, but I chose to not follow it in the beginning because I was just making experiments. And when I tried to test reinforcement learning algorithms, I had to implement reinforcement learning algorithms from scratch because my API wasn't compatible with the OpenAI implementation. So I urge everyone to take into consideration when implementation these type of solutions to use the API so that it can interact what already exists in the literature. Regarding future work, very simply, the information that I had about the soccer actions were represented by the place where the pass starts and the place where the pass ends. I didn't even have the information about surrounding players or the target player that received the ball initially, where it was initially localized. Nowadays, there are becoming widely available more information about the details of these event actions, and I can start to take into consideration more factors like, for example, the positioning of the opponent player. So the references, they are the same as the paper, so feel free to check them in the paper. And if you guys have any questions, I am open to answering.
Thank you, Tiago. As all the colleagues have done, I would ask first Professor Augusto for a review on Tiago's work. and then we can go to some questions that are available.
Okay, Tiago, again, the first slide with the agenda of your presentation would be welcome. You started by the 3 topics that you have in your work, the main 3 topics. Okay, it's good. After that, the motivation and explaining, comparing with other games where reinforcing learning has been used also. The social environments have some difficulties, and you mentioned some of them. And I believe that human behavior is the most difficult one to model. And you mentioned this because the same person in different situations get different decisions in different but similar situations. He can take different decisions, and it takes difficult to model. However, from the title and from the beginning, I was thinking that you would talk about some team strategy, but from your presentation and from now on, I just concluded that you were speaking about only the strategy of one player. Is this true? And I believe that finally, in the final part of the presentation, you mentioned that you didn't have data from the other players. Is this the reason that you don't have a team strategy?
Yes, one of the advantages that I pointed towards this approach was that I can tailor the environment around the data that I have, but this also has a problem that is, if I don't have the data, I cannot address this problem with this approach. And what the professor said was actually, it's true. I do not take into account the information about the opponent players. And these has some implications on what we can extract from this kind of environment.
The opponent players and the same team players also. You don't have their positions, okay?
So what I have is a map that says if you are in this position, the best action normally to take is this. But of course, you need to read where are your colleagues and stuff like that to know where to pass the ball.
In that slide, Mente. In that slide, the blue area is not symmetric. No. And after that, in slide number 15, exactly, there is no symmetry on a horizontal axis at the center of the field. And I was expecting that a symmetry could happen. Why don't we get a symmetry on those possible directions?
I think there's a better image for this, which is these ones. These ones are the maps of probabilities from which the environment goes and search for what probability will I use to attribute to this play. And we can see exactly what the professor said, which is these maps are also not symmetrical. These maps were built from data and were built from data from only one season. This means that sometimes there is some instances where, for example, a player, the probability in this area is close to 1%, which is not true. But there were some goals in that specific season from that place which went in for reasons, it's probabilities. They went in when they shouldn't, and they are giving a higher probability in this area that should not be there. So the difference that we are seeing in figure 15, in slide 14, is the model by the data that was inputted to build the models in here, in slide 8.
Yes, actually, in this case, yeah, you are right. You are right. Even the image on the left is not symmetric.
Yeah.
I'm noticing now that we have some gray pixels on the top right, and they do not exist in the bottom right. Yeah, that's right. That's right. Okay, it's and this is data that is collected from an entire year league, isn't it?
Mm-hmm.
Okay, so we have to train our players, our real players, to use also the left side of the field.
Yes, probably, or train their left foot because they're more.
It can be a good strategy for a team, no? Because the others are used to the other side.
Yes, there are better approaches to evaluate what Professor is saying right now rather than my strategy. The goal of this was to find novel strategies and not to find optimal solutions for data that we already have.
Okay, I'm convinced that, and I followed by more or less. You didn't mention a good state of the art again. For a scientific presentation, I was expecting, especially in this area, I was expecting a good state of the art, what others are doing about this, and I didn't see this. For the developments, okay, you mentioned that graphic, I don't know, slide number 10, perhaps, the fluxogram with the steps of your strategy, slide number 9. So it's more or less understandable. It's also understandable that you have reward systems and including penalties also when the players are coming back to their side, etc., etc. So I was just expecting a little more from this because my initial idea was team strategies, not one player strategy. But okay, this is what it is. Thank you, Tiago. About the presentation, yes, it was okay. Slides are good in size. In size, you have slides numbered. From 1 or 2 slides, you have too much text. Perhaps you could use only keywords instead of complete sentences, but it is not too dramatic. Okay, it's not too bad. Okay, thank you, Tiago.
Thank you, teacher. Tiago, we have some questions for you pending here on Slido. I would ask sorry to the authors, but in order to get the time to be manageable, I would just pick the top selected question and the other one from another author. So the first question is, Tiago, do you have an explanation for the horizontal asymmetry in the direction map of the DPG, slide 15? Could it be due to most players being right-footed?
Yes, this is one of the possibilities because they have a tendency to play with the stronger foot. And if you are on the left side of the pitch, playing with the strong foot will lead you inside. If you are on the right side, if you play with the right foot, you go outside. So this is one of the possible explanations. Also, we only have 18 teams in Portugal. So this might be due because those 18 teams have similar patterns in those areas, and the algorithm is picking up these biases.
Yes, thank you for your answer. And the next question is, have you considered the hierarchical architecture with max entropy for reinforcement learning, I guess, to integrate expert knowledge through reward shaping to support the modularity of policies?
I used some strategies to incorporate some human knowledge to accelerate the search space. Because, for example, I know that the players only should shoot when they are close to the goal. So I do not attempt actions that are really far away from the goal. But that method in specific, I did not try. I used warned startups on the algorithm that I used.
Okay, Tiago, thank you. I think we are going to the next colleague to perform this presentation. I would ask Adoreza if he's on.
Yes, hello.
Yes, Abdurreza, please.
Sorry for my problem. Now I'm ready to present.
Don't worry. Don't worry. The stage is yours, and good luck.
Thank you so much. I want to share my screen, please. This screen, I think. Okay, I need again. Sorry for. Okay. Hello, everyone. My presentation is about a K-means wavelet neurofuzzy method to forecast the number of road accidents and a case study of Karaj-Qazvin highway, a main highway in Iran. My name is Abdurreza, and my colleagues in this work are Wahid and Professor Tavares as my supervisor. The agenda of my presentation is first, I explain about road accidents as its importance, then about problem statement, related work, challenge of my work, proposed method, autoregressive model, AR, autocorrelation function, partial autocorrelation function or PACF. I explain about wavelet transform, narrow fuzzy systems, then I define my case study and result and discussion. And final part of my presentation is conclusion. Road accidents is important in any location, in any country, in any area, because drivers is important, cost is important, safety of the road is important. And in modern world, we have many cars, many humans that use cars. So the safety of the road, safety of transportation system in cities, in outdoor systems, between the cities is more and more and more and so important in any of the world, any country in any area. The role of technology in this safety and managing road accident, decrease road accident is so important because we can use technology to reduce the accidents and to decrease it. As problem statement, forecasting the number of road accidents is very important. But we have two aspects of this forecast. We can try to forecast in short time, for example, weekly or monthly. We can try to forecast the number of accidents in long time, in the year or in a period of years, because we try to manage road planning and rules in a long time period. Many factors can affect the road accident. Human is the main parameter. Time, for example, daytime or nighttime. Climate condition is so important. Geographic information, the situation or type of road is important. And human as a driver is the most important, the main important of any road accident. Related work for forecasting the number of accident or road accident, work on some topic. As example, stochastic modeling of road accident and defining main factors or main parameters of accident in different roads. Time series modeling, because road accident is a time series process. Multivariable systems because road accident is a many multi-variable system, is a dynamic system, and machine learning methods that is very popular in any forecasting system or scheme. The challenge of road accidents that is very hard this topic is uncertainty of any accident in the road is very general and intrinsically obvious that we have uncertainty in accident. Human as a very dynamic parameter of any accident and complicate variable that affects road accident. In a proposed method, we try to combine some well-known methods and define a novel method to forecast in long time road accident in Iran because unfortunately Iran is one of the bad countries in road accident. I think my country is the first or second rank in the number of accidents in the roads that is not acceptable and is very bad, unfortunately. In my proposed method, we used a wavelet enhanced narrow fuzzy scheme. We at the first step we collect data from Karaj Qazvin highway because we should forecast based on the location of the road. This is a very main road in Iran, as many of cars and transportation system need this road to transfer passengers. Split each location data of the road using time windowing. This means that I have time windowing based on the location. Is a two-dimensional separation of data. Define or make an AR autoregressive model for each window. Compute autocorrelation function, mathematical function for each window, and partial autocorrelation function in each window. Then apply k-means to autoregressive and autocorrelation function that use them for clustering my data. Use wavelet transform to each group of data. For each group, I train a narrow fuzzy classifier for each cluster, and then using each cluster, for each cluster, I use narrow fuzzy model to forecast the number of accident. I don't know why. Okay. Using this proposed method, we have some main steps: autocorrelation function and partial autocorrelation function, autoregressive model, and k-means method as clustering, and finally narrow fuzzy system as my forecast or regressor. Autoregressive model is a time series modeling. We're very popular in each time series modeling. Using this model, we can predict output using older output. We can define a number of features for predicting that you can see in my formula, and using the number of observations, we can predict the output with a specified error. But this type of modeling, because a simple way, has many errors in forecasting. Using autocorrelation model and partial autocorrelation and autoregressive, we try to find some parameters of accident, and using these parameters, we define some clusters by k-means method. In fact, k-means as an unsupervised method using autoregressive model, autocorrelation, and partial autocorrelation function separate similar conditions, similar time windows to each cluster, assign each of them to one of our clusters, and after that we can extract some pattern using wavelet transform. That is a very good method in dynamic time series such as accidents. After that, we train a simple narrow fuzzy model to forecast the number of accidents. We have some known parameters in narrow fuzzy models such as match-predictive criterion and minimum believable level that we can easily define these parameters using trial and error. My case studies, Karaj-Qazvin Highway. I searched this map in the Google, and you can easily find it in Iran. My data is among 2014 and 2018 years before COVID-19, because in COVID-19 the number of trips is very decreased, very reduced, and usually the number of accidents decrease, but is not usual, and we should define our model for normal conditions, not the conditions such as COVID-19. I plot the number of accidents per month. You can see the high number of accidents in this road in Iran, but you can see two different pattern of accident, because in before about 18 months we have many accidents, but after that the government of Iran approved some rules and try to decrease the number of accidents that you can see it in the plot. Using autoregressive model, I can find an approximation number of accident that is not acceptable, because you can see some errors in this plot, and this error is not acceptable for us. After my clustering and applying wavelet transform to time series window data, you can see the pattern of approximation coefficient and detail coefficient of wavelet. You can see the approximation coefficient is very similar to detail coefficient in each window, is good for training narrow fuzzy system. And finally, I defined 4 different clusters using k-means, and for each cluster I define a narrow fuzzy system. You can see some predicted value for my test data in this plot, and see the approximated low error that show the acceptable accuracy of trained narrow fuzzy system. My narrow fuzzy system parameters that set in MATLAB software, and I try to compare the result of my method to some of the state-of-the-art methods, but because the database of these methods is different to my database, I applied these methods to my database and report the results for convolution neural network that published in 2019. Mean absolute error, that is a standard criterion in this manuscript research, is about 3.4. For balanced bagging approach 2020 we have about 2.62, and finally in my proposed method in my database my MAE is about 1.73. That is lower than state-of-the-art methods result on my database. That shows the accuracy of my method is acceptable, is better than these methods. As conclusion of my work, the road safety is so important for us. I suggest a hierarchical scheme for forecasting the number of accidents. My method is so good because separate a zero accident window from other type of window, and I can define some different models for different conditions. I use autoregressive as a non-ravish, well-known method. I define autocorrelation function and partial autocorrelation function as two good method from related work, and using a combination of autoregressive ACF, PACF, and wavelet transform, I can suggest a good machine learning method, hybrid method, to forecast the number of accidents in roads. That is so important for any government, for any area. As suggestion for future works, I can suggest LSTM or GRU as two well-known deep learning methods, but these methods need many data for training that I can't find this data in the internet on public data sets, and we can analyze risk factors in different clusters. In my work, that is so important in managing road geometry and road planning or rule planning in transportation, and find some different risk factors based on time, based on location, and try to decrease road accidents using these risk factors. And thanks for your attention.
Thank you, Aldo. As before, I would ask first Professor Augusto for a review on Aldo's work, so we can go to the questions, please.
Sorry. Okay, Aldo, I will start with the title. The title is like a train, is long. You know what I mean? You should shorten the title. The title is too much big, in my opinion, too much long. If you remember those ideas that Professor Carlos Soares told in the initial classes of this course, the length of the title should be moderate, and it is not in this case. It is too long. Your agenda, next slide number 2. Yes, slide number 2. I was afraid for the time. Okay, you actually you had 50 minutes. You spent 18. Okay, it's more than the time. But when I saw this agenda, wow, we will spend half an hour for this presentation. Okay, it was not the case, but it is a long agenda. Try to concentrate a little more with other presentations. After that, you went for your motivation, the road accidents. You also made the problem statement, tried to forecast the number of accidents. And you mentioned several things that are in the problem: short-term provision, short-term forecast, long-term, climate, geographic information systems. I remember that you put that in your slide. And I believe that actually you did not use this information later. You only use the information about time of accidents and their position in space.
Yes, I use time and geographic information actually, and I can't use climate condition because my database have not
does not have it.
type of it. Yes,
this would be a big improvement if if possible, because I believe that climate is one of the big responsibles for accidents in roads.
Yes,
when
yes,
it is raining,
exactly.
First days of
Rain or
rain,
snowy
wind.
conditions. Yes, yes, yes. But I can't access this data.
But are you using geographic information systems?
Yes, yes. I use GIS as a simple traditional software in this topic. In my windowing, in fact, I divide road to some different parts. Each part has about 1 kilometer length, and use this windowing in my clustering, because the road geometry, for example, turns can be very affect the accident.
You mean curves of the road?
Yes, yes, yes.
But geographic information system will refer information that is geo-referenced. You know exactly.
Oh, no. I want of the manager of data in Iran, the police of road, to give me detail about turns or a straight road or other detail of the road. They use a GIS-based software to define some different part of the road, that some of these parts can be increase the probability of accident. And for example, the straight road is so good for driver, but in a turn or other.
How do you relate when you have an accident at kilometer 20 in the same road, have another accident in kilometer 25? How do you relate both accidents? Because you need this for your clustering.
I define a two-dimension clustering. I using time windowing based location. This means that I cluster using each location in each time. For this type, I can separate, I can define many clusters, because I have a tag for location and I have a tag for time. I use two tags for my clustering. That this means you can separate each location, each accident based on its time and its location.
Okay.
So increase the accuracy, because as you know, the location and road geometry so affect, very affect the accident, because it's so important for driver.
Let me go ahead with your presentation. After this, you mentioned the related work, but I didn't see any scientific work, scientific idea, any reference to others, to a paper, to a book. You mentioned only four titles.
Topics. Yes.
Only for titles, and I was expecting more than this, much more. Actually, after that, when you are speaking about your proposed method. You mentioned a series of techniques that you are using in the same application, I believe. And perhaps at least these techniques should be explained perhaps in the related work. Or
yes, for example,
alternatives.
AR model is for time series modeling, ACF and PACF autocorrelation and partial autocorrelation function is a subsection of stochastic modeling and multivariable systems. Narrow fuzzy and wavelet can be a member of machine learning methods. Each of these.
Now, this is all the set that you are using, but what are others doing in this special subject, forecasting accidents? If there is any other work, or work similar in other areas, not in accidents, but in other things. Okay, can you put slide number 10?
Yes, slide number
Thank you.
7 to 10. Okay, this is slide?
No, that one, exactly that one. I don't understand why there is a slightly decrease in the number of accidents in the middle of the year, of the time.
I asked from the police of the roads in Iran, what happened after 18 months that the number of road accidents decreased very, very
okay, this is real data. This is real data. Okay.
But I asked him what happened in the road. They don't answer me clearly, but it's mentioned that some of rules and some of road they repair some of roads. They try to install some of traffic assigns in some of locations that
okay, Abdurreza, my question is I believe this is real data, so I don't discuss the numbers, I don't discuss this data, okay? What I am discussing is the change there in the month number 16 or 17 was so strong that you are mixing, perhaps you are mixing in your study, you are mixing one condition on the left and the different conditions on the right.
Exactly, because I defined 4 clusters for my modeling. I think the clustering able to separate this strong difference between before 16 and after 16 months. So I think using 4 clusters for modeling and separating these forms help my method to forecast accurately the number of accidents. If I try to train only one model for forecasting the number of accidents, surely my error is so bigger than this paper. But
just to finish, I understand your point of view. Just to finish this part, supposing that after month 16, the decrease of the number of accidents is because of the COVID that limits the number of cars in the road, for example, this is an exceptional situation. And for the future, you cannot use this situation because in the future, you will have again a high number of cars in the road. Do you know what I mean?
Yes.
We have here perhaps a special situation that is a temporary situation that can be a, let's say, an outlier from all the situations.
Yes, and at the it's exactly true. And at this situation, maybe one of my trained clusters surely useless because it's a special case and any other situation that clustered in this situation do not exist at the future. So one of my 4 clusters may be useless, but other trained clusters can cover the situation.
Okay, can you go for slides number 13 and 14? 13. Next, yeah, no, 13. Okay, 13.
Yes.
That's 12. Yes, that's it. Results and discussion. Neurophysics systems output versus real data. What is the real data here?
Real data is the reported data from my database, and neurophysics system that is predicted or forecasted road accident for this time window.
But in these graphics, are you showing real data in these graphics?
Yes, the real data is training data, and my predicted value is ANFIS output.
Okay. Okay, training, it's real data. Okay.
Yes, my training.
Sorry, misunderstood for my part. Yes. Okay, about your presentation. Your English is being highly improved. I must agree. I remember when you came.
Sorry for this.
And now you are much more fluent. You have more way to walk, but you are in a good way. You are in a good way, Abdulreza. About the slides, let me say that in some slides you used a small font that result very well here in Zoom, but whether or when projected, they are too small for a big room. Okay. And you had space. Can you put, for example, slide number 7? Seven.
Okay.
Big one.
Yes.
You see that slide, that font is so small and you have so much space. Free space that you could increase the font. I'm not saying that you have to use large fonts everywhere. No, I'm not saying that. But in this case, you could actually improve the font in this slide and other slides that you had in the same conditions. I'm done. Thank you very much, Abdulreza.
Thank you, Professor.
Hello again, Abdulreza. We just have a couple of questions here, depending on the Slido. The first one is why did you opt for k-means clustering over density-based clustering algorithms such as DBScan?
I don't understand your question, Ricardo. Can you repeat it?
The question is posed regarding your clustering task.
K-means.
Yes, why did you use k-means and not use the density-based clustering algorithm like DBScan?
I only need an unsupervised clustering method. I use MATLAB software from the toolbox clustering in MATLAB, and from some related work, I see that k-means in use in some manuscript about road accident for clustering, so I use k-means. Maybe other methods can be used as an alternative of k-means, but I use k-means and I have acceptable accuracy, so I don't change it, or I don't try any other methods for comparing my accuracy. It's only a simple idea.
Yes.
Only one choice, in fact.
Yes, we understood. Thank you, Abdulreza. And I have another question. This one is for myself. Because regarding your neurophysics system, did you perform any source of optimization on your parameters, or those parameters were the ones that fitted your data?
I use default parameters of MATLAB software. It gives me acceptable accuracy. I only change a little some of parameters, and check my accuracy, but I don't see meaningful change. So I use default value of the software, epoch number, initial step size, and I find acceptable result. It's based on trial and error, not any optimization method.
Yes, you understood. And the last one, sorry, Suraya, I'll just pose the first one just to keep the time on schedule. How is the data collection process for algorithms? Did you have some sensors to get them, or did you use another source?
I collect my data directly from the Board of Police in Iran. I don't use any sensor or other things. So I directly access to a database in police organization and give my data directly from it. I don't collect my data directly.
Okay, okay, I will have to. Thank you. Thank you.
Thank you.
Right now, I would give the word to Vahid to present the last paper for today, I guess. So, Vahid, as long as you're ready, the stage is yours.
Hello.
Hello.
Hello. So let me.
Okay. Go ahead, Vahid.
Please give me a second.
I can stop my share. Okay.
So can you see my screen?
Not yet, I guess. There is nothing happening right now. Okay. Okay, now pressing your screen. Please go ahead, Vahid.
Okay. Just a moment, please. Hello, everyone. Good afternoon. I hope you are all not feel really tired as a final presenter.
I
am. I'm sorry, Professor. So actually, I'm going to talk and explain about my article with title Automated Human Activity Recognition by a Modified Hybrid or Hybrid Recurrent Neural Network. Let me have some problem in here. Okay, so my outline is include the introduction of human activity. I will explain the main goal, related work. I explain some deep neural networks that I used in my work. And I will explain my proposed method deeply and introduce the data set and show the result and discussion related to my work. And finally, I will conclude all of these things for you all. So actually, HAR is a detection of movement or activity of people in environments, whether it is a complex or simple. So, simple like walking and complex like cooking, for instance. And we have two general type of the HAR, that is image-based and also sensor-based. The image-based, which can include image adapted from the camera, radar, infrared, etc. And sensor-based that I worked actually on it is a sensor-based. And HAR application is include smart city, medicine, security, smart home, and etc. And the challenges of my work is the high variety of movement, different type of sensors, and the camera variety of application, and to reach to the higher accuracy. So the main goal, or actually the hypothesis, is in this article is to increase the accuracy of the deep neural network or deep learning method in R, which we do by changing the learning mode. So the main goal in R is improving deep learning technique to increase the system accuracy, applicability, so and etc. But how and how I did is modifying training process and using of the new deep learning method in the fusion step, or optimizing the parameter and the layers of existing deep learning methods. So according to consider hierarchical structure on the peak in the right side, the several machine learning and the deep learning approach were used for R during the last years. And some of these approach use accelerometers. Actually, the extensive use of mobile sensors and smartwatch in the recent year has caused accelerometer data to be more notable in R. My work based on the information about the sensor in a smartphone, and most recent articles are categorized in two types of different methods based on my proposed application, that most of them are in the deep learning methods. In this slide, I show the standard neural network figure and also general flowchart of the temporal convolutional network, or in the abbreviation TCN, that inputs of this structure can be a sensor signal, for instance, as a one deep learning approach to action classification R. And the main stage, as you can see in this picture, we have a two main stage of the TCN, that is include encoder and decoder, and each of them done separately in the both part of train and test. These stages include the steps mentioned in this figure. So in the vanilla recurrence network, according to the review of the recent article, it has better answer than TCN, but it has one major drawback that I found based on previous study. In RNN training model, we use backpropagation, the value of which are based on gradient. Given the time lapsed in R is very important. Exponentially reduction of gradient values in this type of RNN in previous time and their ineffectiveness in updating the network leads to unintentional deletion of the previous information, which is the major weakness. And what does it mean backpropagation? To the remind of yours, is means returning the error from the output to the input in a completely optimal way and in order to the correct weight. In this slide, according to the review, to eliminate the RNN problem, TCN LSTM network is suggested, and traditional LSTM consists of the several layers, the use of which affects are pre-input to output. However, the problem which this structure, as you can see in the block diagram, is the lack of direct access to the value of the internal gates, which cannot be, for instance, reset if there is a problem in their training, for instance. TCN of the LSTM network has been proposed to eliminate the RNN problem. Traditional LSTM, including GRU, is actually an improved structure of LSTM. So the first, GRU is a simpler in terms of the number of blocks, and because it provides direct access. It does not have the problem of LSTM, and in some case, we can say GRU works better than LSTM, and generally in GRU, complexity of LSTM has been largely eliminated. Actually, I have used a genetic algorithm to find the best structure and the best values, and this toolbox is already available in MATLAB software toolbox that I use it for my implementation. And I will try to find 5 parameter that include epoch, dropout, batch size, learning rate, and hidden unit. As you can see in the figure, the first information as my proposed method, read by the sensor creates a feature map. Then this information enters the proposed network as a feature map, which include the following layer. I've tried to use of this structure to our data in 2 ways, information of the before and after, that it can be used simultaneously. The input of the genetic algorithm are network parameter, and in the total we have 7 network structure, which means that 7 different genetic algorithms for these structures. But these 7 structures are implemented separately, and the optimal parameter of each structure are found separately. In this section, we begin to extract the optimal value listed based on the GA that's described in slide number 3, as I explained it before, and result for each type of network that I will show in the next slide. In this, I applied to in this 7 type, I applied genetic to find all of these parameter separately and precisely. To introduce my data set as I use, the name of data set is Unimip share that include 11,771 record of 30 people and 3-second non-overlapping window. And this data set has include actually 4 tasks, and it's categorized between AF number 2, F number 8, A number 9. The difference between these tags is the different of situation and different of type of falling that include in this database. For best result for each of the RNN after optimization, as you can see, based on my category or classification of this database, I reached to the very good result based on my methodology. As you can see in the AF2 and the overall average, I can able to got a very good result and very good answer. For comparison with the previous method, in the recent article mentioned on the same database, it can be seen that the methods are better than the available methods in the average mode and very close to the reference number 47 in my paper in the AF number 2 mode. And for more accurate comparison of my work with the reference number 47, that was my basic and main paper as I implement and improve it, it should be noted that my idea compared to the recent article to the related to this idea, which are given in below, and I reached to, fortunately, I reached to very good result. So as a conclusion, I can say the GA found the number of position of RNN for the hidden layer, such as BI, LSTM, and GRU to optimize the harsh system. And my future direction, it's divided between 2 selected RNN and also selected RNN model or on more data set, and also analyze the effect of data augmentation technique such as Windows wrapping and Windows slicing on the system accuracy. Thank you for attention, and I hope that you are not be tired of my presentation.
Thank you, Vahid. Let's hear what Professor Augusto has to say about that and about your paper. Please, Professor.
Vahid, we are not tired of your presentation. We are tired of all the presentations. Okay.
Thank you, Professor.
Okay, let me see the time. 3 minutes more.
No, Professor, 14. I
sorry?
calculated. It was 14. 1 minute less.
Yes, okay. No more time than the given time. Okay, Vahid, the agenda was too long from my point of view, but you maintained the time of presentation, that's true. You started with an introduction, giving your problem, what is your intention to do? And you said there are mainly two solutions, image-based and sensor-based. What is the main goal and what is the hypothesis? Can you put please the slide where you have the main goal and the hypothesis?
Yes.
Okay. As a main goal, I accept this. Okay. As a main goal, improving data to increase seasonal applicability. How modify? We will try to improve. Well, should be written as improve deep learning techniques, modifying by modifying training process. But for the hypothesis, no, the hypothesis. The hypothesis again is a sentence. You are near the hypothesis in this slide, okay?
Yes.
But the hypothesis in this case could be, for example, it is possible to improve deep tech. Using. No, it is possible to improve deep learning techniques to increase system accuracy, applicability, etc., by modifying the training processes and summarizing the rest. Okay, it's a sentence. It is possible to do this using that, for example. Okay, this is an hypothesis. This is something, one sentence that you have as correct. Okay, and finally, during your work, you will try to prove that that idea is true, okay? But if you write an hypothesis, it is a good strategy in a paper at the end, in the discussion or in the conclusions wherever, it is nice to conclude the hypothesis is true, the hypothesis is not true, or we cannot conclude about the hypothesis. Okay? So I am just saying this because as a main goal, I could accept this slide, but because you mentioned hypothesis, no, hypothesis has a certain format, okay? It's a sentence. And you have, if you write hypothesis, if you write research questions, at the end, you have to check true, false, or we cannot say anything about it, okay?
Okay, perfect.
After that, you went to the related work, and you have been speaking about deep learning networks in several aspects. I cannot discuss this. Some slides have long sentences, okay, and it's difficult to read. Sentences about 3, 4, 5 lines. It's difficult. Okay.
Yes. Sometimes, Professor, let's say it's really I've tried to really some summation, but sometimes I think just speak, maybe it cannot convey what I mean to
bullets.
The audience. Yes.
Bullets.
Right.
Bullets.
Yeah.
Subdivide the sentence in several parts and use bullets. Okay.
Yes. Okay. Professor.
So after that, you went to the proposed method, slide number 10, perhaps. Yeah. Okay, you have a graphic. Okay. Looking at the left pictures and looking at the right pictures, looking at the beginning where you had pictures showing persons cycling, persons in different other activities, and looking to this, I see that you don't mention too much activities. Why? Are you concentrating only in some activities, or you are trying to make a solution, to develop a solution that is able to conclude about any activities? Cycling, driving, in the road, at home, eating, sleeping, you know?
Actually, the main goal of my work in this case, I'm trying to make a detection of the falling and not falling, not more. Okay, I'm trying to classify for the falling and not falling.
So is something being developed for elder people?
No, it can be include the elder people also, but the main goal it was to the detection of the fall and because the fall is it's not just falling from the, for instance, when we are walk, as you know, it's not just in the one way. We can fall in a lot of way for a lot of reason. So yeah, that is my main goal.
Okay, okay. Now I understand better this,
Thank you,
this
Professor.
part. What about data set, slide number 12? This data set is a public data set, or is a data set from your group?
Yes, it's a public, Professor.
Okay, and it's a complete data set for what you need?
Yes.
Okay, for the discussion, in results and discussion, okay, you presented here some numbers showing some methods. How can I say this? It is necessary to make some evidence of the advantages of your own method, okay?
Yes.
My method here is less time, is better accuracy, or reinforce this when you are presenting this type of things.
Exactly, Professor. Let's say Actually, you are completely right. But if I didn't explain more precisely about the result and to comparing to show the evidence, is just because of my time. And actually, I consider it in my paper. And if you want to check, or because I have a plan to also send it for after to complete and make it much more better than this to send for a journal. So, but you are right, and I explain it much more better than my in the slide in my paper. So,
okay.
Yes.
I don't have any more questions. Thank you very much. Perhaps the
Thank
audience
you.
has some questions for you.
Thank you, Professor, for
Okay.
your time.
Thank you, Professor. Wahid, we have some questions popping up here in Slido. The first one is in slide number 11. How did you decide which layers to use in each one? Do you think you could extend the genetic algorithm to choose the neural network architecture?
Could you please repeat your question?
In slide 11,
Okay.
how did you decide which layers to use?
Actually, it is based, I'm sorry if I interrupt you. I understand. I tried to find it based on try and error to find a good type. And that's
okay,
it.
of architecture. Okay. Next question we have were there subsets of the data set where your models had a much higher or lower performance on detecting people falling?
Which slide?
It doesn't ask for a particular slide. In the subsets of your data set,
okay.
Where your models, is there subsets where your model has a much higher or much lower performance on detecting people falling?
Yes, actually, as you can see in the AF number 2, okay, this is a type of just the type of falling and not falling. This is not with a specific situation. I reached to the very good result in the average, and also in the AF number 17, in the category of classify of number 7, I reach also to the very good result. And finally, according to this slide, I try to show the best choice as I reach according to my proposed method.
Okay, thank you. And now, sorry, Gonçalo, for the last question, so this doesn't get...
No, it's okay.
How much time was needed to train the networks, more or less?
Around 2 days.
Around 2 days. I think that's
yes.
That's a proper answer. And just a final one: was there a reason for choosing a genetic algorithm to set the parameters over simulated annealing algorithm?
Actually, according to my experience to implementation and well-known algorithm that I already did it, okay, and also teach it in during some heuristical models. I choose them because I have a lot of experience, and that's it. That's
okay, understood. So I guess this is the last presentation for today. I'll give the stage to Thiago. Please be our host.
Thank you, Ricardo. So well done. Let's applause. I think you have the right as well. All right, so guys, yes, I think that's it for today. Thank you for your patience and your effort and all your availability. This has been very interesting day with so much richness, scientific richness, I would say, almost overwhelming richness. Tomorrow is going to be a different day. Today we had 19 papers. Tomorrow we will have only 6, which seems good news at this time, right? And we will have in the afternoon also our special invited speaker that I just request your special attention. And then we will have some, I think, funnier activities in the networking. So we will be very happy to have you here again tomorrow. We start at 9:30 sharp. I wish you all a very good rest. I think you all need it. So see you tomorrow. Thank you.
you.